tell
Yeah,
me.
he can explain it to you in a minute, meme, but I want the fucking video, and I've been asking for a very long time. Please let him send the video, and then he can explain it to you.
Mame, you're also coming in a bit distance. I understand you're driving, buddy, but you're a bit like far away. Not coming in very loud.
Yeah, you sound pretty loud.
So yeah, Mick, if you can please send the link into the live stream and then just explain.
No, I'm just looking for it. I have so many videos that have the word reflective. I already posted it before, but I got booed. Oh, here it is.
Dude,
just post it when you get it, and then for me, because he's driving, can you just explain it to him? Thank you.
So Nick, real quick, where we post things, I don't know if you're familiar with this Discord, but there's a channel right under the live stream. It's called live stream. Oh, it's above the live stream. Sorry, it's live stream 1 voice text. You can drop it in there, and that's where it's, I just did.
Awesome. When I gave him VC verified, I explained that.
Yeah. So it's basically what I explained earlier, and it's showing that but you know, that's my garage, and it's showing the light bending towards cold and away from hot.
No, where have you measured this across the great distance we're talking about?
I used Dr. John's measurements. He posted it in his video, the temperature gradient. He actually measured it. I haven't done it. I'm using Dr. John's measurements. What's wrong with his measurements?
I'm asking you about Dr. John's measurements. I'm asking you about yours to prove that it is happening.
Well, I haven't done a long distance laser measurement like Dr. John measuring the thing.
You haven't done anything.
He has though.
You haven't done anything. Yeah, but what I'm asking
you haven't.
Is, where is your measure?
I've done experiments
that it is happening. It's just you saying it. It's just you saying it. It's just you saying it didn't account for something.
I think you're repeating yourself now. I think you made your point.
This. Can I ask a question now? Can I have a real quick question for Mr. West? Mr. West, please. So I heard your father was part of the Flat Earth Society, and I was wondering, is the Flat Earth is the Flat Earth Society like a bunch of globers that are actually going around trying to make Flat Earth look stupid, and how are you not part of it? You know what I mean? And what do you think of Flat Earth Society?
I tried to make you look stupid. And my dad just did it ironically. I think he did it in the 70s. He did it ironically,
but he told you that the other side needs to be done. That's what you said on JRE. Don't you lie. Don't you lie. You limey.
What am I lying about? I'm not sure what you mean there.
You just said he did it out of irony, but that's not what you said on JRE.
That's what I said. I said.
Well, I'm curious where your loyalty is. I'm curious
doing it as a joke.
I'm wondering if you're more, if you're a Flat Earth Society,
he's not going to tell you his loyalty, Bong. He's not going to tell you his loyalty.
Right, I'm just wondering.
Let's just break apart his fucking stupid experiment first, though. Let's just do that. That'll get him out of here. So let's get back to your experiment, supposed, right? So your laser, what's the intensity of that laser?
Well, it doesn't really matter what the intensity is. It's a visible laser. It's just a laser pointer. But it works exactly the same.
So right. It's more exciting. So you said you held it up to a flame, right? You're next to a flame. Is that correct?
Yeah.
Is that flame putting out more energy than that laser? You would consider at that point?
Probably, yeah. Because it's just heating the air.
All right, but can the
ice pack isn't putting out any energy?
Here's a question for you. Can the laser light heat air? Is that possible?
Not very easily, no, because air is transparent.
All right, so if you continue to increase the intensity of that laser, what will happen?
I'm not sure where you're going with this. Could you explain what your point is?
I'm trying to. If you can answer me that, what will happen?
What? Can I increase the intensity of the laser? No, it's a Logitech laser pointer.
All right, but he's
asking, what if you did?
Right. Exactly.
It wouldn't make any difference whatsoever. Zero difference.
Wow, you heard this guy?
Well, Mr. West,
It's true. It's true.
it's a problem because if you take the supposed globe and surround it with concentric rings of air layers, then you would have, say, a what you're trying to say is basically a warm layer under a cooler layer toward which the light refracts. Okay, that's fine. But over long distances, you're essentially saying that that light goes up into the second layer and goes back down into the first warm layer to hit the eye of the observer. That's a little hard to believe because that would have to be the case for the thing to go
I'm
up,
not sure what you're saying.
But he
So.
just doesn't. This guy doesn't understand lasers. There's no point arguing with him. He just doesn't have. He doesn't know what he's talking about.
It's got to go.
Here's the whole problem, guys. With his whole entire thing, he's changing with the experiment that he's doing. He's changing the temperature around it, right?
Exactly.
Okay, but what's going on at night with these laser tests is it's stable. It's not changing anymore. So we're not going to see this. This is the problem. You're inducing this refraction. This is not happening naturally because there is no mixture of air where you're having that huge change at night anymore. Literally, you're not having that much change. So guess what's not going to happen? The refraction.
But Dr. John,
Jesus Christ, this is why we posted that damn graph, man, that you're going to deny again.
Well, are you going to deny Dr. John's measurements?
This guy doesn't know it. He doesn't know what.
No, the graph he's talking about, Mick West, is I forgot who did it exactly, but it was a bunch of people that got together and they were trying to test the refraction. They tested it for about 72 hours, 3 days in a row, and they got the conclusion, I believe, that the most amount of refraction they got was, when was it, Reg, exactly, that they got the most?
The day is when you get the most amount of refraction, and in the evening and in the mornings, it drops off rapidly, and at night, there's none.
And that's why we have to match these conditions one for one, Mr. West. Otherwise, they have a theoretical sugar water abstraction.
And if you look at the reason why... Sorry, Lemon, hold on. If you look at the reason why, you'll notice it's the temperature difference, just like you said. The reason why, though, it goes and it bottoms out and it's nil is because the temperature in the air has already mixed, and now it is constant. There is nothing changing.
But would you agree, then, that you would have to measure the actual temperature gradient at that time?
They did take the temperature at the time they were doing the laser test.
They did do it, and they found that there was a temperature gradient.
But do you understand that there's different types of
Excuse me? Not at night, there wouldn't be.
They found it in Dr. John's experiment.
Hold on. Do you know that there's different types of lasers? Right? Do you understand that?
Well, sure, yeah. Different wavelengths, different ways of generating them.
And different kinds of Logitech lasers. What are different types of lasers used for? What can be the use for a laser? Can it be used as a weapon? Is that...
They used to illuminate things and they used to heat things. And they use for a variety of other reasons.
So why would a laser that's used to heat things be affected by what the fuck you're talking about?
Well, this is the thing with lasers. They're targeting devices. We can use lasers to point at shit and paint targets and say paint because that's what the military do. Now, military use lasers. Yeah, so military use lasers to paint targets over distances that should have to take into account the curvature of the Earth and now your light refraction. These are from vessels at sea. Now, it seems, with a little bit of research, that quite a lot of their ordnance and weapons that they use for the shit out of stuff requires a direct line of sight targeting system, up to and including about 100 miles. So if they can aim lasers at shit up to 100 miles away, that's got a direct line of sight and is directly in front of them from a vessel at sea, and the targeting device is somewhere about 40 foot off the surface of the water. Excuse me. So if that's happening, practical, everyday use, I think we're fine shooting lasers over 25 miles, right?
You wouldn't be shooting things that are at sea level because you wouldn't be able to see them.
According to you, but right now I've just pointed out, I said military, I should have said Navy. I did say vessel. I did give you a height of 40 foot above the surface of the water, aiming at a direct line of sight to a surface-based target. Now, this is 100 miles, it seems, with a little bit of research. Many of the ordnance they use require a direct line of sight.
I think you're probably referring to rail guns. I think you're conflating two different things.
No, I'm not. I'm actually not talking about rail guns.
All right, so post a link then.
Yeah, I'll go and get through. But what I'm referencing is military do seem to have lasers that paint targets that require a direct line of sight. at distances where Earth curvature and refraction should have to be taken into account.
That's great. Let's go with that then. Let's post me that evidence, and that will prove it.
Okay. I'm surprised you haven't looked into this before yourself, Mr. Mick West. You know everything about light refraction and what lasers do. We're talking about a test that's done over 25 miles, or one that's done over 10, or any other laser test or line of sight test that requires, like I just said, a direct line of sight. That's easy to understand light refraction. No flat earther is denying that light refracts through the medium of the atmosphere. Can it be demonstrated to curve around the curvature of your Earth? Not just a little box where you've got an ice pack underneath it, because we're talking about the majority and most conditions, depending on the air clarity and conditions of the day. Direct line of sight is required when shooting lasers at shit.
Oh, it's
can you hear me?
Yeah, line of sight is, but not a geometric line.
Yes, we can hear you.
So I want to put in my 2 cents about this. Like the experiment, that would be what you would consider a special case. That is not the general case of the atmosphere. So the basic claim of globe proponents is that the general case, generally, that air will refract light down because of the weather conditions. And that has not been demonstrated, right? Not been demonstrated in the environments that these tests have been done in. Now, of course, you can make a special case test. I think it was Greater Sapien did one over CO2 in frozen ice, right? So, but he didn't take into account that CO2 has a higher refractive index of air, and it's way colder than any environment on Earth. You know, so these are special case experiments. These are not the general case conditions that we find ourselves in. And I think like just showing that light can refract says really nothing. We all know light can refract. Okay?
So you got to look at the actual conditions.
Did it refract in this situation? And what do actual measurements and tests of refraction show?
Look at the actual measurements that Dr. John did. I can post them if you want. I've got them right here.
Mr. McWest, I have one point in your carriage test that is wrong, or I have a question for that. You said that in warm air, it's
just
not
posted the temperature readings of Dr. John, by the way, if people want to check out them. Sorry, but carry on.
Okay, in your carriage test, the laser.
I'm sorry, like you said. Oh, my garage test, right?
Garage.
Yes.
Sorry, my English.
Garage.
The laser starts in warm air.
Yeah.
Like maybe 20 degrees Celsius in your garage.
Yeah.
And it goes nearby the ice. And it goes into the colder air. Maybe, I don't know, minus something. The ice was
probably like minus 20, minus 15, minus 20 or something like that.
Exactly. Where does that happen in nature? That your laser starts from a warmer temperature and goes through the colder temperature when you point it across the lake.
If you're on the shore of the lake, then the air around you is say like 90 degrees.
How many degrees
Fahrenheit
difference is in the where the laser starts?
What you need actually, it's quite interesting. You only need about 1 degree of difference to curve like over the surface of a lake. It's quite interesting just how little of a temperature gradient, because the gradient it's not really the amount, it's the amount per meter. So if you've got a gradient of say 1 degree per meter, that's actually a huge gradient. But because it's very close to the surface of the water, you get this very, very steep gradient just at that point, which is why you have these issues with the lasers, and it's why you also get this very thick line of compression at the bottom of images just over the horizon, because closer to the water, you get this steep gradient.
Okay, so I'm looking at
which is what Dr. Don showed.
Yeah, well, he didn't measure at 2 meters. He didn't measure at 1.5 meters. He didn't do his measurements at 1 meter. He did them at a single elevation, right?
No, it's this 5 measurements there. Oh, sorry, 4 measurements there. Above the water, 0.5 meters, 1 meter, 1.5, and 2 meters. And the difference between above the water
those are the measurements
is 1.5 degrees.
The elevation that he did, the laser was at, the laser itself.
No, it doesn't matter there, because at some point the laser is going to be skimming the surface of the water.
Listen, it does matter because this is a vertical chart, right?
So either the laser's got to hit the water, or it's going to skim the horizon.
So I think
so if it's skimming the horizon, that means
so this chart is vertical. He didn't shoot the laser vertically.
Correct,
he didn't cross this gradient.
No, it shoots when you go along the gradient. What happens is that the light bends towards the more dense, the air, the colder air in this case. This is something.
There's some boundary. There's some boundary.
No,
right?
no. It's actually a very difficult thing, and it took me a while to understand.
I mean, this is all theory, dude. Like,
no,
when it comes down to it, like, where's like the data sets that actually show this happening? You took an extreme case, 70-degree Fahrenheit, going over, minus 20 Fahrenheit. I don't know what type of environment that is in nature, because I don't know of it ever existing.
It's an extreme example because it's hard to show, but Dr. John's own measurements
just said it was easy. You just said a 1 degree temperature difference will show a significant amount of refraction.
Over that distance. It's hard to show in my garage because my garage is only like 40 feet long.
1 degree, right? So say you have 1 degree per meter difference. Okay, so you shine a laser 15 kilometers. That's 15,000 kilometers. Or 15,000 meters. So if you have a 1 degree difference, it's 15,000 degrees at the other side.
No, it's the vertical temperature gradient. It's again, it's like a difficult thing to explain
if you're crossing the vertical gradient.
No, that's the refraction. Look up a thing called gradient index optics. There's a difference between light going from one medium to another and light going through a medium where there's a gradient. It's actually a very different type of thing. Light, even like you know about Snell's law, and the amount it bends when it goes from air to water. Now you think if something was shining parallel to the surface, there would be no bending. And so you think that if something is shining like at right angles to the temperature gradient, intuitively you would think there'd be no bending, but there actually is, because a light actually bends towards the more dense medium. It doesn't matter about if it's actually going into a more dense medium; it just bends towards it because it's not actually a line as such. It's actually a wave front. Light is a wave, so it will still bend down, even though the temperature gradient is only vertical.
So
it's
a
kind of
portion of the
confusing.
cone, a portion of the wavefront will go to the medium, and another portion won't. Right?
No, it will.
This is layers, right? This is 4 layers. I'm at 1 meter, so I'm just going off his little data here. This little data set from John D. So say the laser's at 1 meter. He's shining exactly horizontally. Now, and we assume that from the target from the source to the target, the laser is always at 1 meter elevation.
Yeah.
How is it crossing into the 1.5 meter?
It's not. That's the thing. That's the fascinating thing about it, is that it doesn't need to go.
I'm asking you how it's done. How does that happen? I know that there's beam divergence, right? So there's going to be spread. A portion of the wavefront is going to spread out and go higher and lower. But the centroid of the beam is not going to. That's not going to happen.
Light is like a wave.
Right?
No, it's not. No, it's not. Light's not a wave. Wait, light's a particle.
Right, it's a particle that acts as a wave.
No, it doesn't. Particles don't act like waves. Particles act like particles.
Well, water is made of particles, and water.
Yeah, but light isn't. Light is made of particles. Light's not water. You false equivalence fallacy, knucklehead.
Water is made of molecules, which is
light is made of particles. It's not water.
And
clown show.
It acts like a wave.
Photons are particles.
Act like waves.
They don't.
Stop screaming.
Why do you get like interference and things like that then if they don't act like waves?
Yeah, QE. Look, dude. Okay, we're talking about something else entirely, dude. And you come in here wanting to talk about waves and particles. Look, dude, you're not going to interrupt the conversation and take this in an entirely different direction. McWest, continue talking about refraction.
All right, so yeah.
He was it is relevant though.
Hold on. He's got something.
Mick made a claim. Mick made a claim.
From ray optics to wave optics, right?
Huey is refuting his claim that he made as part of his argument.
That light acts like a wave, which it does.
No, it doesn't. You can keep on saying it, but you're wrong. To refute light as particles, you have to refute the photoelectric effect, number 1. Number 2, Compton scattering. Number 2. Number 3, Heisenberg's uncertainty principle. You ready to do that right now?
I don't think any physicist would argue that light does
any
not act
you
like
can't
a wave.
speak. Objection, Your Honor. You
Okay,
can't
QE.
speak to any physicist.
Dude, if you okay, QE, if you don't,
let him go.
no.
Thank you.
So,
Question and answer.
Say again.
Dude, QE, stop yelling. Okay.
Hey, shut. Who are you? Who's giving me instruction?
First.
Who's giving me instruction?
I mean, for the sake of conversation, like, let's try to keep it civil. You know.
Hey,
like,
Indio, are you in here?
What?
1 second. Indio, are you in here?
I'm in here. I'm taking care of it. Just chill.
Okay.
All right. So, can I carry on?
No, you can't. Just wait.
Okay. Right. Yeah.
Yeah, because you sound really stupid.
Yeah, because just like when you stop Living Bird when he says something wrong, QE is doing exactly the same thing. So don't get mad about that. Or Mick, sorry, Mick what?
What is a science communicator, Mr. West? Because you are a science communicator, and so is Neil deGrasse Tyson. What is that?
Someone who popularizes science and explains it to people, I guess. It's like
stupid people, right?
You don't even know what science is. What's up?
No,
wait a second.
Yeah,
He's a science
you don't even know what
communicator.
lasers are. What the fuck is wrong?
Wait a second, folks. He's a science communicator. Do you even know what a scientific hypothesis is?
Asking me what a scientific
Yes, I'm asking you. I'm asking you. What is a scientific hypothesis? What is an Let's keep it simple. What are the three constituent? Hold on a second. What are the three constituent parts of an experiment?
Well, off the top of my head, I don't know. Like, I guess.
And you're a science communicator?
Yeah, but this isn't the type of science that people want to be communicated with. I mean, you have like, the variable, you have the variable, you have hypothesis.
I would
wrong.
Hold on. I would argue that communicating a scientific principle is different than communicating a scientific experiment.
Wrong.
Science
Everything,
is the method.
the whole basis of the scientific method is based on experiment.
That's why, like, Dr. John's experiment was actually a pretty good one.
Dr. John didn't perform an experiment. He even told you that. Now let's get back. You didn't. You're a science communicator, and you don't know what a friggin' experiment is. You'd fail 5th grade general science.
Well, I don't think that's really relevant here. Like,
he is also an expert on debunking on what chemtrails.
Would you stop changing
You're an
the
expert,
subject, please?
But like you talk about, like
he
stuff
has
like dependent
dedicated
variables.
his life to debunking and making conspiracy theories look stupid. I just want to know what is.
Hey guys, Bong, let's stay on topic. Let's not switch it up.
So we got two subjects on the table. One, you don't know what the hell light is. Number two, you don't know what an experiment is.
No, I do know what light is.
No, you don't. It's not a wave. It's a particle. Now,
acts
if you
like
want
a
to refute
wave.
that, listen. If you want to refute
he
that,
has to appeal to physics, to physicists. He's not going to answer.
What physics?
Why
oh
are
my
you
God!
Because you are not qualified to answer the question, Mick West. Because you are paid, so you're not qualified to answer that question. Am I right?
I'm not paid. No one's paying me.
So you have to appeal to physicists, right?
Bloke who's
So you
got an
can't
idea.
answer the question.
Why are you asking me questions?
All right, listen, let's deal with this right now. Richard Feynman, Nobel laureate physics. The first thing Newton believed light was corpuscular. Turned out that it had very strange properties from that point of view, and it was then explained that many of these strange properties was because, in fact, it was a wave, which was wrong. Turned out he was right. It was a particle. Richard Feynman, lectures on quantum electrodynamics.
Wave. Yeah, I know. It acts like a wave.
It doesn't act like a wave. Particles aren't waves. They don't act like waves.
Can someone mute him for fuck's sake?
Yeah, QE, can you stop yelling like a fucking kid, dude?
I'll tell you what, brother, Mr. Kid. Let's meet up, man. Me and you. Who said that? Who said it?
I said you should be muted, you fucking.
All right, you know what?
All right, hold on, guys, hold on.
Yeah.
Hold on, everybody. This is what's going on. Hold on, everybody. Look, we got a bunch of the people that hate QE in here interrupting. All those people are getting muted because literally I'm trying to hear this discussion between Mick West and QE and everyone else. Kind of let them go at it for a while and stop interrupting. Please.
Yeah, I'm going to pull over up here. I'm going to go ahead and ban everyone who's been interrupting QE like that because I know y'all don't like him. Okay, congratulations.
From the chair of physics at Yale, Professor Shanker, everything is really particles, all things, electrons, photons, protons, neutrons, they are all particles. So let there be no doubt about that.
Of course, yes.
Clown show.
Agrees with that. I'm not disagreeing with that. I said it acts like a wave.
That is horseshit.
It's demonstrably true.
It's okay, demonstrate it.
Well, constructive interference, for example.
Oh, here we go.
A wave. The wave function is not a wave. It's a mathematical construct. You're talking about the wave function, not a physical wave.
So Young's slits, the Young splits experiment.
Young splits. It's not a split. It's a slit.
I know slits. Young slits experiment.
Yeah.
Demonstrates the wave-particle duality of the nature
There
of
is
light.
no wave-particle duality.
Well, the experiment seems to disagree with you.
Oh, really? Professor Shankar, chair of physics at Yale. So we have to play this game in two waves. It is particles, but its future is determined by a wave. But the wave is purely mathematical. You cannot put an instrument to measure the energy due to that wave. It's a construct.
You can see the effect.
It's a construct. You're mixing up the concept of a wave with the wave function.
If you can see it.
Misplaced concretism. It's reifying something that isn't real into something that is real.
Reifying the wave function. It's not a physical reality. It's a probability amplitude of possible outcomes. That's all it is.
Exactly.
There's no physical reality.
Exactly.
But you can see it, though. You can see the effect.
You can't see it.
Young slits. It's visible.
Right now.
Someone posted.
I can see the green codes falling down like Neo from the Matrix.
Okay, but let's not yell and hurl insults, man. Just for the PR.
From the University of Tennessee, in one dimension, wave functions are often denoted by the symbol psi. They are functions of the coordinate x and the t time, but psi is not real. But a complex function does not have real. See, don't rumpus me, you clown. You don't even know what an experiment is.
You're denying reality. You can actually see.
Kiss my ass! I just pummeled you. Pummeled you.
Are you denying that you can see the effect of Young slits?
Oh my God! But the wave function itself has no physical interpretation.
There's a physical interpretation. You can actually see
the University of Tennessee, the professor of physics at Yale, Richard Feynman, and now we got Mick pseudo-fucking West telling us the opposite.
All right. Well, if you want to deny the evidence of your own eyes...
Deny the evidence? Fine. Bullshit. You don't have any evidence. You just got clobbered, and you already denoted... You don't even know what an experiment is, Mick.
Wikipedia.
You want to know what denying the evidence of your own eyes is, Mick? It's looking at the sun and the moon and thinking that they're different sizes. That's denying your own eyes.
This guy doesn't even know what an experiment is. He doesn't even know.
It's weird. It's a little weird that you don't know what an experiment is, and you just said that you teach it.
The thing is, like,
science. You don't know the parts of an experiment.
The vernacular of an experiment is just something that you do to test or to demonstrate a hypothesis.
Yeah, but you need things in this test to conduct it, right?
Oh, you don't. You get the idea that you need a dependent variable, an independent variable, and control.
Idea, that's a scientific method. Yeah, we get that idea from the scientific method, and we're trying to demonstrate cause and effect relationships without personal bias.
No, he said you
can demonstrate very simple things, like you say, does light does it act like a wave? If it acts like a wave, then if you did a double slit experiment, there would be constructive and destructive interference, and you do the experiment.
That's a wave function for the time.
It's something that actually happens, though. Does it?
What's
does
a
it happen
function?
or not?
happen.
What's a function? Hold on a second. What's a function? Hold on a second. What's a function, mech?
In what context? A function is it's basically a mapping of one variable through a mathematical operation to another,
It's
like a
a
sign.
mathematical construct. It's a function, a complex function, mech.
Okay, let me ask you a question. Is this QED?
You ain't asking me shit. You don't even know what a hypothesis is.
Hey, Quantum.
You don't have to know all that stuff. You can still do some decent experiments.
We're on the same side of this fence. But I realize it's like sometimes you have to realize when you're dealing with people that are trying to disprove like
controlling with just like that.
Jedi, you hear me, right? It's like you start to realize.
I hear you, mate. Yeah, I get you. But come on.
These guys came here to try to prove to us something that we can prove ourselves with math and logic and science. But at the end of the day, we don't have to start to get upset or like get rivaled or triggered by that.
Yeah, but they're pretender clowns.
Sure. Oh, I already know.
He's just doing his job.
At the moment, what we're doing is we're talking about light and it acting like a mathematical model. Now, a mathematical model isn't real, is it?
It doesn't matter if it's real. When you drop an apple, it acts like the mathematical model of gravity.
See, that's exactly what I just said. I just said that. I was like, that's like fucking Neil deGrasse Tyson saying, "This is gravity drops the mic." Are you serious? Is that it?
Bong, I'm on.
Is that all you got, man?
But I'm trying to say, like, at the end of the day, like, if we're on this side of the fence, we should be sitting back in our chair and chilling. Like, we don't have to sweat them.
Hey, you should be.
Like, we have to let them fucking sweat because we already know we've done the math and they haven't done the math. So,
Done the math?
I don't give a fuck what
Done the math?
Yeah, done the math.
Bring Neil deGrasse Tyson here, West.
Okay, Mick said he doesn't have to have independent and dependent variables in an experiment, right? He just said that.
Well, it depends what type of. If you want to have a strict interpretation
Penn State University. Let's go through these. Can we go through them, Mick? So we have Mick that says you don't have to have Mick.
Yeah, but
can I speak?
You don't have to be frustrated by guys that are just talking shit, trying to fucking waste our time.
Can I speak, please? I'm gonna refute Mick.
Go.
Pseudo McWestian 2 space. I'm gonna refute him right now. Are we ready?
Space. We live in 3 space.
Not according to your friggin' fairy tale gas model, but I digress. We'll get to that in a moment. Experiment. You said you didn't need Mick. You said you didn't need a dependent and independent variable in an experiment, right? That's what you said?
For the common understanding of what an experiment is.
Yeah, I got you on tape, so that's what you said. Here we go. Experiment, Penn State University. There should be 3 categories of variables in every experiment. Dependent, independent, and controlled. The Institute of Physics.
That would be great.
That would be great now, wouldn't it?
That's just one definition of.
That's okay. Let's get another one. Institute of Physics. When planning an investigation,
you're giving the same definition.
Please shut up, Mick. When I'm pummeling you, please shut up.
You're just going to keep doing the same thing over and over again.
Yeah, I'm going to keep refuting your dumb ass.
I'm going to take control, John. Going to take control. If you're just going to turn around in a minute and say, no, I'm just going to keep over talking you, then that's not helping the conversation. Just let him finish. I'm sure he'll finish much quicker if you stop interrupting him.
Yeah, right? But I know he's going to do the same.
Don't even appeal to me. Next person to speak is going to be John. He's going to finish, and then you're going to answer.
Institute of Physics. When planning an investigation, students need to identify the variables that they consider significant and then select the ones they want to look at for cause and effect. If possible, any other variables that will affect the outcome of the experiment will need to be kept constant during the investigation. The variables are independent variable, dependent variable, and controls. Anne-Marie Helmutstein, PhD, Biomedical Sciences. When you design an experiment, you are controlling and measuring variables. There are 3 types of variables in an experiment: controlled, independent, dependent. Is that enough yet? Do we need to go a little further for you, Mick?
It's fine by me, because I already said that. That's one useful definition of an experiment, scientific experiment. Yeah. I mean, it's the type of thing that Nathan Oakley likes to go on about it. Because when people talk about an experiment, they don't necessarily mean that very, very precise thing.
Doesn't matter what they mean it in the colloquial sense of experiment, just the broad umbrella experiment.
we were talking about
like,
scientific communication.
When I meet a girl at the bar, I want to experiment.
Scientific experiment.
Science.
And you're saying you don't need the IV, DV, and the CV. That's what you're saying.
I think that if you're trying to communicate science, those are not useful concepts to discuss with the general public.
What the experiment and breaking it down into a very easily formulated method of where your dependent variable comes from, your naturally observed phenomena, and then how you build your hypothesis.
Generally,
you're answering the question of what causes that. So there's your independent variable, and then obviously you've got to control shit. So there's your controlled variables. You then got to take this forward in your experiment and test your hypothesis. Without these independent variables that are very easily explained, if that you just hand away from away in an experiment. It doesn't involve something that you're trying to manipulate to prove a cause of an effect.
Right, and the gold standard is basically that when you change something that you know is the cause independently, since you're independently changing the variable, you get a dependent variable that acts in accordance with your hypothesis to prove with as much proof as possible the causal relationship. And you have controls in the experiment that shouldn't change. If the experiment is properly controlled, all the factors have been factored, and nothing weird is changing in the experiment. If one of your controls changes, well, then perhaps there's another explanation you haven't explored or controlled for. Take with gravity.
Let him answer. Let him answer because hold on. Calm down. He said that you didn't need an independent or dependent variable in an experiment. I provided many citations here that said the opposite. Let him answer, please.
We're talking about scientific communication. And when you talk about things like dependent variables and independent variables and control groups, it confuses things for the general public. It's usually better simply to describe what the experiment does. You can keep that other stuff in the background as useful information. Like, this is why we need these things. We need controls. We need this independent variable. We need a dependent variable. But in terms of scientific communication, it's usually best just to describe what's actually going on and what it shows.
Nick, you baited. Nick, I'm sorry, I'm going to have to stop you. You baited and switched us. I didn't ask you what you were teaching them. I asked you personally, what are the 3 constituent parts of an experiment? And you didn't know.
I couldn't remember off the top of my head at the time, and now I remember.
Man, can I quote you? Can I quote you from Wikipedia? It all stems from a fundamental distrust of science and authority. Are you not trusting science and authority when you say those things? Like, you don't have to explain the variables. Like,
so you're quoting Wikipedia? Like, if you look at the Wikipedia
are these your words or not? Are those your words or not?
Which words?
The word on Wikipedia.
Which ones? Well, I'm not sure what you're talking about.
Read them again.
I didn't write anything.
Right. Yeah, just read them again.
It all stems from a fundamental distrust of science and authority. You are always going to get a percentage of people who are true believers. My goal is to minimize that as much as possible, to stop people falling for it and help them get out as easily as possible. What does that mean?
That is what I said.
So we're talking about the scientific method here, and we're asking for the variables, and you're saying, what are you saying? You don't need those, or what? You don't need to
I'm saying it's not productive. It's not productive for communication to the general public.
It sounds to me like he's describing atheists when it comes to religion.
But people asked me about science communication. They said, you're a science communicator. What is science? And I was trying to talk about it in the context of science communication.
Do you even know what that is? Do you even know what that is? Makes you a shell. That's such a corporate little turd term. You know that, right? I'm a science communicator. I'm a product communicator. I communicate what the product is. You're an advertiser.
I don't say I'm a science
communicator. I create synergies between.
You're an advertiser with a stick down your throat.
Well, propaganda is important even in science, saying proof for evolution or, proof of the God particle. Part of it is how you disseminate it to the masses to get funding and get support for your projects. But with gravity, we don't really have an experiment that's properly controlled to say we can tell that this is gravity versus, say, electromagnetism or something else. We don't even have proof that it coalesces things into balls for heliocentrism or makes orbits for heliocentrism extravagant claims. So that's why these experiments preferably would be properly controlled with some decent variables, and sometimes you have to revisit the experiments if you discover something after gravity's formulation, like, say, electromagnetism. Just to see if
we're getting off into gravity and electromagnetism. Hold on.
I think you're getting off into semantics as well.
Yeah.
Maybe we should get back to
semantics. Words mean things, Mick. So let's summarize. Yeah, words mean things, Mick. But let's summarize. You are a science communicator that didn't know the constituent parts of a scientific experiment.
Off the top of my head.
Fail 5th grade general science. Just to let you know. Okay? Thanks.
That's fine. No.
And light isn't.
Well, that's the general pattern. I mean, he knew what we were talking about in general. That's not what's important. What's important is the shape of the Earth, and these experiments that are used to undergird gravity. Light appear not to have been very well controlled, and so we may have bad theory, built on top of bad theory, built on top of bad theory, leading us to where we are.
You don't have bad theories, Lemon Bird. Just stop. There is no bad scientific theories. Scientific theories are validated, confirmed hypotheses. There's a lot of things that go under the term theory that are not scientific theories.
To the general public, the word theory and the word hypothesis are pretty much interchangeable. Sure, not for scientists.
Yeah,
for the general public.
Yeah, that's the problem.
That's scientific theory. Man. You're talking about colloquial theory?
That's intentional.
Or scientific theory?
Yeah, and this is why words mean things.
That's just you changing the meaning of words so you can weasel it around and make it mean whatever you want. And that's been intentional. And politicians,
how people use them.
Politicians have been doing that for a long time.
Really? What?
There's a word that we use quite often, just band it around, hoping it's going to do something that it probably won't because you can't demonstrate it. Refraction. Words do definitely mean things as well. Yeah, go on, let's get back to this bending of light and you tell us what light is. Let's go.
All right, excellent. So the problem is that, like, I brought up the idea that light kind of acts as if it is a wave.
Wrong. You're wrong, Mick. I just drug you through the friggin'. I just drug you around by the short hairs for 20 minutes over this. Okay, please tell me in the photoelectric context how light is a wave. Please, the floor is yours.
Well, what I'm saying is that it appears to act like a wave.
Appears is not reality. I just told you the wave function is what you're talking about. The wave function is not real. How many more times do I need to go through this?
I thought that the entire flat Earth thing was that appearances are reality.
Oh my God!
Can't you just know what you see?
Well, to be fair to Mr. West, the wave function is based off of activity in reality and is a close approximation, ideally, as possible. But it is a mistake to reiterate it as reality if it's math and numbers. It's a model of what we think happens in reality. That's all.
Let's forget this whole wave thing then. Let's just ignore that for now. Let's just go back to just observable refraction. Like you would agree that...
Oh, hold on a second. Are you talking about terrestrial refraction?
Talking about refraction as a physical phenomenon.
On Earth, you're using terrestrial refraction. Is that correct?
Oh, I'm talking about light passing through a medium and how the refractive index gradient affects.
Okay. Can you please post? Okay, I got you. Can you please post? Let me pull Discord up in the live stream. I want the formula for refraction, please.
Which one do you want?
Which one?
Because that's not the one that's actually applicable.
Which one? No, we want refraction, terrestrial refraction, Mick.
Ah, dear. So this is where we get into problems with science communication because it gets quite complicated. Refraction happens because of the refractive index slows down light. So light.
I don't want to. Mick, what did I just ask you for?
The equation of refraction. But so I guess if you want an equation, I've got to know what are the inputs to that equation and what's the output.
You're the one that claimed refraction, Mick. What, do you want me? It's not my job to support your claims. So please give me how they compute terrestrial refraction. That's all I want. We're going to evaluate the formula to see if there's any begging the question fallacies in it.
Right. So fundamentally, the refraction is governed by the speed of light in a medium. The speed of light in a medium is the speed of light in a vacuum divided by the refractive index.
No, it's not. No, it's not. You don't know this. Don't go into the speed of light, Mick. We want the terrestrial. Go to Wiki for fuck's sake. At least
That actually is the underlying formula for
It's a simplification.
refraction.
That's actually a simplification.
All right.
But we're not seeing light travel through a vacuum. So why would you invoke that? We're talking about here, right? There are no vacuums here on Earth.
What you're trying to yeah. Do you know what a refractive index is?
Well, the refractive index
unbelievable
travels through a medium, but we've seen 7.6R, we've seen 1/16 of it R or whatever or a degree. How about the one that gives the biggest amount of refraction? That'll help hedge in the discussion. How about the equation that gives the highest amount of refraction? Let's go to the limit. How about that?
We just want to see the equation they use for refraction. That's all I asked for.
That is the equation that you use for refraction. It's the speed of light divided by refractive index.
Where do they get the refractive index from, Mick? I want to see every variable in this equation. See, Mick, with equations, right? Every mathematician will tell you that every variable in an equation must be rigorously defined. I want you to post that friggin' equation right now, and I want you to define all the variables. You claimed it, you support it.
You're a programmer. You know that.
There's only two variables here, which is the speed of light. Well, it's not some variable, it's a constant. The refractive index is the only actual variable.
Oh my God.
Now, the varies based on the density of the air, which kind of varies based
Optical
on temperature
density.
and pressure.
It's the
and,
optical density, not the mass density.
Humidity. Yeah. The optical density, which defines the refractive index.
There's a square root of epsilon times mu.
So the refractive index
electric
curves around
permittivity
the
of free
globe
space,
perfectly.
and mu being the magnetic permeability of free space. So that's the actual refractive index. The values the values of vacuum is 1, and every other medium is set relative to that.
But I think the thing that's missing here is,
obviously.
I think the thing
that's actually pretty straightforward.
Yeah, hold on a second. I think the thing that's missing here is people are assuming that the refractive index is perfectly following the curve of the globe. Over 20, 30, 40, 50 miles is following perfectly. The refractive index within water or whatever medium that we're talking about is going to be whatever it is. But to assume that it's going to follow the globe perfectly all the way along at whatever distance we're talking about is ludicrous.
It's not what anybody's saying.
It's laughable.
Nobody is saying that. So you can laugh at it all you like, but no one's saying it. So you're laughing at ghosts.
So then at what point does refraction become a moot point? At what point?
It never becomes a moot point.
10 miles? Give me a number so I know, okay, refraction goes up until this point.
Refraction is always there because the atmosphere is always there, but usually you get extinction.
There's no demonstration.
It's actually
that it's always there.
It goes infinity. Give me some numbers so I can put my numbers to it.
The refraction you should have is 7 inches per mile squared. I think the max with 7.6R is 6.8 inches per mile squared. That's why it helps to put this discussion within certain boundaries.
That's a simplification.
Yeah, exactly.
I was explaining earlier.
The boundaries matter.
You have to look at
the boundaries don't matter. It's
no, they don't. They don't matter.
Let's put these things within boundaries. Where does refraction bend? How much does it bend? And to what limits does it bend? And if it's beyond the limits of refraction, if we're talking about something that's beyond the limits of refraction, then we shouldn't even be talking about refraction anymore.
We need to look in history for the greatest refractions in history, and let's put that down as the refractive index. Let's try that and put this thing within certain boundaries.
Exactly. Yeah. Well
that's not how it works, though.
Well said, Lemon Bird.
You have to use ray tracing.
Of course, that's not how it works. We don't understand.
Oh God, Ray! You still haven't answered my question though, Mick. Do you see the live stream?
Yeah, I see the chat. Yeah.
Do you see quantum eraser? Do you see my post right in there?
Atmosphere is curved, follows the shape of the Earth. Calculations below. Rough value.
Of course it does.
What are you asking here?
Well, I'm not asking anything. I'm showing you that terrestrial refraction takes into account the radius of the Earth.
Well, that's because the atmosphere is curved.
So, okay, so that's you have to prove that the atmosphere is curved.
Wow.
Prove the atmosphere is curved.
Can I bring up a point?
Well,
hold on a second. Let Mick prove that the atmosphere is curved.
We know that if the surface of the ocean is curved, we can see that.
Oh, so
we're not using refraction to curve the curvature of the
reasoning here, right? That's the only curvature you're about to find.
I don't know. You just said the atmosphere. Now it's the ocean.
Let's say it's not curved. Then let's say we don't know if it's curved or not.
Sure.
Everybody
knows that water does not curve. Everybody knows that.
What I was saying, Mick.
People know that.
What I was saying, Mick.
It's not actually true.
What I was saying, Mick, in the beginning when I said terrestrial refraction, I was trying to lead you to the definition and the equation for terrestrial refraction. As we can see, terrestrial refraction. I'm not done yet, Mick.
I know,
just one
I know
second.
what you're going to say. So
just one second. Oh, yeah, but this is for the audience.
Okay, go ahead.
What I wanted to say was I was trying to lead you to give us, because you claimed it, I just wanted you to support it. And as we can see, that terrestrial refraction is computed by already assuming the radius, i.e. curvature of the Earth. So to use that, you must first scientifically validate the radius of the Earth, and then we'll let you use your terrestrial refraction.
Yeah, okay,
so go ahead.
That's fine. No, that's not a problem.
Is that fair? Is that fair?
Yeah.
Okay,
yeah,
so
but we're not using refraction to prove the curvature of the Earth. We use Earth.
What are we using? Are we using measurements over land?
Okay, we've been talking about refraction all this time.
Yeah.
So why were we talking about So why were we talking about hold on, one at a time.
Cut that out. Timestamp it. 2019. Nick West. Someone quickly.
Well,
that's hilarious.
Okay, listen. He's under. Listen. He's under great stress. We're all pounding on him.
I'm not worried at all. We use observations that are high up that get above like the worst effects of refraction. So you stand on something like a cliff and you look at a distant mountain. So you're not looking too close to the surface of the ocean. Where you need to use refraction is to explain things like these laser tests or these mirror flash tests that go very close to the surface of the ocean.
Of course. So the ones that are actually measuring the ground of Earth, that's where we need
I just want to ask a simple question.
No, they're not.
What model of refraction can make predictions? Is like what you just said. That's a post-diction. That's the Earth is curved. I see this, therefore my model, I'm going to fit that observation to my model. As opposed to, I have a model, I see an image, and now I know how much refraction, and I'm going to make a prediction based upon weather conditions on what I should see and what I shouldn't see.
Yeah,
and
the assumption that refraction is going to follow.
That's a great question, and I have the answer.
Because there are hundreds of models of refraction.
Yeah,
you are aware of that, right?
Listen, I think the thing that we need to focus on is the fact that they're trying to assert the fact that the refraction is going to follow the curvature of the Earth perfectly without any fucking deviation is insane.
Hold on, guys. We're doing it again. Hold on, Mick. Sorry, one sec. We're doing it again, guys. Someone makes a point. Someone brings up another point. Now Mick has 2 points to address. Can you first address what model you what model do you use or can you use to make refraction predictions?
You use one that incorporates the temperature gradient, and then you use ray tracing to trace the path of rays through that through the medium. And the more detail you can get in the variations of temperature, the better. But if you simply do a vertical temperature gradient and then do ray tracing through that, you can predict what things will look like. And I actually programmed a simulator that does exactly that, which I can share the link with. Let me look it up.
Can you show it actual measurements or tests to validate that model?
Yes, I can.
Okay, so let's see them.
Well, you want me to actually? I did it with Dr. Johns.
I know they don't exist because I've seen every experiment on refraction ever done in the last 150 years.
The dog ate them, India.
Used Dr. Johns' numbers, and it came out to be like basically matching what he saw with his numbers.
Indio, he said he had scientific evidence of this.
On a curved.
Indio, he said he had scientific evidence of this. Can he give us? I'm sorry, Mick.
I'm still wondering how it gets sucked. Like it's sucked into other layers. I'm still wondering that. You got a vertical
that's
that's
what we were talking about earlier. That's a great question, and I love talking about that because it's something that I didn't understand myself at first, and I actually wrote to this famous refraction expert, what's his Andrew Young. He kind of explained it to me, but yeah, it seems like it shouldn't. If something's going kind of between the layers, as you say, it shouldn't actually get bent down, but it does because the
math says it does, or because it's observed.
No, you can actually demonstrate it. You can demonstrate it.
It sounds like we're assuming curvature.
I just want to see these demonstrations, dude, of these models. Right?
Well, the problem
models
is
that actually make predictions that are accurate.
Yeah. All right. Let me get my refraction simulator link up so you can see it.
Wait a second.
Wait, you wouldn't even give people data on your calculator, but yet you're gonna expect us to believe that crap? Really?
I'm saying
sending
there's
you
models,
a link.
right?
I've got
And
a link
reality, and we validate models by experiment, right? So where are the experiments validating the models?
Yeah, we want the hypothesis,
I know who A.T. Young is. I've read everything he's published, right? So I know who these people are.
Where at San Diego State University?
Use ray tracing. You're going to get a bend just from the nature of the equation, right? But that's just the equation. But that's fine. That's a model. So where's the actual experimental validations of these models?
Dr. John's experiment.
Controlled experiments.
Dr. John, hold on a second. Hold on a second. We already talked about Dr. John. Dr. John didn't conduct an experiment. He already said as much. You don't know what an experiment is. That's the problem. Hey, Indio, he said scientific evidence. Can you please have him post the natural phenomena? Go through the steps of the scientific method, please, Indio.
The natural phenomenon that he observed? There is
there isn't one. What's your dependent variable?
Let's see, the temperature gradient.
Of the Earth.
The temperature. So the temperature gradient. Hold on a second. Hold on. So I'm going to write this down, Mick, because I want to make sure that I got this correct.
Temperature. It's just what changes. Are you doing the changing or is something else changing based off of your changes? That's it.
Hold on a second. He said hold on a second. Hold on, people. Relax.
That's the dependent variable. Actually, will be the image itself.
So we're going from the temperature to the image now?
Get them mixed up. But it doesn't matter.
Wait, 1 second. So if I manipulate the image, what will I get?
No. If the temperature gradient changes and the image changes as predicted by the model, then that validates the model.
Mick, you have to have a hypothesis because a hypothesis is a scientific prediction. So we're only at the first step. Mick. 1 second. Now, the dependent variable, your observed phenomena, is now the image?
Yes, the image.
Okay, what's the independent variable?
I don't know. What would you give me an example of an independent variable?
He doesn't even know. The temperature,
oh my God, Mick! Thank you.
Just want to make sure we got the right terminology here.
Mick,
so the temperature gradient.
Mick, it's your experiment. You're asking me for the independent variable for your experiment, son.
Yeah. So somebody clip the temperature gradient varies. It has an effect, which is changing the image. So the hypothesis is that there's a model. There's the Earth is
every time you stop reifying shit.
It's over 5 dozen people in here.
We're already on a ball when this is happening, right?
This is a clown show, Mick.
The hypothesis? Wait, did you really just say the hypothesis is it's a model?
Have you seen my refraction simulator?
Let him describe it.
Hold on, everybody. Please let him finish. Could you please let him?
Yeah. Go ahead, Big. Go ahead.
Nick, I'm gonna have you over for a beer.
Cool. So the model. You want me to describe the model that I use?
No. Let's just summarize. Yeah. 1 second. You said the dependent variable was the image. The independent variable was what?
The temperature gradient.
Temperature gradient? Okay, give us your hypothesis.
That if you ray trace light through air that is curved, with the temperature gradient being like the same over every point on the curved surface, then you will get images that match reality.
So I thought you said the temperature gradient was your independent variable. In your hypothesis, I didn't see any temperature gradient being manipulated.
You would take two different temperature gradients.
No, you
can't manipulate temperature gradients because that's what they
then
are.
It's not a viable independent variable because your independent variable is number one, your cause. Number two, you have to vary and manipulate it.
You vary and manipulate it by waiting to a later time in the day.
Waiting. Very manipulating anything that's waiting.
So is this proof of time?
It changes.
Are we going to prove time? If your hypothesis is time, is that what we're trying to prove?
Let's say your hypothesis is that you can see better.
You can manipulate the
Does this have anything to do with the flat Earth?
God, he's Doctor Who.
Flat Earth, guys. All right, guys.
We have to.
Mick, thank you very much, sir, for showing what a complete imbecile you actually are. Thank you very much.
This isn't
That'll be
about
all for me.
Midwest. This is about the flat Earth. But we have to assume curvature. So it's whether or not there is curvature on the Earth. And so if we do not have reliable sources, say because NASA is lying, or because lenses are adding curvature, we may need to revisit the very basis of our hypotheses that we're, making these experiments off of.
Sure.
I think my simulator does actually fulfill the criteria for an experiment if you apply it to real-world situations.
May I ask a quick question, Mr. West? What caused you to join our server today? Like what?
I was invited by somebody. I can't remember his name. It's somebody flat Earth literalist. No, flat Earth level literalist.
Horizontal.
Thanks, Ben. I thank you for gracing us with your presence. Yeah.
Welcome. I'm talk about this stuff.
Did he
it's very interesting. I like the variety of feedback that I've got, and I know that you think that I'm wrong, but I would disagree. And I would encourage you to have a look at the refraction simulator because it's quite detailed, and it simulates a number of different things.
So
it even does lasers.
Does this refraction simulator simulate the distance with which refraction starts to divert from the curvature of the Earth, or does it just follow the curvature of the Earth all the way around 360 degrees?
When
does the refraction stop? Is my question.
It doesn't stop.
So it goes all the way around.
It doesn't conform. No.
So when does
look at it?
If it doesn't
look at it, and you'll see.
If it doesn't go 360, it has to stop somewhere, right?
It stops because of atmospheric extinction and scattering.
Okay, but where does it break?
Theoretically?
Where does the simulator stop working? Is my question.
My simulator is only set up to go to really about 200 or 300 miles because I didn't see much point going
have
beyond
a
that.
limit to the simulator. Okay.
Yeah, actually, let's see. I think you can set it to be quite a long way, but it's kind of pointless because you wouldn't be able to see that far anyway.
200 to 300 miles
too much variation.
Is that a flat surface or 200-300 miles of a curved surface?
You do both. You can set it to be flat or curved, and you can turn refraction
on your simulator.
What's the drop on 300 miles?
Either.
What's the drop on 300 miles? It's that's a crazy amount of drop, right?
Yeah, no, there is a crazy amount to drop. That
so,
would be,
so you're trying to say a laser that was shot over that?
No, I'm not trying to say that at all. Not at all. No.
It's not going to hit a target.
No, you're not.
So then how is it accurate if it won't hit a target over that distance?
It will show you not hitting it.
It'll show you not hitting it, but then it's not accurate. So that means that the distance that it's actually accurate is less than that. Am I wrong?
If I showed it hitting it, would it be accurate?
At 100 miles.
I'm asking you the refraction indicator, whatever the device you're talking
simulator.
about.
It's a simulator. Have a look at it.
It's going to tell us refraction up to a certain distance.
Let me show you a screenshot of it.
Don't interrupt me. If the laser does not hit the target within that distance, that means the simulator is wrong at that distance. That means we'd have to scale it back because the simulator is shit. Maybe the simulator only works for 200 miles or 50 miles or 100 miles, whatever it is. But there's a distance where the simulator breaks and it stops working. So we need to know
still waiting on that data to support
with a laser.
Because if we're talking refraction bullshit right now, there's a limit where the simulator is going to stop working, and my laser's not going to make it around the curve. What's that distance? If you're telling me it goes 300 miles, I need to know what the drop is at 300 miles, given the numbers that NASA gave us. If it doesn't add up, something's broken with the simulator or something's broken with NASA. Nothing's broken with our math on this side. So somebody has to set it straight for us so I get what's wrong here.
Simulator uses like real world situations, so it's trying to like demonstrate what you actually see.
That can go 200, 300 miles. But if it doesn't go 200, 300 miles, then something's wrong with the simulator. Is it
the simulator uses real world conditions to an extent, right? Until you invoke that radius, right?
Well, did you account for the temperature of the water, if there's water in there, and the gradient temperature, whatever, of the atmosphere? Did you account for all that? Like, probably not.
Yeah,
right? I don't believe because you just spoke about how you did an experiment where you put cold, the hot pushes the laser towards the cold, right? Did you account for that?
No, that's not an experiment.
It's basically built into the simulation.
None of that is in your simulator.
Laser shoots straight to my eye.
No, it is because you can
altogether. I don't give a fuck about a simulator.
The temperature gradient.
Yeah. He didn't
perform something you don't have all the variables for.
Refraction is bullshit.
Yeah. He didn't perform an experiment. We already established that.
To fucking distract us. Refraction is bullshit. Straight up.
Yeah, and he has no experiments. He doesn't even know what an experiment is.
Hold
on a second. I just want to finish up. Mick, friend, sir. Hello?
Oh, I'm here.
Yep. You have been erased. Thank you very much. Have a nice day.
Yeah.
Thank you.
Terminated.
The problem with refraction is usually it's only talked about in one terms going up and down. But if light goes in all directions, we should talk about, the image refracting this way, that way, left, right, up, down, in all directions. So the model appears to be inadequate in some ways theoretically, does it not?
Yeah, makes sense.
It's pretty much up and down there because of the gradient usually goes vertically. You do get some side to side. If you look at things like the air over a bonfire, you will see all this kind of shimmering, and that's a bit of side to side movement as well. But in the atmosphere over long distances, it's really only up and down.
Sure, but by their simulator, 300 miles, it follows the curvature of the Earth flawlessly. It's laughable at this point, man. The fact that they say it out loud is embarrassing.
Who's saying that?
I don't know who said it. Somebody said it. I don't know. I didn't look at the names, but somebody said out loud, 300 miles.
It's a little bit of special pleading because the picture should be unstable, hazy. How is it stable? Going over the curve of the Earth in one direction, up and down. I mean, this is just too much special pleading, and we haven't even factored in perspective at all and how things can compress to the eye line of the observer based off of the angular resolution of light and the angle that the observer is viewing the object at over possibly a flat plane.
It's all built in. It's built in because I do proper projection.
What curve of the Earth?
I have one quick curve of the Earth measured. The data is two totally different things. Your bullshit claim means nothing without data behind it. Prove your calculator is even worth anything. Where's the data that John D's been asking for months?
How dare you?
I was using his data.
Here.
No, he's talking about. No, did you? Wow, you're not even paying attention.
I don't need to.
I'm talking about your atmospheric refraction simulator. It has not been validated yet. Dr. John D and you had a thing going around about this. You never answered him. You never gave him the data on it yet. So we can't trust that simulator.
See what I just posted. See what I just posted in the chat.
What a photo is not proof of anything.
Oh, that's what Dr. John uses as evidence of things. What I posted is
he's asking for the data for your simulator to validate it, to make sure your simulator is following the proper laws. That's what he's asking for. And you're not providing it. You never did.
I gave it.
No, you did.
You can go. You can.
Really? Where's the video of him going over it then? Because it's not there.
He obviously did not. Let me find it. My email that I sent to him.
I have a quick question. I just want to know, Mick, when did you start debunking conspiracy theory?
It's about 2005, but it's kind of stuff I've always been interested in since I was young.
And don't forget, we can find out if he actually communicated with you or not. We have.
Yeah, I've got all these emails here. You a screenshot of my
screenshots of what?
My exchanges with Dr. John.
Screenshot of what? Like I said, it could be anything.
It could be, but
it doesn't have to be you and him. Literally.
But yeah, it could be all lies.
We need to validate that you actually made this conversation with him and not through you. I need to hear it from him.
All right. Well, you can.
I can't trust
CC you on an email if you like.
You kidding me?
No, that's true. That's true. I would encourage you not to trust me. I'm just trying to find where I sent him.
That's a weird statement.
Hey, I just looked at the values in your little calculator here. Is that in degrees? The beam divergence?
Which one? Oh, yeah. That's. Let me. I think.
Degrees are radians.
I'm tired of the math that they're handing us, bro. I'm just tired of the fucking math they're handing us. The only
beam divergence for the laser.
It's just a bunch of magic tricks.
Only math I want to talk about is the curvature of the Earth math. No other math.
The laser divergence is the standard laser, which I think is like in degrees per 1,000 meters. I'm not entirely sure though. But whatever, like the standard unit of laser divergence.
Large. Well, I'm just going by the screenshot.
Yeah. So it's or per 1,000 feet or something like that. I can't remember what it is. I could look it up, but I was looking up something else.
Well, I mean, there's only going to be one angle
not in that screenshot.
It isn't going to like. Listen, if it exits,
all the screenshots,
0.5 degree angle, it's going to stay at that. It isn't going to get crazy.
Divergence is greatly exaggerated on the screenshots. You can actually turn that off with one of the options, side zoom. It turns it to flat.
Yeah, I'm not interested.
But anyway,
in that. I want to talk about the measured flat Earth and like why that 8 inches per mile squared. At least that parabolic equation doesn't fucking ever come out the way NASA told us it should. Like that's
because
the
of
only thing I want to focus on.
Because
Anything
of refraction, basically.
I'm not even interested in talking about. I don't want to talk about space. I don't want to talk about refraction. I don't want to talk about shit.
The problem is
8 inches per mile squared. Why is it found by the people that
you've got a big problem? You've got a big problem.
That's all I want to talk about. Everything else is bullshit to me. Everything else is word salad. Everything else is obfuscation. Everything else is bullshit. Where's the 8 inches per mile squared? Let's talk about that.
Catalina.
Explain that to me in simple terms, because I'm so dumb. I don't get it.
We know how far away Catalina is. We know how high we are off the ocean. We know how far away Catalina is.
What do we know?
How far away Catalina Island is from Santa Monica. Santa Monica.
And what's the distance?
I believe it was 35 miles.
35 miles. And what does that equate to in terms of curvature?
You mean in terms of how much should be hidden?
Droppage.
Droppage. Well, droppage isn't the important
no, it
thing.
is.
It's the actual...
I should not see how many feet should be obfuscated from my view. That's what I
well, that's not the same as drop. That's the hidden value, which is different because that depends upon the viewer height.
If I can't see it, that means it's no longer in my view. It's obfuscated from my view because it's past the curvature, right?
All right, so 35
parsing words
miles.
Here. How much? How many feet?
You should have 682 feet hidden.
682 feet.
Or 576 with refraction. Yes.
Is that what we observe?
Yes,
and that's what we observe. Mick, I got a picture in the chat for you that shows your point.
You can't invoke terrestrial refraction, Mick.
In reality, Zanuck, hold on, I'm talking.
Hold on a second. He invoked refraction again.
Is that?
Oh my God. We can ignore that if you like.
He added it.
Mick, is that what we observe in reality, or can we actually see Catalina Island?
Yes, we can see Catalina Island.
You see what I showed you in the picture.
Well, that's a problem.
If you can find
because Catalina Island is like 1,400 feet high or so.
Okay, well, how much of it can we see?
I just did a
the amount that is expected. Look at the photograph that Zanuck posted.
Let me show you what it looks like when you're closer in the shore.
I found a video. I just did a quick search, Catalina flat Earth, and here's a video that shows flat Earth and Catalina Island from 48 miles away. So what do you have to say?
I've looked
many photos of Catalina.
What distance is this?
About
That's
this
up close.
guy he has a
but
video.
Listen, but this is an up close picture.
But his video is just showing that you can
not-
actually see Catalina. Of course, you can see the
we
top of
need
it.
someone that
48
did the
miles away.
observation.
48 miles,
We
not
would need
36.
someone that actually
48
did
miles.
the observation from
Not
across the
48
water
miles.
to Catalina Island.
This guy
and then
does not
measured
Order in the court. Guys,
You can
one at a time.
You can see the amount of Catalina
Show me a
Island that
picture
you
of
would
the island
expect.
is useless. We need someone that actually did the entire experiment across the water.
I've been there.
Measured the shoreline, measured how much we could see.
That wasn't an experiment.
Right, so do you deny the existence of Catalina Island, or just how
No,
big
it
is?
wasn't an experiment. Is the problem, Mick?
Experiment.
Observation.
You're taking a picture of like the mountain, like look, Catalina
Twin
Island.
Harbors
I'm like,
there.
what does that have to do with
You can
anything?
see the
We're talking
picture
about
from the shore
the
of
curvature
Santa Monica.
of the Earth.
What about the video I posted where there's 2 minutes of a guy zooming in from farther away than you guys are saying? And there should be no Catalina Island at
Well, let me
all.
look at that real quick.
Oh, we could do the math on that.
From Santa Monica Pier, how far it was?
You can say your little observation, but I just posted a video with the
I got the
alternative
video. I'm
observation.
watching it now. What are you saying?
See, but here's the thing. It's like
You're saying exactly what I showed you.
Here's
From
the thing.
48 miles away.
Here's how
Can you hear
far
me?
What you would expect to see.
Here's the thing.
It's showing exactly what I showed you. See that?
Hear me out on this one.
I have.
I'm not even gonna watch the video. Let's be honest. Like I'm not even gonna waste my time with the video. There's so many observations that people have shown distances that we should not see. So if you post a video that I can see it, I'm like, well, now I'm like, did you doctor it just to fucking make a point? Because like, if we have observations after observation after observation after observation of shit we shouldn't see, why don't you reconcile the shit that is on our side? Don't bring me another video that I've never that I didn't reference, that didn't come from one of us, didn't come from an independent observer. Give me a video that I've seen on my own. You know, make the Chicago skyline disappear, and then we'll have a conversation. Until then, I'm like, well,
where are
make
you
the
based?
Chicago skyline disappear.
Do you have a place where you could go? Do you have a
Well,
do you have a place you can go? I mean, I've been to Catalina and done it
What
myself
about the
many
Chicago
times.
skyline? That's not you can just disappear. I don't know where your video came from, nor do I trust it.
There's lots
Do you
of
think I'm gonna trust
videos
you?
of the Chicago
Do you
skyline
think I'm
being
going
hidden.
to trust you? I don't know who you are.
No.
I don't
So
know
do an
who
experiment.
you. I don't know how you make your money. You think I'm going to trust you?
Do an
Made my money by
experiment,
doing
Mick.
Tony
over
Hawk.
the Great Lakes. Then
Do
we'll
an
have a
experiment, Mick. Wait a second. He said do an experiment. Mick, you didn't know what an experiment was when we first discussed this.
But you're saying that experiment has to have an independent variable, a dependent variable, and a control.
Yeah, I'm not saying that.
And you, okay.
Penn State,
So are you,
Colorado State, the Institute of Physics, the National Science Teachers Association, though they're saying that.
let's say my independent variable here is my height above the ocean.
Height is not a viable independent variable because it doesn't cause anything, Mick.
But your position, your changing position changes how much you can see of an object.
Independent variable is your cause. Height doesn't cause anything, like depth doesn't cause anything.
Height changes your view position.
No.
It will change what you see.
It doesn't cause anything, Mick.
It's a variable which is tied to a result. There's a direct correlation between the height and what you can see.
Correlation is not causation, Mick. And height is not an independent variable, Mick.
Seriously?
Yeah, height isn't an independent variable.
Well, what is independent?
Time. It has to be something you manipulate and then you see a change.
No, it has to be your cause. Not only it has to satisfy. Shut up for a second. It has 3 criteria it has to meet. Number 1, it must first exist. Number 2, it must be able to vary and manipulate it. Number 3, it is your presumed
it seems very definite. Very definite.
You got it wrong. I'm out of here.
You are able to manipulate height because you're able to give the variable height different values dependent on the angle.
Are you listening to me? It had to satisfy 3 criterion, clown.
It's a variable. Basically, you vary the inputs.
Clown.
You take
clown show.
Right, let's see if it hits all 3 criteria.
He just won't shut up.
Let's see if it hits all the 3 criteria that we've spoken about. So the first one, height. Is it real? Discuss. Is height real?
It's real. It's a real variable. Something you can change, and it has an effect. When you change the height, things change.
You clown! Let me ask you a question.
Stop calling him a fucking clown. Stop insulting him. The fucking behavior here is goddamn ridiculous. Shut the fuck up.
You clown.
I'm a fucking mod here,
You're a
so
clown
shut the fuck
too.
up. Stop.
Yeah,
Fuck you. I'm a goddamn mod here, so shut the fuck up. Stop insulting.
Okay,
The
so
fucking
listen.
behavior
So
here
listen.
is goddamn ridiculous.
Let's do it the other way.
This is the Wild West.
Yeah. Fuck.
Yeah. Height is an independent variable. Thank you very much. I appreciate that. Clown.
Fucking children. Shut the fuck up.
The output is how much of the island you can see. So that's the dependent variable.
You see what you've
so
done.
It's a mathematical
you
relationship that you can measure.
What's your naturally observed phenomena?
What?
See what you have caused.
The hiding of islands behind the horizon.
What's the horizon?
Persuaded by these
It's
guys.
the edge
What's
of
the horizon?
It's the
What's the horizon?
It's the edge of the ocean.
No, what's the horizon? Is it the lead?
Just told you what the horizon was.
I suppose
told you where the edge
of the sphere.
Edge of a sphere, yeah, that's a
Not
good way of
actual,
putting it.
though, is it? This horizon. It is the limitation
Sure
of
seems
your
to
view
be.
when you observe across the plane of the Earth. It's not
Why does the
actual.
why does the
But no,
definition say apparent? Why does it say apparent
Which definition?
of horizon?
Probably they're saying apparent because refraction is a factor.
The line at which the Earth
It's not
the line
actual.
listen, the line at which the Earth's surface and the sky appear to meet. Appear.
Yeah, that would mean because it's
I guess
not actual.
someone cut out there,
not
but
because of
did they say
refraction.
appears to meet? I mean, they appear like they're meeting, but they don't actually meet. Obviously, one is just obscuring the other.
Yeah, that's why they call it apparent, Mick. It's where the sky appears to meet the ground. It never does.
Yeah,
That
of course
means
it
it's
doesn't.
apparent, Mick.
Hey,
Yeah, of course.
Can I ask?
Obviously.
The air does not
I'm
touch
dying
the
to
ground
ask
now.
this question
Fantastic.
before he gets banned again. Mick, do aliens exist? Yes or no, please.
I don't know.
That's
I have a question.
Go on.
Is level curved?
Let me do that, chocolate. That's my,
Oh, I'm sorry. I'm sorry, Bev.
Not even had a chance to go yet.
Bev, get in there. Get in there. Bev. Go
Hey,
ahead.
listen, anyone that wants to ask Mick, since he's our guest here, a question, like just speak up and so we know who wants to ask.
I'm going. It's my turn.
Give it, Bev.
Okay,
get it.
I want to ask Matt. Do you want to ask a question next? Matt Philosopher?
Yeah.
Need some more lube?
No, wait till Bev and then you go next, okay?
Put him on the list.
All right. Yeah. I'm good. Go.
Sweet Mick, you still here?
Don't forget the KY.
No. Are we
You know-
going to get onto the level being curved?
No, just the reason I invited you here and the reason you came onto the thread.
All right, yeah.
Is like, let's take it right back to basics, right? We want to know about the curvature, right? So my thing is, I'm trying to get people to give us the best method they have for measuring the curvature of water level in a canal.
Yeah.
A mile long, let's say.
That's too short.
Why?
There's very, very little curvature over a mile. You need to do about 5 or 6 miles.
No, how much curvature is there? Your calculator?
7.9 inches.
1 mile.
Yeah.
It's not a lot. The
Not a
drop
lot.
over 1 mile is only 0.66 inches.
0.66.
Yeah, that is 7
Is it?
inches, isn't it? Yeah.
Oh,
0.67 feet. 0.67 feet.
Okay, so that's
Over 1
noticeable,
mile.
like, isn't it?
It's hard to see.
So what would your... No, I'm not asking you to do it or anything. I'm asking you, what would be your method
Yeah, that's a
for
good question.
measuring the curvature of said water level in a canal?
I would use what's known as the Wallace method. And the Wallace method uses raised targets. It's something that Geocentism did in Beyond the Curve at the end of Behind the Curve, the documentary, which you've all seen, I imagine. And basically what you do is you set 3 targets up. One is the camera, one is in the middle, and the other one is at some long distance. And you get them as high above the waterline as possible, but you make them all be the same height above the waterline. And then you look from the camera through the middle target to the end target. And you will see, if you've done it right, that the middle target is above the end target, which shows that the water is raised up in the middle.
Would you not call a surveyor and use a level?
You could do, yeah.
Yeah. Do you think that would be a little bit more accurate than setting things?
Essentially, it's doing the same thing. Essentially, it's doing the same thing.
Looking or actually measuring.
Well, no, that's what surveyors do. Essentially,
they measure stuff really accurately.
Yeah,
they do.
So then, how do you handle the discrepancy when people measured across 25 miles
0.04
and
degrees
measure
of
from
drop
from
in
their
water level?
The laser are,
yes, 0.04 degrees of drop of the horizon.
Of what? Of an apparent location.
No. Stop. No horizon. We're on water level in a canal.
Yeah, so
we're not going to the horizon. You don't need to do that.
Yeah.
You would just have the best method for determining the curvature in the water level.
That's then exactly what I said then. You would set up these targets high above the water so you get above any refraction or minimal refraction.
Yeah.
How high above
and
water?
Then you see where the line of sight from the first target to the last target intersects the middle target.
So
and you'll set up like a
datum. The datum you are using is going to be your sight.
I think Jedi was asking how high above the water, because refraction is obviously to you guys a big deal. So we want to make sure.
No, you don't need refract. There's no refraction in when we're measuring level of the water.
The reason why I'm asking how high is because the higher you get off the surface of the Earth, you're increasing the radius value. So, for example, if you have 3 lasers, one foot above the surface, one, pardon?
Enough to make a difference. It's like a thousandth of an inch.
It will eventually, with altitude, start making a difference. But especially, hold on, I haven't finished. If you're presupposing on a curved surface, your target is going to be angled away. Also, if you have a low target, a mid target, and a higher target, because of the speed of light, having to traverse a longer distance across an arc, you wouldn't necessarily notice this speed of light change or the time that light would take to get to the top target, because you've increased the distance between the two. Keep doing this with altitude, then that's exactly what you should find on your ball, and increasing the time it takes light to get from the laser to the target, and the target is curved and angled away over a distance of an arc.
We're doing 12 feet all at the same height. So if it was flat,
I want this one now. I want this one now, because you're saying that we're on a ball. So if you increase the radius value of that ball, then this demonstration would take into effect, correct? You will be able to prove your curve if you could demonstrate with altitude it took the lights longer to get from a target, which was further away, because it's on an arced tangent, right?
Yeah, you could do that, but that's not a very easy thing to do. Like, we're talking about an easy demonstration, like which you can do if you've got a 5-mile long body of water. You set up these targets 12 feet above the water surface, and you look along them, and you see that the middle target's raised up.
What would your datum be, though? Like, in order to measure a curvature or a drop or something,
the water surface.
The what?
The water surface.
And I call
the water surface is level, being horizontal.
As it goes out anyway.
It smells like a lot of bullshit going on.
What you're measuring is
that's perspective coming into play. So the object in the middle is going to look like it is risen up anyway.
Dude, did you not just hear what he said?
What did I just say?
The datum that you are using to determine drop is a level.
It's the water level.
Is the water, yes, which is horizontal.
It's level.
Yeah. Thank you.
No, it's level. which is not horizontal, it's level.
Sure.
Different things.
There we go.
Yeah,
There's
they are
two
the
types of
same
level.
thing.
There's two types
There
of
are
level.
two types of levels.
What?
What? What? The real one and the
level.
fake one, right?
No. There's true level and there's apparent
The one you
level.
can see and the one you can't see. Right.
True level,
one you
true
can
level,
see, and then the one that they
I've done
say.
construction since I was a kid. Level is fucking.
There's the one you can see, and the one they say is curved.
In construction,
The one you can see, and the one they say is curved that you can't see.
construction, apparent level and true level are pretty much
Probably
the
haven't
same.
lifted a fucking hammer in your life, by the way. I can tell by.
No, they haven't. Anyone who talks like this hasn't had a
I
job.
own a lot of hammers.
I can show you a
I
hammer.
don't believe you, bro. By the tone of your voice, you've never lifted a hammer in your life. I'm a worker.
I've got a hammer.
I probably own more hammers than you do.
And I'm a worker. You've never lifted a level in your life.
Can the real
I
level
own like
please
5
stand up?
different levels.
Doesn't matter if you own them. Do you know how to use them?
Yeah.
In order to say that level is curved, you have to prove R, which you failed to do tonight.
We're talking about like water.
Bullshit is what we're talking about.
Water's always
Right.
what are you talking
It's gonna be relevant. It's gonna be
I can hear I can hear by the way these guys' voices cracking. They're fucking just feeding us bullshit, man. I can already smell the bullshit coming out of them, bro.
Think my voice is cracking?
I know it is.
No,
Mick,
he's the professional.
I don't think.
Voices
Hold on, guys.
I was laughing about the hammer.
Sharp ears can hear. People that are lying or just too dumb to realize they don't know what they're talking about.
Vagabond.
Vaga. Give it a second.
Get all my
Don't you think that's a bit hypocritical?
We all know. We all know.
Insults.
We all know. Whatever. I don't know what you are. I don't know what you are.
You broke up though.
I don't know what you are. I don't know what you are, but you're one of them, and you know you are.
I'm a retired video game programmer. I program Tony Hawk's Pro Skater.
So AKA,
yeah, that's not all you are.
Your fucking life.
What programming language?
That's not all you are.
Video game programmer.
Hold on. What language you use?
Life.
Oh,
Guys,
since I retired.
Anderson Cooper, he's just a reporter, guys. Anderson Cooper is just a reporter.
What programming language you use?
I do actually have a lot of hammers.
He is a programmer. He is a programmer.
What programming language you use? That should have been like right off the bat. You should have been like, "Oh, I use C++, use C, use C Sharp."
You broke out. We use C++ in programming video games. I mostly program in JavaScript now, though. If you look at the Refraction simulator link I posted, I'll post it again. You can do view source on that, and it will show
time, bro.
all the code.
We don't need your simulator. I'll just play Skyrim.
Out of your fucking mind, bro. I'm not gonna waste 30 seconds on that shit.
I have a question.
Killing your own stuff.
What happened to Fallout 76, Mick? Damn.
Mick worked on it. That's what happened.
Hold on. He said he used C++. What was one of the
blaming Mick for 76.
Hold on. What is one of the things you use in C++? Main things.
What do you mean? What do I use? I programmed in it.
The release.
Get him.
That is probably the only true thing about him is that he programmed.
Hold on. No, I haven't heard a legit answer on developing right now. I'm a developer. I develop in C Sharp, but I know some C++.
C++ you use new and delete, or you can use malloc and free.
What is it called when you release resources? What is it? What is a deconstructor for that?
You're freeing the memory, so it could be a dereferencing, and then it could be garbage collection. But it depends what you're talking about. There's lots of different ways of doing these things.
All right, so you give me the garbage collection. All right, what are pointers?
You're breaking up there, so
what are pointers? No.
He's verified. We know he's a programmer.
How do you know? What are
I like talking about programming.
Garbage collection is easy. One of the easiest things you can figure out. What are pointers?
Pointers?
Just ask him what's a stack.
That should have been a 2-second answer for you right there.
Buffer overflows?
No, sorry, you're cutting out, so I can't hear the question. So, can you repeat the question?
You already repeated a question.
I hear everything.
You just repeated the question.
No, I was asking if that was a question.
Buying time.
Okay. Now you had the time to look for what is pointers.
You have the guy in his ear explaining.
What?
Yeah, your programming skills are very.
I can't hear. I can't hear what you're saying. Why don't you like type it in the chat or something? Because I have no idea what you just asked me.
Yes, because you're gonna search and look it up.
I've got a website called Cowboy Programming. It's cowboyprogramming.com, and I've got loads of articles I've written in there about programming, and they're all really complicated and technical. So if you doubt my programming abilities,
don't make it real, bro.
And if you want, you can go and look at the credits for Tony Hawk's Pro Skater 1, and I'm listed there as the lead programmer.
My God, I could hire a fucking writer to write me a fucking article with a fucking neurosurgeon tomorrow, bro. Doesn't make me a neurosurgeon.
You could go to
You're asking me like, I don't know, high school level questions like, what is a pointer?
Exactly. Exactly. So this should have been like, oh, dude, the pointer is this and that. It's garbage.
No, I know what a pointer is. Like, I started programming it in Z80 or 68K, well, later 68K, and a pointer then was just one of the registers, like one of the address registers in 68K. It's a location of a variable in memory.
What is this now?
Yeah, but where's
you finally looked for the answer, did you?
Yeah, bro, but where's the curve?
I know what it is.
He knows what it is. We know that you're good at programming and manipulating stuff, and you can show it on your simulator, but you're not really, because you can't, list the variables. Like, you're just gonna give us a simulator.
I'm telling you the variables. The variables are they're right there in the simulator. But the temperature gradient would be the one that you'd want for doing an experiment.
Yeah, but where's the curve at though, bro?
How come water is always flat in video games?
It's just the easiest way of programming it.
Or is it because
that's way more complicated?
Yeah, because
it's because it's the easiest way of programming.
It would be a little weird if you programmed it with curve, right? Because
it would be complicated. It would be hard to do because it's not real.
Yeah, if you want it to look like it does in real life, when you look at the water.
It is actually programmed with curve in things like Microsoft's Flight Simulator or X-Plane.
How does it find its own level?
I've been tracking the simulator, and it's not what you think it is.
With a lump in the middle.
It's like saying, how does a pendulum find like its own level? No, it's
not. It's like asking how does a fluid find its equilibrium. That's what they do.
Because if it's in disequilibrium, then it moves towards equilibrium. That's just
it doesn't have a big lump in the middle, does it? I think that's what it means.
It doesn't have a big lump in the middle. It's a sphere.
Water curve? How does a body of water at rest curve?
By being attracted towards the center of the Earth by gravity.
Gravity. Here we go.
So how come gravity? So how come no scientists can demonstrate gravity and replicate it?
I've heard that word.
You can demonstrate the effects of gravity.
Sure, no, but they can't demonstrate what they're actually claiming. It only works at a planetary level.
Excuse me, Hollywood. We really wanted to give Most Mad the opportunity to ask a question as well. We seem to be veering off again.
I have to be going soon anyway. So
next up.
Can
I have one question?
If Matt doesn't want to go ahead.
Are you
Matt,
familiar
you got something?
Sorry, he must be AFK.
Let's give Mick a little breathing room. How are you doing, Mick? You all right?
I'm fine. This is all fascinating stuff.
Yeah, it's all yeah. Okay, good. Professional.
I understand that people are passionate about their beliefs and they get angry sometimes. Not a problem.
Who's getting angry?
All right, next.
I heard a few raised voices.
Cool as a cucumber.
Yeah.
There's some people who just yell all the time, so it doesn't necessarily mean they're angry either.
I just don't like liars when I figure
I'm
them
angry.
Out. Oh yeah, I'm angry.
Does someone have a question?
Once I figured out this thing was a lie, I'm furious. So anybody that comes in here, they better have their shit correct.
Waterball, go ahead and ask your question.
Hey, sorry, I was my phone got frozen.
There he is. You good? If you got a question, go ahead, man.
Yeah, are you familiar with the heliocentric?
All right, go ahead, James.
I have a question, if that's okay.
James. Hang on a minute. No, James is going.
Mad philosopher,
go, James.
please. Mad philosopher, please.
All right, so Mick, you're obviously aware of everything that happened post 9/11, correct?
I wouldn't say everything, but I'm familiar with things. Yes.
Right. Sorry, I guess I should have reworded that question. Everything, like the wars that have been fought since then.
Yeah.
Since like we invaded Iraq, Afghanistan, Libya, Syria, all of them.
Against
you know,
it.
Right. Well, I'm asking. So, do you know what those countries were doing prior to 9/11?
They were just sat there with a bunch of oil.
Right. No, that's not actually correct. That's not all they were doing. Each one of these specific countries, the ones that have been invaded post 9/11, all back their money. All of those countries backed their money in gold and silver, and denied central banking in their country. And denied backing their money with the U.S. dollar. Since then, every country that we've invaded, Iraq, Afghanistan, Syria, Libya, all.
Okay, someone cut out there.
He broke up.
Hey, James, we lost you.
Oh, sorry. Since then, all of these countries have backed their money in gold and silver, in U.S. dollars. They no longer back their money in gold and silver, and each one of them have incorporated Rothschild central banking. So, I guess my question to you is, how the fuck can you turn a blind eye to all of this shit and not see how evil the Federal Reserve and these Freemasons, the Rothschilds, all of them are, and you just go to all of these conspiracies trying to debunk them instead of seeing all of the evidence right in front of your face?
Good question, and I'd be happy to answer it. I think the reason I don't turn a blind eye to it. In fact, I think that things like that, the corruption that's endemic in the American system and their foreign policy, is something that we really need to look at. I might not agree with all the exact details of that link.
What do you
that
think about it? Don't say we need to look at. Sounds like a political statement. What do you think about it?
You're asking, like, why do I debunk? The reason I debunk is that I think people need to focus on things that are real. I don't think the flat Earth is real, and I think people spending all their time. I know
you need to focus on things that are real, but you keep reifying things that are not actually.
Yeah,
real.
wait. This is
doing that.
Because what I see myself doing is I'm kind of like a force multiplier, for want of a better word. If I can actually help a lot of people not spend their time on nonsense,
well, then
they'll be spending their time on real news.
Wait, hold on.
Who are you to dictate what is nonsense and what is not?
Yeah, what's related?
The genius of the group.
This is related.
Obviously, it's what I personally decide to focus on.
Are you,
for example, like the flat Earth?
Save us.
Hold on. Do you not see this world,
my friend? Are you the intellectual that can save us?
Hold on, let me
I'm trying to help.
Help who?
So then, do you not see this world organization, this world secret society or world government trying to establish itself? Do you not see that?
I don't think there's a single organization. I think there's lots of people with their own self-interests. There's lots and lots of corruption. There's lots of powerful people who are doing things for themselves.
Cool.
Under one banner. They're all doing a bunch of things under one banner. Do you not? I'm asking you, do you not see that?
You think the Chinese are all doing the same thing? You think the Russians and the
I
Japanese
think they're all
are all doing that?
Yes.
Yeah, bro. This guy just doesn't have the balls to wake up, bro. Fuck
it. Have you looked at the Forbes list of billionaires?
Forbes.
Dude, that's everyone that has trillions in private.
I thought you were busy with important things, not Forbes.
Well, so look at them. Look at the variety of people that are billionaires. There's over 1,000 people in the world who are billionaires, and they're very, very different people.
Publicly billionaires.
Well, yeah, but that's all we have to go with, isn't it? So if you're just imagining things, that's just something I can't really comment on.
It's not
but what we actually see is that people who are in power are very variable. There's lots of very, very different people, and they all have their own interests at heart. So there's obviously a lot of corruption. There's a lot of problems, and that's what we should be focusing on.
All right. So wait, real quick. This is related to Most Mad's military kind of thing that he's talking about. So when we went into Iraq under the presumption of weapons of mass destruction, what's your opinion on that? Because you're like debunking stuff. So like at some level, so like, what's your opinion on the weapons of mass destruction?
I think that they basically made up a case for going into Iraq, and that they essentially lied about the weapons of mass destruction by just exaggerating evidence that really wasn't there, like the stuff about Colin Powell said about the labs really wasn't.
So why can't you imagine them doing this at a different scale, a different subject? Why can't you imagine them lying to you
them doing it
about other things, dude?
Was that a conspiracy though? Was the weapons of mass destruction, was that a conspiracy?
People, I think, conspired to modify the evidence to make it seem like there were weapons of mass destruction. Yeah.
But
The whole Iraq thing started with a secret conspiracy. You know that, right? The Sykes-Picot Agreement.
I'm not familiar with
the whole geopolitics. The Sykes-Picot Agreement was a secret agreement with France, Great Britain.
It's a secret. How do you know about it?
What was the other? The Ottoman Empire
the Flat Earth
decided that they were gonna divvy up Iraq. This happened in the 20s, right? So this
makes sense. I mean, they were doing
Iraq
that
war.
type of thing back then.
Yeah, so the current
colonial
Iraq
powers
war
were just...
is a base. That is the basis of the entire
No,
war.
the Middle East is
The whole
completely fucked
Bahrain,
by the
Kuwait, all that stuff.
The colonial system basically just messed up Africa and the Middle East. So it's
but that was a real conspiracy. That was a real conspiracy. I mean, you can Google it. It's called the Sykes-Picot Agreement.
I mean, there's thousands of, there's lots of real conspiracies.
Oh, I'm just glad you admit it, because you believe in a conspiracy theory.
Yeah,
you believe in 9/11 was a conspiracy among
I wrote a book.
19 hijackers. It was a conspiracy of 19 hijackers, right?
Yeah, well, more than just 19 hijackers. There would have been a lot of other people. There's like who financed it. Then there was the organizational things. So yeah, there was a lot of people involved. So the conspiracy.
Well, I'm just saying the official story is the conspiracy theory.
Yeah,
is my point.
Yes, I'm not sure.
Calling other theories a conspiracy theory is just saying just a different conspiracy.
There's a difference between a conspiracy and a conspiracy theory. I mean, a conspiracy theory is just essentially, in the scientific sense, a hypothesis. If you want to get scientific,
I believe in the lone wolf theory of 9/11, like Lee Harvey Oswald. Like there was just one person flying all three airplanes.
That's just silly.
I mean, I know it's silly. That's the point.
So why are you saying that?
Because when the government says it's a conspiracy, people believe it. When they say it's not a conspiracy and it's just some lone nutter, they believe that too. Like, you just believe anything that comes across the television set.
I didn't believe the weapons of mass destruction thing.
Well, it came across the television set that it was a big lie. But if
I didn't believe it.
If the New York Times didn't out that, then everybody would just believe there were weapons of mass destruction.
Well, you're going to go to Iraq and find them for yourself?
Well, they could just put them there.
You can actually
find them.
You can measure the curve of the Earth yourself. It's hard to do things in geopolitics for yourself.
May I just ask a question? May I ask a question quick? This has come from one of my friends that's just messaged me. What's your opinion on Jeffrey Epstein? Did he kill himself? I mean, considering we're talking about conspiracies. Just
I think he probably killed himself.
You sure he's dead?
Good. Yeah,
he might have been allowed to kill himself, and that's about as far as I would go in terms of conspiracy there. But I don't think he was murdered by someone coming into the cell and strangling him.
And what about his what about his overall setup?
I think he was a bit of a perv.
What about the broken hyoid bone?
That broken hyoid bones happened quite commonly in older people with suicide strangulation because it gets more brittle with age.
Well, I've seen two forensic pathologists with a total of 50,000 autopsies between them say they've never seen it in a suicide.
I don't know, but I've looked at a bunch of
unless it's a height, you know what I mean, like 16 feet, something like that, not the 4-foot bunk.
There's been scientific studies that predate this by decades that show that the hyoid bone is commonly fractured in suicides, just by regular hanging from a bunk bed type suicides.
Well, thank you for your time, Nick. Thank you for answering.
Can I have my short question?
I should also say the hyoid bone wasn't the only bone that was broken.
Well, I'm not familiar with anything other than that right now. I could look it up, but
there was three. The hyoid bone was fractured, and the vertebrae underneath that had 2 fractures, and the cartilage had lateral tears in it.
The people who actually performed the autopsy say that it was consistent with the suicide. Now, the Epstein family hired another pathologist who attended the autopsy, and he is saying that he thinks that it might have been a murder.
Where's the video?
Yeah,
Where's
Michael
the security
Baden.
footage?
Conflicting opinions.
Real.
Any what?
Well, the independent one is saying it might have been a murder, but the one that's got paid by the government decided to say, yeah, it was.
Well, no, the one who is paid by the family is the one who is saying there's something suspicious. The family have already said that they think that there's something suspicious going on. So they're paying a pathologist, and he's giving them an answer that conforms to their suspicions. Now, does that mean that they've influenced his opinion? Are they going to fire him and get someone else if he doesn't give them what they want? Who knows?
Well, Cyril White, who's a famous forensic pathologist, saw the autopsy report, and he says that it's more consistent with murder than suicide.
Well, perhaps you should do a survey of all the different pathologists. But
well, yeah, that's why when something like this happens, you have a coroner's inquest, right? And then you get a jury of people to judge the evidence to determine whether it's a murder or suicide. That's what we used to do in this country. Well, we'll see if it happens, because I seriously doubt it.
It seems like the family is kind of heading in that direction, but I don't think they would win such a case because they don't really have the evidence to back that up.
Well, it's not really winning. It's getting people to look at the evidence. I mean, from one perspective, I guess, but it's not really a win. That dude's still dead, suicide or murder.
Yeah, but then they can sue the government and bring down people in power, which would be pretty impressive.
Why was the photo of his body not him? It was somebody else's body.
No, it was him.
Yeah,
the photos look very different in different situations.
Why did you recognize any birthmarks?
You're comparing it to photos from 10 years earlier, and also he's dead.
His left ear was showing. You can compare it. You can compare it to his left ear.
The blood flows down to the lowest point of their body. It's called lividity, I think, because you get all this pooling and purpleness.
How do you
when someone lies on the side,
without even questioning it?
I'm questioning.
You're not even open. You're not even open-minded. You never thought about it. You just automatically. You're like,
well, no. The reason it seems like I'm not thinking about it is that I've spent an awful lot of time already thinking about it.
That's pretty weird.
Like I was on.
Is your default position to support the official story? Is that your default position?
No, it's not. My default position is to go with whatever I think is best supported by the evidence.
I don't think you've actually seen the evidence. You haven't seen it.
Yeah, but what I have seen is it doesn't really suggest murder to me. Like there's things like the cameras being switched off or the guards sleeping on the job and things like that. Yeah, you can say that's very suspicious, but that's just something that's been happening constantly at that particular prison for the last 5-10 years or so, because they're grossly understaffed. It's a federal prison, and the federal prison budget has been cut, and they've got more prisoners there than they should have. All the prisoners.
Okay, well, name one instance. Name one instance where a person has committed suicide like that, and everything has been, all the cameras from that location has been.
That prison has only had about 3 suicides in the last 30 years, and I think a very small number of actual suicide attempts. So
okay, he wasn't just any normal prisoner, was he? He was an extremely high-profile prisoner. This was an extremely rare case. So I get what you're saying if it was just another bloke coming through the prison system, but it was not. So, I mean, that's why what happened is highly suspicious.
I can certainly see that, yeah. And I think with hindsight, he should have been put on some kind of more full-time suicide watch. But
then what if those guys fall asleep? But what if those guards fall asleep?
He was essentially... well, then they wouldn't if he was put on a proper suicide watch. They've actually got much more rigorous checks and balances.
Yeah, but then those guys can fall asleep.
That's like saying the doctor can fall asleep.
Any guards can fall asleep.
You're making
You guys know
hypothetical.
we got 3 theories. We got before he got moved into the cell where he committed suicide. Someone did try to strangle.
We got conspiracy theory, coincidence theory, and incompetence theory.
So someone
You're
did
going
try
like
to
with the
kill him
incompetence
before he
theory.
actually
Like,
supposedly.
I am going with the incompetence theory. Historically speaking, incompetence happens
it's hard
a lot
to make
more
an
than,
argument against a federal
than
employee
evilness.
not being incompetent.
Federal prison, and it was very underfunded.
Okay, look, basically, the end result is here. If Jeffrey Epstein went into a court trial, they had evidence and would have subpoenaed, or at least tried to subpoena, Prince Andrew, who was one of the main people involved in this situation. So whether Epstein killed himself, was killed, or was relocated, that's the reason that he's gone now. He couldn't go into the courtroom. It would have opened up too much information on Prince Andrew.
Possibly, quite possibly.
It's not quite possible. The main woman testifying in this trial is the lady that's living in Australia. She was the one that was in the first initial case that was actually abused by Jeffrey Epstein on his yacht, and they've got the photographs of her with Epstein and Giselle Maxwell, or whatever her name was, the co-accused or the co-charged in this case. I mean, it's blatantly obvious why he had to go.
Okay, well, I really have nothing more to add on that. I think he probably killed himself. Maybe he was allowed to kill himself. I think it's unlikely that he was murdered, and that's
Wait, how did he kill himself? With what?
He hung himself with, I believe, a blanket. Or
And you know how thin those blankets are, tissue paper, dude. There was nothing to kill himself with, but you think he killed himself.
No, he was in a standard cell at that time.
Yeah, no. There was nothing. No, he wasn't in a standard cell. No, there was nothing.
They said he tore the blankets into pieces and made a rope.
Yeah.
So he weaved himself a rope in the cell with the cameras off.
A rope of tissue. Okay,
you could do that actually.
Okay, cool.
Nick,
but I don't know.
Have you ever stepped a foot inside of a prison?
Well, only in tours and things like that, like Alcatraz and Folsom Prison.
No.
But I've never been arrested or anything.
Not
like
an
that. Spent time in jail.
A fully functioning prison. Have you ever been in one? Okay, so the blankets in prisons, they are fucking thin. It would not be able to support Jeffrey Epstein's weight.
People kill themselves all the time with those blankets.
You just braid it up a little bit with a few things. Yeah, obviously people kill themselves in prisons. And they do it by hanging.
But dude, here's the story though. We're talking about the McWest. We're talking about the official story, Brett. Okay, so he hung himself with his sheets. Okay, now I'm telling you that those sheets are tissues. Okay, but you say that that's fine. You can hang yourself with tissues. Now, can you demonstrate this?
I'm saying that he hung himself with the sheets, so I don't know how he did it.
And I'm telling you that
Maybe
the sheets are tissues, okay? And you think that people can hang themselves with tissues.
Okay, hold up.
I'd have to.
Hold up.
I'd have to see the actual sheets.
Is it possible that he was told, can you threaten a man like that? Hey, end your life, or we're gonna do this to whatever, your family, or
possibly.
Is it
but
possible?
I think he knew what was coming down the line, and he decided to kill himself.
So when are you going to decide to kill yourself?
Hey, Hollywood, chill out, man.
What if they do that to Mick and he's going to do that? Like, what? I don't know. What if that's that's how they? I don't know, man. I'm just possibility. I've already told people.
They do it to me.
I've already told people if I get suicided, don't believe it. I've already told people if you get a letter with my fucking handwriting or something, don't believe it. Like, I've already said that. So it's possible to anyone, dude.
I got a flat Earth challenge.
I'm still interested about aliens, though.
What we ought to do is do 200 proofs in 200 hours, and every hour on the hour for the next 200 hours, pull up the 200 proofs and debate them one by one. Each one gets an hour's debate.
Well, Any other conspiracies or theories?
Yeah, I really have to go. So if you got any last questions, then speak now.
I have a question.
Thanks.
If that's okay.
Thanks for your time.
My question would be, what do you think people's criteria for evidence should be? So when you see a claim and some substance presented for that claim, how should people look at that substance and decide whether it holds ground?
Well, good evidence is evidence that's verifiable and testable. So if you can verify, repeatable, testable, verifiable. It's the three criteria of evidence. But verifiable is probably the most important one. But then if you got reproducible, that kind of verifies it naturally. So things like, I don't want to get into a big argument again, but like the observations of Catalina is evidence that is verifiable and repeatable, and you can test it. You can do things like change the way you view Catalina from, and you can go to Catalina and measure it. No, it's not every day, because the weather is sometimes quite often actually you can't see it, but on a clear day it's visible with the naked eye. So yeah, if it's those things, verifiable, repeatable, testable.
Mm-hmm. All right, thank you.
Anything else?
Thanks for coming by. I just want to get that out.
All right.
Thanks a lot. We appreciate it.
Yeah, thanks. Step by again.
Maybe some other time. And yeah, if there's anybody who wants to have a more extended one-on-one discussion about this type of thing, I do have a podcast, and I would like to talk to people, like more varied people than I have been talking to. So if someone was interested in being on my podcast, maybe have a quick look at it. It's called Tales from the Rabbit Hole. TFTRH.
Yeah,
and just send me an email if you would like to be on there.
The universe is also
just say rabbit hole.
We've got one of our members here, Dr. Science. He does Flat Earth Initiative and Friday Night Fights. So it's a more structured sort of debate. So that also might be.
It doesn't have to be a debate.
No. I know. I'm just saying it's a more structured format where
it's actually just kind of a chat. Really, I like talking to people about where they're coming from and why they believe what they believe, and how their opinions change over time. Yeah, things like
I have a question for you. Have you ever thought of going to SLAC up in Menlo Park and going into the Stanford Linear Accelerator and look at that structure, which is probably the flattest structure in the universe, I would say. And you could do some tests in there, kind of go from the reverse angle. Now you have something you know is flat, and see if it then comports with the reality of curve or straight.
Well, I mean, if you know it's flat, then it would be flat. So I'm not sure what test you could do.
You get the plumb line at the ends that won't be, right?
Well, at each end it would be the same. Well, no, they wouldn't be. They would diverge from each other. But yeah, you could do that on the surface.
They'd be parallel, wouldn't they?
Right. And then the other thing,
they would
one way.
But you don't need to have a flat surface to do that. You just need two lines that are some distance apart. But the problem is, how do you measure this angle? Which you can actually do. You can do it with good surveying equipment on buildings. You can see that
just measure the water level. Just measure the curve in water level. It'd be easy.
That's a good point. Let's do that. Wallace experiment.
It's the same inclination that you'd have for the Nile River, right? We're talking about 8 inches, every 8 inches every.
Inclination for a river. Well, that's what rivers do, isn't it? That's what water does.
Downhill.
It finds its own level, doesn't it? It keeps going until it.
No, it doesn't find its own level, actually.
It actually flows down to the ocean, Zanuck.
It finds stability.
The inclination is the same as that building.
It's called sea level. Have you ever heard of it?
Yeah, and the sea level is curved all the way around the Earth.
It's not. Level's horizontal.
How can water be curved? How can water be curved?
Okay, relax.
Let's fight the flat.
Nick, the other question.
I'm going.
The other question. So there.
I'm going now.
See you later.
All right, Mick.
Nice try though.
Zanuck, be quiet. Zanuck, he says one.
Last question.
Zanuck, Nick's trying to leave. Come on,
the last question. You guys have had the whole 2 hours.
Last question. Go for it.
Well, I haven't said anything personally.
Yeah, but we have a little relationship, Nick. We actually worked on your curve calculator and added one little bug on it. Remember that a while back?
There's a few people who did that, but
anyway,
thank you.
what about looking at mountains? We're looking upward, getting away from the water refraction. Again, I like getting away from this refraction element and look at the angle of those peaks versus the horizontal to see if that comports with reality as well, or what they should be for how high they are and how far they are away.
You can do that. It does require a little bit of bit more math, for want of a better word, working out the angles and things. There's some very good examples though. I think like the twin sisters or the three sisters. What was it called? In Oregon.
Yep.
Mount Hood.
Mount Baldy, and then what's the other one over there? And
Right. Oh yeah. There's. I'll just post the link.
11,000 feet, and then you're at sea level at some point, looking up at that mountain, saying, "Okay, does that have the right angle for how far?"
It's actually the best thing is to be on the top of a mountain, looking across the tops of other mountains at distant mountains. And I posted a link of that type of thing.
Right.
But it's essentially a very large-scale version of the Wallace experiment. But you do have to kind of accept what the height of the mountains actually are,
right?
Which not everyone can accept, because it's all based on numbers.
That's a great picture, by the way. Yeah, a lot of people here actually accept the altitude indicators and the air density measurements.
They just did the world. They just did the world record.
I don't.
326.
I don't.
Who are you talking for? A lot of people.
I accept measurements of altitude. I don't accept the model.
So when you basically in a helicopter and the altimeter says 1,000 feet, you don't think it's correct?
I believe there's an error within a certain range.
All right, so I think I've answered that question. But
What happened? All right, I guess that's it then. All right, well, have a good one, everyone.
disagree, and I certainly haven't come here to come and crap on what you believe. I think it's actually genuinely fascinating, and you guys have as a community have done it in the very least like an actually fascinating job constructing these theories. I study philosophy of science myself, so seeing how you guys do this is actually pretty cool. I'm wondering, as part of your the way you see this, why is there a global conspiracy to make us think that the Earth is round?
You're going way too far.
Oh, am I?
The point he's sorry, Remy. The point he's saying is you're actually looking at why did this happen instead of like what the evidence provided. The evidence.
No. I mean, let's assume. I'm going to assume your proof is correct. So if your proof is correct, why is there a big cover up about the Earth being flat? Why do people want us to believe it's a globe?
Dr. Science, go ahead.
Yeah. Well, you gotta look at it this way. It didn't just start like recently. This has been worked on for quite some time. The globe Earth is kind of like the new kid on the block. Flat Earth has been around a lot longer than that. So within the past 500 years, it's been really propagated throughout history. So before that, it was only conceptualized, and then it's been actually.
Don't cut them back in the Greeks.
We're talking about like.
Don't cut them.
Yep, we're talking about like where Copernicus and everybody's looking at the sky and conceptualizing, planets and ideas of these sorts, and putting forth into the mainstream. Notion.
In Copernicus's time, there was no debate about the Earth being round. The debate was whether the sun was at the center or whether the Earth.
Yeah, there you go.
Right. So there you go.
Sorry, that brings us back to the earlier question of when the Earth was proven to be a ball. All right, so we've worked on like disappearing from the bottom up. Now we can provide you with visual demonstrations of things disappearing from the bottom up on a flat surface. So we have another mechanism. So if we moved on to when was the Earth proven to be a ball? Because the boats disappearing was working on the presupposition that the Earth was a ball, and this boats disappearing was caused because of curvature. The next one will be the presupposition that the Earth was a ball and a guy sticking sticks in the ground and measuring shadows to find out the circumference of the presupposed ball. What you'll find out is as you look through history, like you just pointed out, it's always presupposed. The Earth was already a ball. So the question is, when was the Earth actually proven to be a ball?
So my understanding, as someone who studies the history of science, is that the Greeks were the first to manage to prove that the Earth was a ball.
Right. What was the test that they used?
BC.
What was the test they used, Crazy? Since you know a lot of history, right? So what was the test they used?
Okay.
How did they know that?
Well, as I said, I think they didn't have proof before.
What timeline? I want to see.
Hold on, you just said that they were able to prove that it was flat.
That's what you just claimed, Crazy. We want to know exactly.
Give me a second. I want to do this justice.
All right, I know you want to do it justice, but here's the thing, though. You're looking up an answer right now that you already assume is true, which is kind of crazy, right? Because like you're coming in here thinking, well, yeah, it's a ball, duh. And these guys here, it's interesting to know that these guys look at the world differently. But I'm kind of looking at this like I'm a man of philosophy, and I understand things. Yet I have to look this up when it should have been given. I mean, you know what I'm saying? Like that's kind of like, well, where's the information that you should already know? You should be like, oh, bam, here it is, Eratosthenes, right there, where he measured the sticks and shadows. That's go with it. But you didn't even have that ready. So how do you know that information is true? You're going back into this thing where you're trying to verify what you already think you know.
You're being very philosophical here by doing what's you're being very critical, which is good. I mean, that's very like
I can give you all your maths on this globe that you believe in all time. Every spin, what you gonna give me, I can
Yeah, you're just proving that you're not very knowledgeable and you're fighting a losing battle.
Right.
If
And
you
that's what
have
it
no
sounds
idea
like.
what you're talking
Well, I don't know if it's a losing battle when most of the world
just
still
because
believes.
just because
losing
crazy
battle. If you've got
didn't
no
just
idea,
sorry.
if you're asserting that they've proved it, then and you've got no idea what it is that they've proved and how they've done it, then how do you know they've proved it? You're just going off what
Indeed.
other people say. You're a sheep in a system.
Sorry, but just singling out a person and just because he didn't know a fact and calling you a sheep.
That's not my fault.
Actually,
To be very
Earth
polite
is
with you
very
guys.
popular.
And you guys
A lot
are
of people
being
know
pretty
that.
personal at me now. I mean,
No, it's not putting crazy on the hot seat. This is the point. Okay, this is the point. When people come in here, they already have this idea in their mind, like, yeah, it's a ball, duh, for sure. But okay, so the thing is, when you say, well, the Greeks proved it, let me look it up. That's saying, like, well, I didn't know that they did. Well, let me see if it's true. Because when you look it up, and we're telling you, yeah, we've already looked it up. We're telling you that they had an assumption that the Earth was a ball. That's how they derived the information that it's a ball, because they already started with that without even verifying that first the information to see if it was a ball.
The Greeks,
absolutely, and that's why I'm kind of astonished. I'm kind of astonished that you didn't know that, being a person who studies this. Like, I thought maybe you would have been like, of course they.
No, I know that they used to think that it was flat.
So guys, out of interest, sorry.
Hold on. Let me have a go at this. It's fair enough, you know what I mean? Because when I came here, like, if flat Earth was never pointed out to me, you know, I'm a researcher. I like looking into conspiracies. But if it was never brought up, if it was never pointed out on the internet, if all these videos didn't keep freaking popping up with all the other searches I was doing about flat Earth, I wouldn't even have thought of it. I wouldn't even thought of questioning the globe Earth. So let's be fair, right? Let's be fair.
Yeah, exactly.
Everybody believes it because they were taught it to be the truth. And everybody believed it to be true because what reason? My parents sent me to school. Are you saying my parents are incompetent to not even know that what they're sending me to learn is bullshit? Yes. I'm saying that these people are so freaking ahead of us, so ahead of the curve, that anything you can think of, they've already thought of first. So to speak. Right. I know, right? You like that? But that's what I mean. Okay, so once you see it, once you've heard of it, okay, once you hear people are believing in flat Earth, and they don't seem to be stupid, crazy, psycho, culty people. They sound like they know. They sound like, then you have to. Then no matter how many people believe in the globe,
you might have a bit of a paranoid perception.
Wait. No matter how many people believe in the globe, you have to check this. You have to look into it. Else I wouldn't have checked flat Earth. I told my friend about it. Hey, did you know that people think the Earth is flat? And he flipped out at me, right? He flipped out at me, and I didn't even know what flat Earth was. So I had to look into it because it was like, all right, let's clear the table. Let's take everything off that's not true. All right, we got this hollow Earth. We got this flat Earth. What is this crazy stuff? You know, let's remove everything that's false. And once you do that, you're going to see that you have to remove the ball.
I mean, made a presupposition that it's false.
No, what I'm saying is, if 3 people are saying the Earth is this, that, right? You have to pick, because you're saying, well, the majority of the world thinks it's a ball. Nobody cares. If there are three Earths presented to you,
I'm not so much won over that it's the majority. I'm won over by the fact that the experts, the people who I say, in the same community that I trust with my health. I trust
the experts
with my health.
Exactly, and that's what I'm talking about. And that's exactly what I'm talking about. See, no one is responsible for your health. No one is responsible for what you learn, what you accept as truth, but you. If you put that responsibility into the hands of the doctor, then now you have to trust the doctor no matter what lies he tells you. If you put that responsibility on the schools, on the government, then you have to accept what they tell you no matter how nonsense or how ridiculous it is. It's your responsibility, not theirs.
But if it's my responsibility, I mean, that's a huge responsibility. I basically can't believe any science at all because I'd have to go and run every single experiment.
But no, you can't throw the baby out with the bathwater. And I hate to use that analogy, but you can't throw the baby out the bathwater. You can't just say, I can't trust anything.
Hold on, Mickey. Let me adjust this. If you cannot trust yourself, then who can you trust, right? Are you even capable of understanding the reality you live in without the experts? See, this is a big transformation. This is a big thing you're about to go into. You are about to trust yourself. I mean, how crazy does that sound, right?
You're expecting me to trust you, actually, in this community.
No, I'm saying to trust yourself. I said yourself, bro. Like, serious.
One of us has said true.
Wait.
One of us has told you to take what we say as gospel truth. You're here to hear a different side of the story. Go figure out what the hell you want to believe in. Never take what we have to say.
I actually have some.
Never take
He's not phrasing it that way. That's actually quite fascinating. That you phrase it that way. That's good. You're right. Yeah, absolutely. I need to figure it out for myself. And I certainly will never say about your community that you guys are force feeding people beliefs. You have clearly said to me many times to think about it myself.
No.
And
I'm asking you to take the journey yourself, and you're saying, "Well, I don't have to take that journey. Someone else has done it for me." It's like, dude, are you going to take the journey, or are you just going to sit here and tell us why we've taken this journey? You know what I mean? Like, take it. Go see for yourself.
It can be curving at 8 inches per mile squared and have lasers being shot over it at 25 miles and have it hit the target at the other side, 2 meters above sea level. That can't happen.
Okay.
That's the whole point. That's the crux of this whole thing. So if you do have that, I'd be interested to see it.
Well, like...
If you don't, that's fine, because no one else does. No one else has that. So, you wouldn't be the first. Don't worry.
Yeah, I know, because, like... I don't know how to explain it to you, but, like...
Well, what?
Like...
Do you mean?
Okay, okay, you're right. You've done your own, and... Okay, so you're saying you've done the experiment.
No, I didn't personally do
not you. Yes, I know. People have done the experiment.
Yeah.
And they say, well, this happened, and so the Earth is not curved. But other people have done it, and it worked for them. So it's like...
Who did that? Where? Who? When?
Yeah, that's what we'd need to see. But you're right. If that were the case, then we would have to compare the two and say, right, which of these bodies of evidence is stacking up and is legit? Because both of them cannot be true. So if you think someone is doing the same thing that we're talking about, and it is actually showing 8 inches per mile squared, remember it has to be a very specific rate based on the size of the ball they tell us, then please post it. It'd be very interesting. We're all waiting for this one.
Okay.
Because that would shut the whole server down, bro. Be careful. But let's see it.
You can go and get it.
Well, I don't have like I know people have done it, and they have videos on YouTube. No, they have videos on YouTube on both sides, whether it's flat, whether it's not.
So there's a couple on YouTube like Discovery Channel, National Geographic that claim to have done this. But when you examine the videos, you can see where they've misled. And also, the videos that you'll find on YouTube are like 5 to 10 minutes long. They're little reality show puff pieces. They're not scientific papers. They're not academic studies or well-documented experiments.
But look, not everything in theory works. You should know that, right?
No. But this is different because this isn't supposed to be a theory. This is supposed to be reality, remember?
Yeah,
in reality, it's supposed to be curving at 8 inches per mile squared. So, in reality, as you agreed, a laser would be able to evidence that. A high-powered laser, when referenced against the surface that it's being shot over, would demonstrate convexity of 8 inches per mile squared. That's very measurable.
Yeah, and you'd also have to tell the militaries of the world to use laser targeted devices from vessels at sea. I haven't finished.
Okay.
I'll start again. So you'd also have to talk to the militaries of the world who use laser targeting devices from vessels at sea, using lasers to target ground-based targets at over 100 miles away. Now, the laser aiming device is only 40 to 60 foot above the surface of the water, shooting the beam at over 100 miles to target something that they can shoot the shit out of. So we can use lasers to hit targets at 25 miles. but practically in everyday use by the militaries of the world when they want to blow shit up, they use laser targeting devices from vessels at sea, over 100 miles. This demonstrates the practical use of a flat surface. Otherwise, the militaries of the world wouldn't use this shit.
You know that they use satellites, right?
No, they... yes. Right, you didn't listen to what I fucking said, so I'll restate it.
No, okay, I've listened.
Laser targeting devices, beam pencil lasers, RDF, requiring a direct line of sight from a targeting device from a vessel at sea. The targeting device is no higher than 40 to 60 foot over the surface of the ocean, hitting targets over 100 miles away that are ground-based. This requires a direct line of sight from the targeting device on the vessel. Nothing to do with satellites, mate.
Okay, I see what you mean. You're saying that people, cruise ships, and other military things are shooting weapons
Laser
from the ocean.
Targeting devices requiring a direct line of sight at over 100 miles from a vessel at sea, no higher than 60 foot above the surface of the sea. It requires a direct line of sight. You're not going to get a direct line of sight over 100 miles from 60 foot above the surface of the ocean hitting the ground-based target because the curve of the Earth will get in the way.
What did you say at the end? You cut off.
The curve of the Earth will get in the way.
Okay. So this is what I understood from what you're saying. Tell me if I understood something wrong. So you're saying that military are like they're using lasers to aim from more than 100 miles away on a ground-based target. That is correct, right?
That is correct, yes. Laser targeting device.
Okay. And do you know what's the height that they're using?
The height, yes. For the fifth time, no higher than 60 foot above the surface of the ocean.
No higher than 60.
Yeah, think how big a boat is. I mean, I could literally give you 200 foot above the surface of the ocean if you want. It's still not going to make a goddamn difference when you're aiming at targets 100 miles away, mate.
Okay. So I don't know how to reply to that. I'll be honest, okay?
Yeah, that's absolutely fine. What I'm trying to demonstrate is the practical use of lasers by if they use them to blow shit up or help target things to blow shit up, then they wouldn't use this if the curve of the Earth was going to get in the way, would they? Wouldn't work. Because there'd be a finite limit to how far you...
Okay, I see your point. I see your point. It's impossible to use that type or to use it in that way unless it's a flat Earth, right?
Require a direct line of sight. You won't have a direct line of sight
if the Earth is curved. Okay.
No way.
So the military is not using the curvature of the Earth into calculations to make their laser work. So they're thinking in a level plane, in the level water.
What? What do you mean leveled water?
There should be a mile of curvature at 100 miles, over a mile of curvature. It's not there.
Okay. I also don't know how to. I don't know how to respond to that. I'll be honest.
Yeah, it's a big thing. It's a difficult concept because this, if true, what we're telling you, and you should check this for yourself.
Yeah,
literally destroys the ball.
Definitely. I guess
They both can't be true. They both cannot be true. The surface cannot be being measured flat in the way that it is at the distances that it is if it's curving at 8 inches per mile squared, which is what they tell us it is and has to be if it's the ball that they tell us it is. Like I said, this is the crux.
Hey guys, can you hear me?
Yep.
My ears.
Yep.
Yep.
Nice.
I was just wondering if you guys have some more information about this gas can theory, like, you know, about the pressure being contained.
What do you mean?
I mean, a lot of people say that the Earth must be like, it's not possible to form an atmosphere because normally the gas would disperse outside because we are surrounded by a vacuum, right? So I feel this maybe is not right, so I just was wondering what's your opinion on that.
Why don't you think that's right?
Yeah, well, because when you have a gas can, like a canister, then the pressure in the canister is the same at each point, right? But on Earth, when I climb a mountain, the pressure decreases. So it's not a canister, obviously.
Yeah, but you can recreate a gradient with pressure on Earth. It's not going to be in your can because that's not the intention.
And that's
it's got one substance inside of the can.
Gas, exactly.
Sorry, I didn't get it. It was like intercrossing.
Sorry, carry on, mate.
Your can doesn't have all the different gases with all these different densities that this atmosphere carries. So it doesn't equate. And we can demonstrate a gradient in a pressurized system on Earth with, something other than a can that you're talking about.
Okay, so you basically just take a big canister and you put in different gases, and then there would be like a pressure differential in the canister.
I don't know if you just get exasperated and then want to answer, but I can't hear it.
Hey guys.
What's up, bro?
Hello.
Why is the Earth actually flat?
Why is it flat? What do you mean, why?
Yeah, why?
What do you mean, why?
What are the arguments for it?
You mean for its observable nature, or do you mean why? Like, why was it made flat?
Yeah, why? I mean, why?
Why? Is why the right question?
Why do birds fly?
Yeah, why is red red?
I think he means like, what are the arguments for the Earth being flat, right? If I get you right.
Well, I mean, if you're asking a why question, that's like a philosophical question. Why? Are you asking like, what is the evidence of what? Like a what question? You're looking for what is, right?
How question? How is the Earth flat? I think he means.
How is it flat?
Yeah.
How?
How?
How? That would be,
have you ever experienced?
That would be a
when you're
singular question rather than why. How is it flat? It's flat because you can tell it's flat because that's how it's observable. You can tell because water is level because it always finds its level, and that's a flat surface. You can tell because you can see too far for it to have any curvature. There's no proof of any curvature. It's, and then that's how. Why is a different question altogether. Why is, as you said, a more philosophical. How is the mechanics of? Therefore, it's a better question to ask. Is all I was saying.
Yeah, I mean, what I don't get is like the stars and their alignment. It just seems kind of unbelievable that we're on a flat surface. I mean, let's just imagine it, and then all those stars, like they
stars have nothing to do with measuring the flat surface, though. So even
by looking at the lights.
Yeah, even Albert Einstein, said the geocentric model and the heliocentric model are identical. It's just a matter of philosophy. Whether you think you're spinning and everything is moving above you, or whether you think you're spinning, or whether everything is moving around you.
Oh man, yeah, Einstein was like a smart man, dude. When he said so, there must be something in it, right?
He was an alcoholic wife beater.
Yeah, I don't take Einstein seriously, but what I'm saying is even on that side of the aisle.
Dude, you just quoted him,
his
so
own fault with that. That's his point, is that even he will,
Well,
explain that this isn't the most accurate thing out there. There's nothing.
Lawrence Krauss, Stephen Hawking, they all said there are philosophical reasons that we accept heliocentrism and not geocentrism. So the question of the stars is heliocentric versus geocentric, and that's a mathematical idea. That'll work on any model you create. You could say the Earth is a velociraptor, and you can make the math work for the stars.
It would be complicated, but you could do it.
Yeah. In fact, how we got heliocentrism is Brahe backward engineered the formulations he got.
But my dude, there's a difference between the different heliocentric and geocentric vision and claiming that the Earth has a flat surface.
No, because when you're talking about the stars, it's not a question of Earth shape. It's a question of math. When you're talking about Earth shape, you need to measure the ground, right?
Yeah, well, but if the Earth was flat, then I would see the North Star from the South Pole.
Why would you assume that? Why would you assume that?
What assumptions are you carrying to that conclusion?
Yeah, well, when you navigate
that you already think you know about what the universe is what you're carrying into that. And if the Earth is the shape you think it is, what's to say the rest of the cosmology you believe is accurate as well?
The way you formulated that sentence is actually an affirming the consequent phonological fallacy.
Yes.
Yeah, well, nice formulation there, buddy. But when you're on the northern hemisphere, then when you're navigating and you want to know where... Dude, please don't interrupt me. I'm trying to make my point here. Why? Just keep interrupting me. That's kind of rude, dude, please. But let me go ahead. So when you're on the northern hemisphere and you want to navigate and you want to know where north is...
You seem to be moving on from a question that was just answered, and you've been taken apart, and you just want to move on. Can you address the fact that you've just had your point absolutely ripped apart?
I mean, I wasn't able to make my point yet because I keep getting interrupted.
No,
we pretty much know your point because we've heard that point 1,000 times.
Oh yeah, well, so go ahead and object to that.
That's why people are stopping you, because you're trying to move on to your second point without addressing the fact that you just had your first point ripped apart. I don't see what's happening.
Dude, what's going on in the background there? Are you living on a construction site or what? It's like kind of noisy, man.
Sorry, I'll take care of that in a second. Can you hear the wind or something?
You can hear it all.
Beep, 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 beep.
I'm hearing the North Pole.
Sounds like Sputnik.
So I get what you're saying, Fulbright. You're saying that, like, if you were standing under Polaris 90 degrees and you walked away 69 miles, it would decline 1 degree, and that kind of corresponds with the globe Earth model, right? But then you're also...
No, actually not. Like, I was trying to make the point that you have like a North Star, and when you want to know where North is, you just head towards the star and it always stays in north. So also you have the Southern Cross, which is basically the South Star, which is only visible at the southern hemisphere. And since in the model of a flat surface, which is being surrounded by the south...
We don't have a model.
That moves.
We don't have a model.
It's not a fixed star.
Okay, yeah, I don't.
Star in the bottom. That's not a fixed star at all. That moves through the southern sky.
Yeah, I think your confusion is why don't you see, like, if you're in the southern hemisphere, why don't you see the stars from the northern hemisphere or vice versa? That has a lot to do with, like, their distance, what they are. You know, there's so many assumptions that we have to make to just say that it's a globe based on that observation. Because you're excluding the fact that, like, perspective causes things to decline. Obviously, the further you get away from things, they go towards the horizon, right? Like, just like if you were to be in a really, really long hallway, it looked like that hallway would eventually touch the center of your eye line or reach a convergence point, and that's what's happening with the stars. You're excluding it. You're thinking in an orthographic view where something's flat, you should be able to see all across, almost like all the stars or everything. That's not the case, you know. If that was the case, then we'd be, you know. Go ahead, Moonlight.
Yeah, I was going to say that's not how you see. And two, I could actually make the same fallacious arguments and say all of that proves that we're on a flat plane and that the stars are close. But that would also be a fallacy. Because I'd be using the stars to prove the ground.
Makes no sense.
Yeah, so I could say because I go south and Polaris declines in the north, that proves the stars are close. See? See how it's fallacious?
Yeah, but if you go south and Polaris declines in the north, then the Earth
that
is
proves
round.
a flat Earth.
Otherwise,
No,
it
that,
wouldn't be.
that proves it's flat. No, listen.
Flat
That
Earth
proves it's
horizon
flat.
rises up and close.
Yeah. That proves it's flat, though. Don't you see? Because if it declines, that proves it's close. See how it's fallacious reasoning, right? Because all I have to do is change the distance of the stars, and I've got a flat plane. If the stars are close, if they're not trillions of miles away, if they're just attached not too far away, then I've got my evidence that I need. So it's an affirming the consequent logical fallacy, either direction. If I make that claim, it's a fallacy. If you make that claim, it's a fallacy. So all that leaves us with is measuring the ground. But to make the sky work, all we have to do is bring it closer and make it smaller. That's it.
Yeah, but how comes it when I'm heading towards the South Star that
I just told you, because you're looking at it's like I'm talking to a brick wall. It's like I'm talking to a brick wall. If everything is close, then it's not a problem for us. But what you need is you need those stars to be trillions and trillions. You need Polaris to be 11 trillion miles away.
Okay, mate, just okay, I gotcha, maybe I explain it different. So you get a plate, alright? And let the plate be the flat surface, alright? So you have the plate in front of you, and then you put a finger somewhere around this plate, okay? Right, so I don't care about the distance. Put it really close somewhere. It's in the south, so this is the south, okay? Now you go to the opposite side of the plate. Now, when you're there and you're being at the Antarctic, which is in the outside, and you look towards the South Star, it's in the north, right?
No, because that's not what would happen.
Yeah, it's not what we're talking about.
Yeah,
let me ask you
what I'm talking about.
In the middle, you would look from the one south point to the middle point, and then from the middle point into the other south point, or vice versa. Which you know you're totally just skipping all.
Dude, this is what?
No, my dude. How come we can see? Does anyone have a picture of the? I'm driving. So someone post a picture of the oil platform. All right. Does anyone have it? Can anyone do that?
Yeah, give me like a minute. I'll grab.
Okay. So you're gonna see this picture of the two oil platforms. Now one is like over 9 miles away, but it's higher than the one in front of it. Now if you're on a sphere 24,901 miles in circumference, you should have 8 inches per mile squared of drop from the position of the observer. But we see both oil rigs in full view, and the horizon is in front of one of them.
I posted them.
Okay.
Yeah, that's nice, but you're basically changing the topic.
No, we're not changing the topic. We're trying to stay on topic. It's a flat Earth server, not what are the stars.
Okay, so you just stay on Earth and don't look at the stars because like, the data
if you
from
look
the
at the
stars.
stars, if you look at the stars, what you're doing is you are skipping step one. Everything you understand about the stars has to be derived from what you've calculated the land to be. Because all the ancient peoples, they all saw the same stars, and they created mechanisms for telling time and season based on a flat model. So it does depend greatly on, it depends completely on how you calculate the land. Now, if the land is flat, the sky still works perfectly fine. If it's a globe, the sky works perfectly fine. You got to eliminate what works on both models and then look at what doesn't work on both models. So the stars will work fine. The stars will work fine on any assumed model that you make, whether it's flat or spherical. So we have to look at the ground first. The ground doesn't measure.
If you fly into the space.
No, Fulbright. No. Settle.
So what Mimorvet is saying, is you have to have that true axiom first. And at the moment, the whole debate here is whether the Earth is flat or a globe. The whole stars, that should be debated after we've come to a conclusion of what the shape is or whether it's flat or a globe. So that's what we're trying to establish here. And you're already moving to step two because, to be honest, I get it. Like, half of the globe arguments have to do with what the sky does, but that's just the model. Like I said, there's so many other models that can explain the same phenomena, and it doesn't mean that the model is true just because you observe the phenomena and it matches your predictions. So if we go back to step one, which is what is the shape of the Earth and how do we come to that conclusion, then we can move to step two and figure out what the stars and why they're doing what they do, which, to be honest, you might never figure out why that, because you're missing, you can't really science them, you can't really do anything with the stars. All you can do is make observations and make a model, like you know, like kind of like what you're doing, you know, but you cannot actually validate it, in my opinion. Like, you can never fully know why the stars do what they do, in my opinion. That's my opinion, by the way. Like, I don't think we could ever figure that out.
Yeah, you're absolutely right. There's no valid hypothesis that's ever come out of astronomy, cosmology, or astrophysics. There's not one valid hypothesis. And that's not me saying it, that's them saying it.
So all those pictures and videos from space are fake?
Find one and show it to us. Tell us the one that's real. Because NASA tells us that they don't have any real pictures of the Earth.
Yeah,
they have very few. They say they have very few real pictures of the Earth.
Yeah, but due to imply that the Earth is flat, you aren't just saying that NASA is lying. You aren't just saying that there's a conspiracy within a single company.
Can I ask you? I want to ask you something. Why did the entire Western world suddenly, up in one generation, start lying to their children about Santa Claus? Why is that? Was that a grand conspiracy?
Dude, I don't care about Santa Claus, to be honest.
I'm asking you because you've invoked the idea that people don't lie.
Yeah, because of capitalism, so people buy stuff.
You're creating this idea that groups of people don't lie, that corporations don't lie. You can't be that naive, can you? Like, the whole Western world decided to lie to their children, and they didn't even think it was bad.
Lie. Okay.
Dude, there are
Satellites.
71. There are
Satellite.
71.
What do you mean? No, there's not a single satellite. There's no satellite.
Dude, there are 71. Listen.
All of our terrestrial communications, all the communications you use in practical life, are all hardwired in and done through trilateration towers.
Dude, there are 71 space agencies, and 13 of them have launching capabilities.
I don't care. How many fast food joints are there that sell burgers? And they all sell burgers. So what?
So you're not only saying all 71 of those agencies are lying about the shape of the Earth, but every single person within them is lying or being fooled by their respective companies.
Why do we see too far? Why do we see too far?
Let me take this one real quick. So, no, we're not saying that all the people in space agencies are lying, because space agencies, all of them, I'm pretty sure, like the military, especially NASA, they're compartmentalized, where you don't know what the person next door is doing. You know, it's compartmentalized. It's just like the military. Not everyone is in on the conspiracy, if there is one. Now, for you to say are the pictures all fake, Well, I would have to say yes, because our observations and our measurements don't match or with the predictions of what those pictures show me. So now you're taking the faith just because there's a big corporations or governments behind these images. You're taking their beliefs or you're believing into their pictures instead of actually going on Earth and measuring the Earth for yourself. So yes, I'd rather believe that the Earth is flat or know that the Earth is flat, because we can actually directly test this, measure this. I don't have to rely on a third party to tell me what it is based on pictures that I can't even validate myself.
And he's literally arguing authority. He's literally arguing that we should trust authority.
The authority that takes their
yeah, but dude, let the authorities aside. But furthermore, every single astrophysicist.
No, see, here's the problem.
Your implication is a scam artist getting paid doing research for telescopes and instruments that will be useless.
You have denied physical measurement and wanted to move on to something you can't prove. So first you wanted to talk about stars, which you can't science. You can't go to them, test them, or measure them. Then you wanted to talk about conspiracies when confronted with measurement. Now, we're going to give you measurements, but you don't want to talk about those because measurements are real.
Yeah, he doesn't.
You want to talk about all the things. Toppings. Yeah. You like the salad dressing and you like the soup. You don't like any of the meat.
Yeah, but basically you're claiming that roughly 75,000 people are lying about what they're doing.
That's a lie. That's a lie. And that's stupid, and you're retarded if you believe that.
Do you know what an argument from incredulity is? That's another fallacy which you're invoking right now. What you're saying is that you can't comprehend that all those agencies would be in on it or lie. That's literally an argument from incredulity, because the reason that your emotions can't conceive that these people could be lying to us is a fallacy, because they all could be lying to us. We don't know, right? For all we know, they are or they're not.
Evidence.
Right, so it's literally an argument from incredulity. What you're doing, like trying to hold.
You can equate that to I don't believe in Jack the Ripper, because I cannot be that
comprehend someone that evil.
It's the exact same thing. Yeah, no, it can't be real. No, that can't be real. Can't be.
Yeah, it just seems that so many different people are involved in this major conspiracy.
Yeah, like he said again, they're compartmentalized. So all these people don't know that they're part of this.
Can I ask my dude? I want to ask my dude a question. All right. So, weapons of mass destruction. There were about 2 million Allied soldiers in Iraq. Were 2 million soldiers lying about weapons of mass destruction in Iraq, or was it 11 people? 11 people. The information went through 11 people, but there were 2 million soldier employees destroying Iraq. Are you saying all 2 million of them were in on it? Are all 2 million of them in on it? I want you to answer me honestly.
Yeah, dude, I don't care about US foreign policy because they're invading everything.
Oh my God!
Whoa!
You're so dishonest. You're so dishonest.
Doesn't care.
So dishonest. It's ridiculous.
One at a time. Come on, guys.
Look, you invoked the idea that everyone has to be in on everything, which makes you intellectually either stupid or dishonest. Now, which is it? Now, it only took 11 people to hide the information about Iraq and get us into a war that lasted 19 years.
Still going, some would say.
Look, I know you keep saying about what Meme is saying, but what he's literally doing is giving you another example that matches to what you're giving us, and it's the same thing. And when you look at it that way, since we do know 11 people were involved, and there was all these soldiers that went to war, that doesn't mean they were in on it. They just were following orders.
It's not about foreign policy. It's about the line of logic. It's about how do people act. What are people really doing? Are 2 million people lying, or are 2 million people doing a job that they were paid to do?
Yeah, I want to ask a general question. I want to ask a general question.
Because of 11 people.
Yeah, I want to ask a general question to the room. So if I'm giving an example, and it has to do with a war that was started, and has to do with compartmentalization and how information is exchanged. And then that person says, well, I don't want to talk about foreign policy. What do y'all think about that person?
They're avoid to the subject. They can't be intellectually honest, so there's no point talking to them if they can't do it.
There's not. There's none.
Jedi, how you doing, buddy?
Yeah, good. Good evening, guys. Hope you're well.
It would have been better if he's like, yeah, I understand that, but in this situation, yada yada. But he couldn't even get to that level.
No, he's just saying that only in the space agencies, is where everyone is in on everything. That's what he's saying.
Did you know what department meetings are?
Hey, did you guys ban him, or did we get our first abort of the day?
I'm just waiting until this rant stops so I can get up.
Oh, okay, I thought you left, man. You aborted already?
Cool. So, do you understand what I just said then?
Yeah, I mean, I get your point, but since I'm not from the US, I really don't care about your foreign policies.
Right, okay, so, hold on. Let me do this. So, do you understand? Hold on, my friend. Hold on. So, do you understand what a department meeting is?
Yeah, sure.
Yeah, excellent. So, if you're privy to that department meeting section, then you will go to that department meeting, and then you will filter down that information to your work colleagues, the people that are under you, right? Yeah. Now, not everybody is privy to that manager's meeting or department meeting. The cleaner's not going in there, for example. So that's how compartmentalization works, or a hierarchy system. And you've got a company, you've got, the CEOs at the top, and then that branches down to department heads, and that branches down, and that branches down. It's kind of like, I don't know, if I was to use the word need to know basis, would you understand what that was?
Again?
Need to know basis. Do you know what that is? Yeah. So all I'm explaining to you is a hierarchical system, something that we see in all industries, something that we most definitely see within militaries of the world, captains, admirals, blah, blah, blah. It's not hard to understand that industries and things like this work in hierarchical systems, compartmentalized, right?
Even this works like that.
Exactly. So this is what we're trying to tell you. It's very easy to understand. Compartmentalization, need to know basis. It's not hard.
All right. So in the NASA, for example, there's a department meeting, and then a guy is being told, yeah, dude, you have to inspect this telescope, and you have to look for this planet, and then he looks for the planet, and then what then?
There you go. He thinks it's a planet. He thinks he's on a ball because everybody thinks that we're living on a ball. So you don't need to tell him because he thinks that's where we are. So he's working within Mars. There you go. That's a planet. It's X amount of billion miles away or whatever.
How do religious institutions function? How do religious institutions function? No, let me ask you this. So how are there so many Catholics? How are there so many people that believe in Catholicism? How do you think that is? Do you think Catholicism is true?
Well, I think people just look for a sense in their lives.
Ah. So do you think Catholicism is true? There's so many people in on it.
Yeah, it's 1 billion people that believe in Catholicism. Are they right?
Yeah. Do you think it's true? I mean, so many people. They wouldn't all be lying, right?
Well, as long as they don't start killing others because of beliefs, I'm perfectly fine with it.
Oh my God, dude,
So
are you
can't-
autistic?
Yeah. Why can't you just answer a question? Why can't you do that?
Yeah, I answered it.
Yeah,
There's some reason you won't answer a question. Like I asked you, is every Catholic in on it?
In religion. In on it.
In on it, yeah. Are they all in on it?
Well, what do you mean by in on it? Like practicing it regularly, or?
I'm just asking you. Why is Catholicism true? I'm asking you.
Could be.
Could be.
Yeah. Who am I to judge if it's true or not, right?
Ah. So you don't know anything about it, and so you're going to say you don't know. Which it's a good position to have. Right?
Yeah, it's because it's religion, right?
What exactly? Yeah, it's a religion. And you know what else is a religion? Heliocentrism. What exactly do you think you know?
Whoa! Flat Earth is not a religion. That's a direct measurement and observation, mate.
Yes. The Earth is measurable. If we measure it as flat, what does that mean?
I don't know.
It's flat.
Some errors in it, or?
My absolute dude, you're having a real bra moment. If something's measured flat, what is it?
It's been measured flat. by someone, and then another fox comes around and he measures it's round. What is it then?
Oh, has anybody measured it round? Sorry, everybody I know has measured it flat, mate.
Yeah.
No one's measured it round. They presuppose it's a sphere, but they've never measured it. That's physical.
There must be a special place where the curve is hiding.
Yeah.
Maybe we just don't have access to it as peons.
That special place is in the hearts of the Glovers.
That's it. It has to be a globe, guys. It has to be. It just has to be. So many people that have to lie, yeah?
I found it one time. It was at the back of a wardrobe in my auntie's cupboard.
No, that's Narnia. That's not Narnia. No.
Oh, shit. No, that's right. No, it wasn't in the cover. It was Narnia. That's right.
We told this guy about direct measurement, and he will not talk about it. He refuses. He's having an emotional reaction and invoking authority and invoking argument from incredulity. Like, he can't believe people would lie, therefore they're not lying.
Well, it can be. No, wait a minute. Are you telling me people lie?
I can't believe it either. This is news to me.
Oh, God.
I'm reevaluating the world now. Hold on.
No, that secular governments have killed 1.5 billion people in 100 years. I think there's a reason to not.
Yeah, alright, people, I highly apologize, but I have to leave. Like, it's not being a disrespect, but I'm getting a call right now, so I'll get in touch later.
You're welcome back anytime.
Is it from your ass doctor? Does he want to stitch it back on? Because it just got handed to you?
Hey, Farguten, are you trying to get a word? Yeah, go ahead. I was just going to let you get the floor. Yeah, go ahead.
Oh yeah, well, hello. I was hanging here for a few minutes, a few 15 minutes while watching all this going on, and I must say that they didn't quite look that good.
The last gentleman?
Oh yes, especially the last one. He was a bit fast-paced.
You seem like an interesting guy. So, what side of the fence are you on? And in this debate here?
I think just to set it all a bit straight on my side, I'm a current student of physics, so I place myself on the very, very other side from yours. That the Earth is a globe, and everything that entails it.
Okay, cool.
Yeah, that's cool. Glad to have you.
That's good.
I just have one question. I'll let you guys take care. Is there a difference between physics and theoretical physics?
Theoretical physics leans more towards generating new mathematical models and theories that are then observed and verified by experimental physics. They are both both sides of the same coin, experimental and theoretical physics, but they just focus on different areas of physics.
Are you saying there's no difference?
Oh, it's a difference of either spending the whole day in a lab or right next to a blackboard, doing math or creating theories to test. That's the word.
Making stuff up, yeah.
The difference in physics and theoretical physics is one is doing experimentation to draw a conclusion from the hypothesis test, which comes after the hypothesis, which is a supposition as to what causes a natural phenomenon, versus theoretical physics, where you have presupposition or theories as to why something's happening, and then you draw up a mathematical abstraction with that. Would you agree to that?
Yeah, in the broad sense, yes. Physics can be split this way into either focusing on doing experiments or creating theories to test in those experiments. I mean, like 50, 60 years ago, there wasn't much of a distinction because back then everything was a bit more simpler. So physics can be at the same time very good at doing mathematics and theory, and also doing experiments in a laboratory with glass, bells, and vacuum pumps, and such things. But yes, in a broad sense, yes. I mean, there might be some disagreement in the details, but in a broad sense, I didn't hear anything that was blatantly off. So yeah.
Yeah. So were you in here when we were explaining that all of these theoretical physicists and different astronomers and people with PhDs or whatever, they're all on record saying that there's no way they can actually prove that the Earth is heliocentric in a heliocentric model, as opposed to geocentric and stationary?
Yeah, I did hear you talk about it, and I think there must be some things to remember. I mean, this might seem like a cop-out, but it still must be kept in mind. Those quotations, where did they came from? Was it from a book they made to the public or in a textbook? For instance,
all kinds of different ones. So they have lectures they gave, textbooks, books, like infamous books like authored by Stephen Hawking. So these are direct quotes attributed to the people in this field, supposedly subject matter experts, right? I mean, within these quotes, we have Edwin Hubble and Einstein, and again, Stephen Hawking, Lawrence Krauss. It's ridiculous. We have the Royal Astronomy quotes. So an attempt to try to hand-wave dismiss the whole thing with some excuse isn't honest. You should look at each quote individually, right? And if you really want to think there's a globe, then you may instinctively want to assume that they're out of context. Well, I encourage you to check them. They are not.
Oh, yeah,
here's another one. Go ahead.
Oh, yeah, that's on. Yeah, all right.
Cool,
sorry.
because it's the best way to learn, right? If you think that those people are right about the Earth being a ball that spins around the sun in a heliocentric model, then you should fully understand what it is that you believe, right? So whether the Earth rotates once a day from west to east, as Copernicus taught, or the heavens revolve once a day from east to west, as his predecessors believed, the observable phenomena will be exactly the same. This shows a defect in Newtonian dynamics, since an empirical science ought not to contain a metaphysical assumption, which can never be proved or disproved by observation. Dennis Sciama, the unity of the universe. One of the founding fathers of modern cosmology.
Yes, I do get it, but to be fair, I'll tell you about those quotes. They are very interesting, and I would love to see them search back to the source and see that in the better context. Because it is a quote.
You understand? Well, we need to make sure they're understood, right? So, like when it says this shows a defect in Newtonian dynamics, right? We're talking about Newtonian physics, right? So, like this shows a defect in Newtonian dynamics, since an empirical science ought not to contain a metaphysical assumption, which can never be proved or disproved by observations. That's a very important quote if you understand what it's saying. He's saying that for Newtonian to be taught as physical definitive reality or make a claim as such is ridiculous because it cannot claim to be empirical science when within it is contained a metaphysical assumption. That's philosophy, religion, belief. That's not empirical science. The conflation debunks it.
What do you think he meant by this metaphysical condition?
Yeah, like these fantastical concepts of gravity causing us to move around in this other concept of a universe with solar systems.
Metaphysical, abstract.
Yes. I do get what you mean, but the thing is, Newtonian dynamics, the model in which forces are applied to objects which then cause them to accelerate to accelerate. Those can work without a local acceleration, i.e., gravity. That's the whole equation F equals ma, from which we can derive many interesting things about how things can change in their position and speed.
That's not the point. The point is that using it doesn't differentiate that the Earth is spinning and there's magical force called gravity that's causing it, or that the Earth is stationary and things just fall based on the equilibrium being side over top of it, not moving. That's what it's saying. That's why it starts off with the distinction that you couldn't tell the difference if the Earth was moving to the east or if the sky was, or from the east.
Yes, I mean, if I just go outside and look at how the stars move across the sky, from that alone I wouldn't be able to say which one is moving because that's relative. Yeah, that makes sense.
That's right. So how you apply Newtonian dynamics is different if the Earth is moving or not moving.
Well,
so
of course,
if you understand there's a difference if the Earth is spinning and you're applying Newtonian dynamics than if it's stationary, which is why he's explaining that it was nonsense for Newtonian dynamics to make claims about definitive physical reality, including the assumption the Earth is spinning, because there's a metaphysical assumption intrinsic within it. It's just a belief. It's a philosophical belief of the Earth being a ball that spins around the sun. So since of that philosophical belief, you cannot conflate that to science. That's what the quote is saying.
Yes, but the thing is, you can apply the basic Newton laws of motion, and and I don't know if I remember this correctly. There is one of the three laws says that there is a local acceleration. Is that right? I don't think I can quite remember them correctly. If you can correct me.
It's an overview. It's not to get into random specifics of what you think about Newtonian anything. It's an overview of the foundation of Newtonian dynamics as a thing that was proposed. That's what it is. It was postulated as explanation of definitive reality when in fact it requires an assumption that is metaphysical, ontological, spiritual, philosophical, conceptual, abstract,
religious.
I frankly disagree with this. The laws of
what part of it do you? What part of, before you continue? What part of it do you disagree with, and on what ground?
That's the basic form of Newton's law of motions. The three basic laws entail.
No, we're talking about the difference between. We're talking about the difference between physics and metaphysics. Still, right? And so we're pointing out that you shouldn't conflate the two, because natural science and writing on the chalkboard is two different things. What about that do you disagree with? Because this is what it was summing up.
But it's not a metaphysical. It's a physical assumption about reality. And metaphysics is by definition beyond reality, unknowable.
Right. So these things that are balls that have mass that we haven't verified or validated in any way, it's just presuppositional, which presuppositions don't belong in hypotheses or scientific theories either. Which part of this do you agree or disagree with?
Let me think. Sorry, could you repeat that question? I didn't quite catch it. I'm sorry.
Hypotheses don't have presuppositions that are predetermined, such as the mass of objects and how they move because of a force, without being able to validate or verify them in any way.
Hypotheses can have presupposition if they can be valid, and they can be valid if they are valid in an experiment.
No, but presuppositions aren't tested. Only suppositions are tested. So the supposition is what caused the natural phenomena observed. That's all it is. Then you run experiments to figure out either my independent variable does cause the natural phenomena or it doesn't, which gives you either a positive result or no result. Then your conclusion is the result of the hypothesis test. That's it. That is very different from a presuppositional statement that will not get tested.
Yeah. So, like, let me ask you this, bro. So, like, do you agree that in science, preference or convenience or philosophical idealism, so philosophical preference, right, or convenience, is that included in science?
You are talking. Yes, but those are subjective notions that differ from person to person, right?
That's right.
No, in science we strive to not include these in objective models. That's the reason why it doesn't science at all, to create as close a models to reality as possible. If you include these cultural notions of philosophy, you model it to a local version of reality, which is not, real. Like, for instance, trying to incorporate your notion of, let's say, superior genders to others. If that is not true in reality, then it would not be. Then it is not true. No matter what you think, reality is the ultimate arbiter of truth, as in or models, which work and which do not work.
Exactly.
Hold on. Listen, I don't think he's understanding what you're saying. Really?
Oh, but I got him. Because where he's about to go.
I think he needs like a specific example, example of where this fails.
Yeah, maybe so. Go ahead.
You want me to give it to him? Okay.
You can.
So we have epicycles, right? That predicts the planetary motions as accurate as the second, I can't remember his name, Kepler's planetary laws, right? So Kepler's 3 planetary laws of epicycles. They're 2 models. They both have the same predictive power. Now, which one do you choose as the reality?
That's a good question.
So this is what they're talking about, how and even if you have one model, right, there could be another model out there with the same predictive power that you just nobody's thought of yet. This is why you can't say models are reality.
Of course they're not reality. That's true. They are a fiction of our humans, but still, if we try to model nature, reality in those models, we will not get a true value, but we will get a very accurate, pragmatically accurate value. So in the case that we have these 2 models with the same results, then that's a big problem. That's a big problem in science. It's called the indeterminate. It's indeterminate. In which case, we try to step back and see from what tinier models are the bigger models made out of. What are their predecessors, as in on which theories those models are being based on, or models. And then try to evaluate closely and see if those models that those 2 are made out of are actually accurate, and see if they can fail in some experiment or observation.
Okay, so philosophical preference and convenience can only taint any attempt to accurately recollect on reality. So a model is tainted intrinsically if it has some philosophical undertone of preference or convenience.
It's subjective preference. Philosophy is a very wide subject. For instance, it does like a logic. It was originally included in philosophy. It was a field of study, which then evolved into math. So So if you mean first of all by subjective cultural or social values, then those can only model the experiment under the model unless that model tries to explain these social dynamics, like from groups and nations.
Okay, bro. So I'm not trying to. You did pretty good. You admitted there's a difference. So here's a quote. The ancient argument over whether the earth rotates or the heavens revolve around it, as Aristotle taught, is seen to be no more than an argument over the simplest choice of a frame of reference. Obviously, the most convenient choice is the universe. Well, we just talked about how convenience is literally irrelevant to actual science, right? Nothing except inconvenience prevents us from choosing the earth as a fixed frame of reference. If we choose to make the earth our fixed frame of reference, we do not have to, we do not even do violence to everyday speech. We say that the sun rises in the morning, sets in the evening, the Big Dipper revolves around the North Star. Which point of view is correct? Do the heavens revolve or does the earth rotate? The question is meaningless, which actually isn't meaningless, of course, but do you understand what he's saying?
Yes, unless you try and see what other metric these two models predict and how they differ, then if you just focus on this simple notion of whether I'm rotating or the sphere or the universe is rotating, then it'll be very hard to see which one is more right in this case or more accurate.
No, they're explaining there's no difference in predictive capability, and I'll give you plenty of quotes about that as well. That's what they're explaining. It's nothing more than, it's not that one's more viable than the other. And if that were the case, it would be geocentric because that's the default. This is what they're saying. I've showed you quotes of them saying it right now. Okay, so it is nothing more than a convenience issue, a philosophical preference. So you cannot adequately make claims about definitive reality if they are confined to your philosophy. If your philosophy is wrong, as you just said, then automatically your claims about reality are wrong.
If my philosophy is, as in my approach to or my view of how science is done, is that what you mean?
Yeah, you just now agreed and long-winded that philosophy is not science, and even Indio jumped in and gave you an example. You have to make some philosophical decision, or you just choose with arbitrary means which one you want to believe in. That is not science, and people are shocked to find out that, in fact, heliocentrism versus geocentrism is that very type of a decision.
Can I read two quotes also?
Oh, sure. Yeah, sure. Go ahead.
So before I read these quotes, now the reason that we're pulling these quotes is because you just said yourself that in science, if you have, two explanations for the same thing, something is wrong?
Well, if you have two explanations that are by themselves contradictory to each other, as in they can be both true, then you have to, then you find yourself in a very serious problem. As in, you can't say which one is which. You can't prefer which one is better solely based on what their predictions. Now you can try and be a bit more pragmatic, saying which one has more complex calculations or which one makes more assumptions. I think that's called the Occam's razor.
So you do know that that would be the heliocentric model. That would be the one with more assumptions. But setting that aside, because you're probably going to ask for that citation. So reading this one right here, all masses, all motion, indeed all forces are relative. There's no way to discern relative from absolute motion when we encounter them. Whenever modern writers infer an imaginary distinction between relative and absolute motion from a Newtonian framework, they do not stop to think that the Ptolemaic and Copernican are both equally true. Ernest Mach is his name.
So did you put it into the chat? I can't seem to find it.
No, I didn't. I'm just reading it. I can put it in there for you in a second. But here's another one. Einstein and Infeld, The Evolution of Physics. The struggle so violent in the early days of science between the views of Ptolemy and Copernicus would be that would then be quite meaningless. Either coordinate system could be used with equal justification. Two sentences, the sun is at rest and the earth moves, or the sun moves and the earth is at rest, would simply mean two different conventions concerning two different coordinate systems.
Yes. Again.
So you don't see how it parallels with.
Sorry?
Oh, my bad. You don't see how this parallels with what you said about the problem in science. If you know what you just said prior, you don't see the parallel here. And then you said, well, the one with the least assumptions, Occam's razor, and I said, well, the one with more assumptions is the heliocentric model.
The thing is, the number of assumptions is not set in stone. Anyone can try and question the assumption and then split them into small assumptions. But it's more of a which one is probably more accurate. It's a guesstimate. Unless you can definitely discern which one is more.
But it's not science, though, right? Because it's a problem.
No,
or is there now not a? So it's not a problem.
Operating by these estimates and guesses is more about pragmatism.
Estimates and guesses. That isn't science, is it?
No,
natural science. I'm sorry. Natural science and dealing with the physical and natural world through the scientific method. What you detailed is not that, right?
It's not accurate. That's the problem.
I'm sorry. I'm sorry. The question that I'm asking is guessing a part of the scientific method, or, well, outside of the hypothesis, right?
Well, sorry, go on.
Is calculation and guesswork without the test of a hypothesis science? Yes or no?
If you don't test your guesses, your hypotheses, then you can't really say that they are true because you didn't test it by nature, but by experiment. So,
okay.
So they only remain hypotheses, unformed and unbased. Of course, they can have very elegant maths, very nice results, but if you don't test those results in reality, saying if you set an experiment that can tell you if this number is the same number as the one measured, as the one that came out of this model or hypothesis or theory, then it just remains a hypothesis. Experiment is the sole judge of truth, accuracy, truth in this case.
Okay. So anyway, man, dude, we're trying to explain to you that it's philosophy, right? So they did this thing where they looked at the microwave background. The idea is that it's all the energy in the furthest parts of the universe they can see and all this nonsense they make up. Well, it showed you that everything was dispersing away from the Earth perfectly. And so here's another quote, but when you look at the cosmic microwave background map, you also see the structure that is observed is in fact, in a weird way, correlated with the plane of the Earth around the sun. I need you to listen to this part, bro. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. That would say we are truly the center of the universe.
Yes, if that was not a coincidence of alignment, then it would be a very strange thing in the and would warrant some further attention.
Okay, I'll go find the quote that explains to you. It's nothing about it's.
Why do they call it the?
That's not how.
I want to know why do they call it the cosmological axis of evil? Why is there a moral connotation to what's supposed to be a scientific question? That's what they call this observation that Earth appears to be in the center of everything. Called the axis of evil.
The axis of evil.
Yeah, cool. Cosmological axis of evil.
Correct.
Yes, that's a name.
Oh yeah, so astrophysicist right here. The apparent alignment in the cosmic microwave background in one particular direction through space is called evil because it undermines our ideas about the standard cosmological model. The Copernican principle seems to be in jeopardy. So he just told you why they call it evil.
Yeah, that makes sense.
And then they came up with a mathematical explanation to band-aid the issue on top of the bad science. You don't see a problem with that?
Wait a minute. Could you expand on that, please? Elaborate.
It's been a long time since I've... So, after they came out with this result, maybe India can help me out. What did they propose to correct for this issue? Was it dark matter, or is that something else?
I have not yet
No,
studied
that's
this
something else. I
matters.
actually can't remember, but they did say they came up with some weird geometric thing. I don't know where, like, I can't remember off the top of my head, and I'm not at my laptop, so I have to
Well, they
like,
haven't really
I
come
don't
up
know.
with much viable at all, from my understanding. I'm trying to find the quote where the dude just admits as much.
No, I saw a Vsauce video on it. They did have a something, something like maybe things are different at different scales or something. Like physics are different at large scale. I think it was something like that.
Yeah. Well, that's what they're gonna have to say.
I mean, physics as we have it today does differ based on what scale we are, located.
We're literally sitting here hearing you admit that everyone that you look up to doesn't know anything about what's out there on that scale, or even about the scale, or how to prove the scale, or that they know anything about the movement in the scale.
No,
how can you then turn around and say that it is like that? We're literally covering in excruciating detail how the people that have given you this story, when you say scientists and they are telling you that they don't even at all know how to adequately map out that scale. They have no idea what it is.
Yeah, I posted the picture with the axis of evil, and yeah, they claim they sent a satellite in space to measure the microwave cosmic background radiation, and they detected. So this satellite was like above the Earth's surface. And the problem is that this satellite detected that actually the Earth's North Pole is the center of the whole universe. And this satellite was not in that center point. So whatever it measured, it found out that everything pinpoints to our North Pole. So in that sphere of scan, which they claim they did, or a dome, they found that North Pole is the very center of everything, of the world and the sky. And they call it axis of evil because, it demolishes the heliocentric model and also the Big Bang theory.
To be frank, I have not yet looked at this particular issue, and to say anything on it from my side would be an opinion in this case.
In the Big Bang theory, the center of the universe is very, very, very far from our galaxy.
The thing is, there is no center of the universe. That's the whole.
Yes, there is. Yes, there is. In the Big Bang theory, there is a center of the universe. Yes.
Right. So, I was able to find a quick article, but yeah. So the problem with the CMB is specifically off of the back of the Big Bang Theory, quote unquote. We wouldn't expect to see what they saw with the cosmic microwave background. That's the problem. Right here it says, at the heart of the picture is the cosmological principle, which says that the universe appears the same on the largest scales no matter where you happen to be looking. This is what you'd expect in the aftermath of an explosion like our Big Bang, with all the constituents winding up mixed together in a randomized homogeneous soup. The reality, it seemed, wasn't like that, meaning the observations didn't match the model.
Yeah. And another funny thing about this satellite measurement, when they did the first measurement and they found this, they said, some things inside the satellite, some sensors must have been miscalibrated. And then they reapproached the problem, they checked everything, all the systems, and then they did the measurements again, and they found the same result. And also a third time, because the second time they also claimed there must be something wrong with the satellite. And they checked it, and then they did again the measurement, and they got the same result. And after that point, they dropped the project.
Just so you guys know, I've heard a lot of people screw that word up. It's homogeneous. Homogeneous.
Yeah,
homogeneous.
Say the adverb version. Wait, say the adverb version. That's the hard one.
Yeah.
It's the homogeneous. That's what it is.
Yep.
No, it's like hypothesis and hypothesis. To me, it's tomato.
Well, they're two different words, homogeneous and homogeneity. But here's
Is it? I don't know.
Yeah. Here's a different bro for you. So dark energy appears to be in the dominant component of the physical universe, yet there is no persuasive theoretical explanation for its existence or magnitude. The acceleration of the universe is, along with dark matter, the observed phenomenon that most directly demonstrates that our theories of fundamental particles and gravity are either incorrect or incomplete. Most experts believe that nothing short of a revolution in our understanding of fundamental physics will be required to achieve a full understanding of the cosmic acceleration. For these reasons, the nature of dark energy ranks among the very most compelling of all outstanding problems in physical science.
Yeah, that's true.
Yeah, so what they're doing is what they're doing, instead of going and even acknowledging that there's a viable option, which is that the Earth is stationed with a fixed frame of reference, they're frantically trying to explain the other as if it's not even an option. That is not science, is it, right? That is religion. That is zealotry.
And forced to religion. Not to believe it, it means to be a heretic for
He's
them.
sitting here saying, we have to scrap everything. Our fundamental understanding of everything has to be wrong. And they're not even going to address that there's one other alternative that isn't wrong at all. And all this does is confirm it even more. And they pretend it's not even there. That is religious zealotry.
But that's not quite true.
It's literally true.
I'll tell you why that's not true. Because
Wait. What's not true? Specifically.
The notion that the geocentric position of the Earth is still remains a viable alternative to this problem that you mentioned.
Okay. So you're answering a question that wasn't asked.
I'm answering an issue. Can't I do that?
I'm just saying you're answering a question that nobody asked here instead of addressing directly what's been said here.
I'm just spotting up. I
know because the point that we're making to you is that though both mathematical representations or coordinate systems are identical, actually practically the same. The only reason that the Ptolemaic model is not viable is simply because they don't want it to be, because they don't feel like it should be. And there's tons of quotes where they say specifically that. There's no actual evidence, according to them, that could go against this. There's no hypotheses or no test that would disprove that the Ptolemaic model is correct. But on the grounds of philosophy alone, they accept that we're not at the center of the universe. So what about that is incorrect?
When you disagree with it, you're disagreeing with the people that brought you your belief.
Well, to be frank, these are quotes. And the problem is science isn't untrue quotes. You are basically distilling a whole position to a few sentences.
They're not true quotes. Okay, so what?
No, they are true.
Wait,
but
okay, don't.
Oh, sorry. Yes, sorry. Go.
So all you can try to say, and I covered this with you earlier, right? Because we're experimenting with this, and what we found out is that anyone that needs to cling on to the ball, they don't have many options here. It's very difficult for them because they think they know the Earth's a globe because they appeal to this idea of these superhero scientists with their capes on that did it all for them. So when you start to bring them those people one by one, and you show them what they're actually saying to explain what it is that they hold to be true, right? Then you don't really have many options to disagree with it. So the only thing you can really say is, oh, this must be taken out of context or cherry picked. Now, if something is cherry picked, that means that if you left it in context, it would actually reveal information that was contradictory to what you're claiming it says. Not one single quote that we're showing you is like that. They're all completely in context, and we encourage you and any of the readers to look up the citations and go verify this. I did.
All right. I thank you for the quote that you have posted in the chat, and I will go look at them later.
Okay.
But you should already know this, because in academia, these kinds of arguments happen all the time. There are hundreds of models. Like, you should know them if you're in school for this stuff.
So do you know what...
I'm trying to figure out what's going on because I'm an outsider looking in. I didn't go to university. And I know this. Why? Because the people at university are informing me. Because I care about the information, right? So I don't understand why you're just hearing about this today.
It's not that I'm hearing about it for the first time. It's about that I'm hearing this particular. Yes, I am kind of hearing about it for the first time because physics is a very large body of knowledge. So to expect anyone to know every single bit of it is
No,
I get what he's saying. I get what he's saying.
Very limited.
I get what he's saying because he's lumping physics in with theoretical physics, and we get that already. That's
okay.
Please continue.
Sorry, but
okay, well, we get it, man, but we need you to understand what we're trying to inform. Like, the reason you don't know about all of it, even if you are studying it, is because they don't teach it. That's right. They don't actually teach it, because what it's set up to do is to get other people to try to help figure out the holes in the story. That's literally what it is. You're going into a field of study that has already made the assumption. That's what astronomy is. That's what modern astronomy is. It is a field that has made the assumption of the Earth and its position. It doesn't even cover the fact that that entire field is actually not even viable or in any way has been proven. They just assume it, and then they try to teach you the details about what's wrong with some of the stuff and mostly what they think they've gotten right. And they want you to, over the course of years, once you fully get the fairy tale, try and help them piece the fairy tale together. We're letting you know the people that helped bring you the modern version of the fairy tale let you know they had to piece it together just to even propose it to you, and it's with all kinds of stuff they can't prove or understand. There are all kinds of stuff they can't even adequately explain. Do you see the bigger picture, bro?
I think I do get what you are meaning meaning to say, there's the idea that you're trying to get across, that this is a big narrative formed from narrative and not from reality. And it's trying to make a fairly fitting narrative of the real world that can be, or should be, fairly easy to find spots where this narrative should and will agree with reality, or i.e. experiment.
Yeah. So what exactly is it that you're going to school for?
Physics. Science in this case.
That's a super.
But of course, it's a very vague idea, I know. But still.
Okay. Fair enough. It's cool. So to understand the physics of the natural world, and it would depend on where your focus is. So are you interested in explaining physics on the Earth, or are you interested in explaining physics in outer space?
Imaginary.
Well, it is kind of true that some experiments done on Earth will be different than ones done in space. But so the first thing is to try and see what the underlying physics would say would happen if it was done on Earth or in space.
You're answering a question that wasn't asked. I don't mean to be rude.
Oh, of course.
I'm just pointing out that a question was asked to you, and I don't know if you're aware or not, but you're not answering the question. You're answering a question that no one asked.
Okay, well, I must try to get to it through this context, but all right. I don't really care if it is done on Earth or in space because I believe it is universal, depending on the local context. Like things don't fall in space, but on Earth they do.
Okay, so anyway, dude, I'm just gonna fast forward this, dude. The reason I brought it up was I'm asking if you wanted to explain physics on the Earth or not. All right. Well, because if you want to fully understand physics on the Earth, you need to look back and see what brought us to our understanding of physics that we currently have on the Earth. For example, electricity and everything that we use in the world. And so when we look back, then we'll figure it out. And so all the people that gave us everything we still use for physics on the Earth, the original people, they actually assumed there was an ether. Then there was a test where they tried to.
Oh, sorry, you cut out.
They try to show you. They try to do a test that proved that the Earth was spinning in the ether, and it showed that the Earth was completely nil. Its velocity. Its velocity was nil, nothing. So it was like, damn, what do we do now? Obviously, the ether must be wrong because we can't even entertain the idea that the Earth's not moving. That's what happened.
Well, yes, that's make us
funny thing,
right?
These laser interferometers are the most precise measuring instruments in automotive industry. Yeah, we use it to measure micron precision car parts. Yeah, and when you put the part that you made, to measure it, its dimensions, so that it fits the tolerances accepted. If you move that table where that interferometer is, that instrument, when it's measuring the part, you're messing all the measurements if you move the table. So they don't work if they are in motion, those laser interferometers.
Yes.
Yeah, so they show you that, speed, velocity in space is imperative. They have to be still so you can perform accurate measurements. If it's not still, if you install this interferometer in a train and you try to measure any component, you will get fake readings. You will have to take the speed of the train, which is moving, and actually equate that into that measurement anomaly readings, and then you will get your real value.
Yes, that's true. Yes, that's true.
So how can something have zero velocity and it's actually constantly accelerating?
Acceleration doesn't always mean that the speed changes. Only the direction can change.
Well, we are always moving in a electric and magnetic field. Yeah, whenever we make a step in the world, we are moving in a electric and magnetic field. Yeah.
Yeah, and really the important part that you need to get, bro. I brought this up because you need to understand what happened. Okay, because obviously as we show you these quotes, you don't know what's happening. They found out the Earth wasn't moving. They had to pretend that wasn't the case. They didn't even entertain that the Earth was moving. So then the theory of relativity eventually was come up with. And they took something called the Lorentz contraction, okay? And Einstein tried to apply it to the actual apparatus in the Michelson-Morley, saying that the apparatus itself, the physical apparatus, was contracting. Literally, okay? It's insanity. And that's just the beginning of the insanity. Then the theory of relativity goes on to desperately attempt to explain how the Earth's a spinning ball on an axis, but it's going to appear to be the exact opposite. That's what happened. That's what relativity is.
As a physics student, I would like to ask you one question, if you guys okay.
Sure.
Yeah, as a physics student, do you believe in Einstein's relativity theory?
I've only had experience with the special theory of relativity. I've not yet encountered the mathematical theorem behind the general relativity.
Okay, so my question is simple. Do you believe that your feet are older than your head?
That depends on what you usually mean. As in, do the photons that left my feet, how much time elapsed since they departed and since they arrived in my eyeball? Then,
so you believe it? So you believe that your feet are older than your head?
The feet are older than I see them.
No, than your head. You know, your head is not where your feet are, and your feet are not where your head is. They are at different position locations at all the time.
But the relative speed velocity is nilch, zero. In that case, they both experience the same time.
Not according to Einstein's theory of relativity.
Could you elaborate on that?
He claims that your feet are older than your head. Yeah, the twin, which goes into space and comes back, will be younger than his twin brother.
Yes, but do keep in mind that the twin was in a spaceship moving at very high speeds, very high velocities.
Yeah, and in your heliocentric model, yeah, your feet are on the ground and your head closer to the sky. So the radius from the axis of spin is different. So your velocity in space is different than your feet.
They do still have the same angular velocity.
No.
Radius, dude. If you're in a little gravity well space-time fabric, then you're in a different place in that relative to the mass that displaced that magical space-time fabric. So you would have a different effect, and he incorporates time to that, right?
Yes. Oh, that's general relativity. Yes, that's if you are including that one, then yes, those will have different time spans, but of course very tiny, very tiny.
So your feet. Then I was right. You believe your feet are older than your head.
I was assuming that you were speaking about special relativity, but yes, from what I know of general relativity, then that would be true. Of course, you wouldn't really know you wouldn't really detect that.
Do you think that it's normal to believe that?
That's pretty crazy, bro.
It is not common sense.
Do you think it sounds normal? Huh?
No, it's crazy, I know. But the thing is, we cannot rely on common sense in these cases.
Oh, that's right.
Right.
You mean actually you have to exclude common sense? Is that what you mean? You have to get rid of it.
Look, where do you think common sense came from?
Common sense is inherent in our reality. Common sense is inherent in our reality, and whoever made it or whatever made it.
Yeah, I mean, they come from your senses. That's why it's in the word. That's why the heliocentric model is, by definition, nonsense.
Well, let's get to the let's get to the crux of the philosophical debate.
Okay.
So now people say, what shape is the Earth? Is it flat or is it round? Now, problem number one: flat is not a shape; it's a description. It's an aspect of something. So automatically, this juxtaposition is that the media puts out is already incorrect on arrival. So the question is it a sphere or is it not a sphere? So how do we determine that it's a sphere? Well, they've given us certain methods to calculate that it's a sphere with a certain dimension. Now, being that that's the case, we can actually measure and test to see if the sphericity is there or not. So before we even go into that, if the Earth isn't a sphere, what really changes?
Okay, well, on the locally, like within your room and such. So now, actually,
No. If it's not a sphere, like if the Earth isn't a sphere, what does that change academically for you?
Well, I was getting to that. Locally, not much difference would be felt. Like your cup of coffee wouldn't be different on the different laws of physics.
Well, is there any difference though? You said not much difference. Is there any difference? That's what he's asking.
Oh yes, difference would be that under known laws of physics, a series of things would happen depending on what actually do you mean by flat Earth.
Okay, so all the physics were come up with on the assumption that the Earth is stationary and flat. That's the only way we can physically do anything in the world successfully. So physics, if it's science, then you can physically test it, meaning you can use it. You can do something with it successfully because it's physically true. It's physics. That all assumes that the Earth is flat and not moving. So when you say on the local scale, not much would change. No, the answer is that literally nothing would change. And if you claim the Earth's a globe, you just have to say that it's identical to what it would be like if it was flat and not spinning. But relativity says it just tricks you. It's an illusion. And that must be true.
Well, let's not for a moment include general relativity because I don't have the math behind it to tell what would be the consequence.
Okay,
so,
it's just important to understand it, man, you know?
Yes, I do know what you mean. But when you ask what will be different, well, to answer that, I would need to know what is different in the scale on the Earth. So would this flat have a thickness? Of course, we know
the deepest anyone's ever gone in the Earth, ever, is under 8 miles. So it doesn't matter what anyone says about anything beyond that. Literally means nothing. It's just a fairy tale. So we know nothing more than that.
So let's also go on.
Well, yeah, because when the globe Earth made all kinds of predictions about what would be all the way down to the 8 miles, they were wrong about the entire thing. So that definitely doesn't help out anything but flat Earth. And that's the point we're making, is everything is like that. Let's use radio waves for an example. What would it change if the Earth's flat? Nothing. That's how we use them. We shoot them horizontally for thousands of miles.
Not quite. In a flat Earth, the signal bouncing back from the ionosphere would travel a larger distances because they would encounter the upper bounds of the object at a different angle. This comes from.
Well, I didn't really want to get into. I don't know. Maybe I asked the wrong question. So what I want to do is take you to whether or not the Earth measures to be a globe or not, and then go from that perspective, because we can't measure it not being a sphere, and then you then say, well, it wouldn't work if it weren't a plane, therefore it is a sphere because of lasers bouncing off the ionosphere, or whatever the case.
But
right?
real fast though, I think it's important to make him before that. I mean, okay, the conversation was, so like, what would be the difference? And so I brought up a perfect example that not only would there be no difference, but it's just how we actually use something. And so he said, nuh-uh. He needs to know specifically, this is a good example because this is how the whole thing is going to be for you. You think right now, nuh-uh, the radio waves wouldn't work like that if the Earth was flat. Now, here's what actually happened. Someone named Marconi sent the longest radio transmission ever at the time, over 2,000 miles, 2,200 miles. All the people said, you can't do that. The Earth's a ball, and it'll block it at 200 miles. He ignored them. He used line of sight. He horizontally hit his target the first attempt, 2,200 miles away. He then ended up sending one 10,000 miles horizontally, hitting his target using line of sight directly in front of him, assuming a plane underneath him. Then people had to theorize with the idea that there's an ionosphere up there, and there's an area where it actually reflects back down and comes down and lands on the globe. Now, that's what actually happened in actual historic reality. That's what happened.
Yeah, that's a good example of what you talked about before, about the two models still giving the same result. So in either case, the signal did go a very long distance, and in your model, on flat Earth, you say that the signal went further because there was no bend, no curvature, so there was a line of sight between the target and the receiver.
Correct.
And also, yes, and on the globe Earth, another idea was formed that there could be something like that, or can be there might be something that can reflect back a portion of the signal from this layer of ionized atmosphere.
Right, but they came up with that idea to try to explain how it could have happened on a globe. They said, you can't do this. It's physically impossible. There will be a huge hump of Earth curvature physically blocking the radio waves. You cannot send it that far. He ignored them, sent it anyway, and it hit his target the first try, 2,000 miles away, and it was supposed to get blocked by the Earth's curvature at 200 miles. But then he sent one 10,000 miles. Okay, so the facts are that when you assumed the globe, you said you couldn't do it. Then you physically did it, and we do it all day, by the way, every day, all around the world. Okay, and it showed that it wasn't over top of a curved surface. It was over a horizontal.
Hello?
How could that have happened hypothetically to keep the assumption the Earth's a globe? It's just objective. If you want to know the truth, you have to put your big boy pants on and be honest about it, right? So like they didn't teach you this in school. There's a reason, right? But this is just very easy to verify. National Geographic covered this, saying what I'm saying to you. Even mainstream knows.
Yeah. Also, when you go to U.S. Military Academy and you want to learn about radar technology, you will be learning electromagnetic waves propagation over flat stationary Earth.
Correct. The military has a ground weapon system.
Yeah.
As a weapon system, they send radio transmissions, a ground weapon system, and the title of the military paper that you can have access to, it's declassified, is Electromagnetic Propagation Over a Flat Earth. And it explains the only way they can adequately acquire target acquirement, is assuming a horizontal propagation over a horizontal plane, and they use it, and it costs millions of dollars to produce it.
Yeah. I have not read that report, so I can't really speak on it. But I can say that this comes back to using what models for which purposes. So let's say, for instance, that this is a hypothetical explanation of why they might have used a model of a flat Earth for radio propagation. So let's say that the calculations needed to calculate this effect on a spherical Earth are more complex. They need to account for curvature, so we need to use.
What happened to Occam's razor?
No, it's very simple what happened. If they shot the waves assuming that the Earth was a globe, they couldn't hit their target. So they had to create a viable model to shoot and hit their target, because we're talking about the military, that people's lives are at stake. You have to get the bad guy. We're not talking about I want to play games and make up stories. This is like real life. And so they have to assume that for it to work, and it's explained in the document. They have to assume the Earth's a dielectric plane. Dielectric is just a word that means electrostatic. The Earth is intrinsically electrostatic, and it's a plane within a magnetic field, and it's horizontal. They have to assume that to use the weapon system that they do use on a regular basis. And this is they are dropping the document for you. If they're not, I will.
Okay, I'll look at it later. Thank you for that.
As a student physicist, you also have to know about electromagnetic waves reflection. What happens when light is being reflected by solid matter or liquid? How does it reflect? When it's reflecting off an object, will it have the same lumen intensity? It will carry all that lumen intensity infinitely, or we have light attenuation, light inverse square law?
That's a good question. Yeah. So when light does reflect off materials, of atoms, two things can happen, or two kind of thing happens. Either the light reflects elastically, just bounces back off like a perfectly elastic marble, which really
that's how we try to imagine it at atomic level. But in reality, what we see is that when you have light reflecting from a solid object, when you shine light on a wall, every light beam wave that hits that wall will be reflecting at infinite angles, all the angles, not just like that certain ray beam. Like when you shoot a laser beam into a wall, you see the laser, a straight line, and it doesn't reflect at the same angle, opposite angle, backwards. You will see only a very bright dot on the wall, and it's very much like the light source itself, the laser, but it will not shine to you in your eye the same kind of laser beam coming from the laser device.
Yes, that's true, and I can give you.
It will be diffused.
Yes, that's the word. That's the word.
Yeah, it's not a beam anymore.
All right, bro. But just because I did take it away from Eli, and like he's asking the most important question, I wanted you to realize that it sounds like a crazy thing to take in. We get it. We thought the same thing. Everyone has different amounts of times they can even be honest about it. You find out, well, what would be different if it were flat and not moving? And then you look at everything else in life and you realize that literally nothing else would change because that's how everything you've ever experienced your entire life is. And you see the sun move in the sky because it moves in the sky. And you don't feel like you're moving because you're not moving. And the horizon is horizontal because it's horizontal. That's why it's horizontal. Sea level is called sea level and assumed to be flat because it's flat and level. That's why it's called sea level. And you will find out quickly that everything that works in the real world has to assume this and utilize this fact. And we're trying to break it down for you. You're going to have to look into things because it sounds crazy. And we were all taught that I did.
And, you know, even on the globe, the down vectors are divergent from the center. Yeah. On the surface of the globe, the down vector is convergent to the center.
Yeah, like if you want to know the truth.
This means, go ahead.
Well, Eli was telling you the most accurate way, most efficient way to know the truth. They claim the Earth's a globe. It has a radius of 3,959 miles. It's on a 23.4 degree tilted axis. It spins 1,037 miles per hour east at the equator. If you want to know if that's true, then you can physically measure the surface of the Earth. It has to curve at a rate consistent with that radius value. That is 8 inches per mile squared, specifically 1.225 times the square root of the observer's height in feet is where you would see the curve of the Earth. Now, I'm not trying to overload you. I'm just trying to explain to you. It's very simple. The Earth's a sphere with a certain size is a geometric claim. The way that you can test or falsify this claim is by physically measuring the surface, and geometry is how you do that. When we did that, and you can do it, it falsifies the radius, which means everything they told you about the Earth cannot be the truth.
Yeah.
Well, I'll take a look at the geometry of that later. Okay,
You
thanks for
agree that geometry is how you measure shapes.
Yeah, I think using geometry in this case is a valid method of saying what will happen and what is, well, yes.
Well, it's what we have to use, right? Because if the Earth's a sphere that's this size, you're making a shape claim with a size. The only way to test a shape claim size is by the measurement of shapes, which is defined as geometry. And it's simple. The sphere has to curve at a certain rate if it's a sphere with a certain size. So that's the most efficient way to test it. We tested it, bro. We have observations where the radius value would have to be over 250,000 miles. And they claim that it's 3,959 miles.
Did you post your methodology in the what was it in the videos in the section about some of the topics below?
Yeah, everything we're talking about is in the sections below, and we can drop in the voice text the observation that showed the radius would have to be over 250,000 miles.
Oh, good. Thanks. I'll look at that later. Let me just write it down.
Don't want to drop the like. I never use commands or anything. I'm modded, but literally never use it.
A black swan. What about modern technology like linear encoders?
I'm not familiar with those. What are they?
You don't know what they are?
I've not yet come across them in linear encoder.
Linear encoders is like a ruler, yeah. We use in mechatronics, yeah, for precision positioning and repeated motion, which you want to be happening between 2 points very precisely, yeah, like CNC machines, computer numerical commands controlled.
Continue.
Yeah. So there is a company manufacturing linear encoders. It is a band strip, yeah, and on these band strips you have very, very thin lines, yeah, just like on a ruler. You have those millimeters or inches gradations, you know, and at equal distance. But these band strips has these lines like a few picometers in thickness and a few picometers apart from each other, but symmetrically apart from each other because it's a ruler, you know. And they are laser engraved. So when you look at it, it does look like the surface of a CD. You can see it looks like a rainbow, you know. It refracts light.
Oh yeah. That's a very cool effect. Yeah, go on.
Yeah. Now, there is a optical laser device, yeah, which shines a beam on that strip, yeah, and there is a sensor which counts all those strips, you know, and this way the machine can tell you precisely how far it has traveled, yeah, and it's coming back. Now, this linear encoder is 200 meters long, and its precision tolerance is 65 nanometers. So I send this machine moving in a straight line 200 meters far away, I give it command to come back, and I give then command to go back far away again in the same location with a precision of 65 nanometers. As a physicist, I am 100% sure that you are very well aware how much is 1 nanometer.
Yeah, it's not a very small amount. Very small.
Yeah, 65 nanometers is a high grade precision. This kind of small size, we use it in computer microchips, like many computer microchips and smartphones. Inside their chips, they have technology of 60 nanometers. Yeah, 80, 120. Like before 2010, vast majority of computers were above 100 nanometers. So those cables, those wirings inside between the transistors and stuff, they were 100 nanometers in thickness. We're talking very small sizes. And you see, according to the Earth's ball radius, 3,959 miles, when you convert that to metric units, in 100 meters, you are supposed to have about 7.8 millimeters curvature drop, according to the overall globe curvature. Now, now, this is not really a problem for us, which, I mean, we can build flat surfaces, because that's what these people actually did at Airbus. They built a very big building, 200 meters long, and the floor is perfect flat from one end to another. It's a plane, very precisely measured. So they installed this 3D printing machine, which is laying carbon fiber, and it's printing large structures of carbon fiber for aerospace industry. And the precision grade in printing those carbon fiber structures, they are laying down micron size carbon fiber, and align it in all their chosen patterns, so they achieve the best structural resistance according to the way you are laying those fibers. Now, this machine, when it's moving from one end to the other, 200 meters, the down vector on the ball is not parallel between two locations, correct?
Yes, but this is a small but.
We have included, like in 100 meters, there is 7.8 millimeters drop. But with our engineering, we built that flat surface. Now, at the start location of the machine, we align this machine, with the down vector to be perpendicular, and it's moving across a flat surface, perfectly straight. And when it's reaching at the other end, after 200 meters, are you trying to say to me that that machine will not be affected by the tilted down vector?
The machine calibrates how many times during its movement? Only once or continuously?
Well, they use actually that encoder, which the machine uses to measure the distance it's traveling, they use that encoder. At both ends, they place two plumb tools, plumb lines. They hang them from the ceiling, with a very thin wire, at both ends, and they are measuring the distance at the bottom, and at the top. And this way, they form a perfect rectangle, So now they know exactly when this machine is tilting or not. And guess what? They found, they weren't searching, but the way they installed this machine, those plumb tools, they were found to be perfectly parallel with 65 nanometers precision in 200 meters. So if there were any change in the angle of the down vector, you would have noticed it in those plumb tools. You will see that they are not parallel. But in building this machine, they use those plumb tools because they are perfectly parallel to each other. So the down vector in location A is parallel with the down vector in location B.
Yes. So, yeah.
So how does this work on the ball?
Well, first let's can I ask what is the precision of those? So you could measure any the difference that is beyond those 65 nanometers of accuracy.
Well, when you travel 200 meters, your margin of error positioning is 65 nanometers.
Mm-hmm.
Yeah, so you are 10 nanometers further or closer,
Yes. Because
those 65 nanometers, you split them by 2, divide them by 2, 32.5, and that is how much that machine will travel further or lesser. 65 nanometers, which if we are measuring the curvature of 7.8 millimeters, with 65 nanometer precision grade, I think you have no clue what you're talking about. How many nanometers are in 7.8 millimeters?
Sorry, how
You
many
can measure it very, very precisely.
Yes. Yeah. I believe you what you saw.
Yeah. So.
Just let me get this straight. So to check if I got it all correctly. In this room, in this hangar, you have a perfectly flat manufactured surface within that precision. Yes. And to measure how the let's say if you have something that's standing on top of this plane, you want to measure what is the angle towards it. Like, is it perfectly 90 degrees above it, or is it at a slant? I assume you have something like that, right?
Sorry, I didn't get you.
Sorry, you mentioned that you have used those two weights on a string to check.
The plumb tools. Plumb tools, yes.
Yeah, and then you compare your, I think it's your printing head to these two calibration devices to see if it's still pointing down perfectly, right?
Well, you see, the machine is moving perpendicularly with the surface of that building, because that building surface is perfect flat. It's built engineered like that. But at the start location, you have the machine calibrated with the downward vector. Yeah, so it stays perpendicular, and the downward vector is also perpendicular with the machine. Now, if the Earth was a globe, when this machine is traveling 200 meters, yeah, on a flat surface, yeah, it's not curved, yeah.
Let's say you do not measure
at the end of that location, because your surface is a straight flat, yeah, at the end of that location, your downward vector will be inclined. So the machine will feel like it will be tilted, you know, because it will not be perpendicular with the machine anymore, because you're moving the machine on a flat surface built on the surface of a sphere, artificially built on the surface of a sphere. And when you have a flat surface on the surface of a sphere, yeah, you can actually choose, let's say we build a flat circle, like a disk, yeah? So we have a radius of 100 meters of a flat surface circle, and we choose that downward vector, which is perpendicular with that surface, will be in the center of that circle. And now, when you move...
Can I interrupt?
Yeah, sure. Go ahead.
Before I got on the train, you know, we were talking about geometry or possibly the lack thereof.
Yeah.
Is all of this conversation in response to maybe a measurement or something he saw, and now he's trying to figure out, like, you know, what laser was used, or like what is that what's going on?
No. I was telling him about... Well, I didn't get to even tell you. You asked me, and then you asked me what the hell I'm talking about.
Okay, why did you change the subject? I'm trying to figure out what was the reason for the topic shift, or am I wrong? And are you like, how did it get here? Because I heard you talking about it. I heard you talking about it in Midtown, right? I had to ride underground, and I was like, okay, I'm not gonna bust his chops because, you know, let's see what happens. So here I am 15, 20 minutes later asking you, how is it relevant to the conversation that was being had before I got on the train, and you're telling me it's not. Is that what you're telling me?
I'm talking about that curvature, non-existing curvature, and divergent downwards vectors, which are
so he's seen a measurement
present on the ball.
So
yeah,
he's seen a measurement?
I told him that this machine is actually doing a very precise measurement between two plumb tools, and they found them that they are perfectly parallel, yeah, in 200 meters distance with a 65 nanometers precision grade.
Okay, well, I apologize.
Yeah, and this would be impossible on a sphere with the down vector converging to the center of that ball. No down vector on a sphere can be parallel with a different down vector from a different position on the surface of that sphere.
Yeah,
that would be like saying you can have a sphere with two parallel radiuses.
Yes, that's a very good question, a very good example of something that can say which model. Okay, it can very well test the assumption that we gave on Earth. Yeah, it's a very good question, a very good model.
Yeah, it's either is there a variation in what would be the proper word? Is there like an elevation change or an altitude change from the point of the observer or the plumb to the next plumb? Like there has to be a change.
No, there is no elevation. Like the surface of that machine, the floor is made perfectly flat and level. So wherever you put a level in that
I
building,
mean the
the bubble
elevation
will
as
point.
in,
Yeah.
I mean the elevation is in the theoretical, like the 8 inches per mile squared. Like from you, the ground would have to be descending away from you on any on any point of the globe. So it's like, for them to be perfectly 90 degrees and parallel to one another, that's impossible on a curving surface. That's not possible. It's not even about shape at that point. It's about whether or not it's the sphere or not.
But the interesting thing is that he mentioned that the surface is made to be flat, in those 200 meters are flat, right?
Yes, yes.
So there's not much. Well, yeah. So the thing is, on a
Degree zero curvature.
Yes, on that plane there will be zero change in elevation. I'm saying very, very well flat. And you are right. If this was a globe Earth model, would predict that two vectors, those two plums, there will be an angle between them.
Yes.
Now, this is the $1 million question: is could we measure this difference?
Well,
you mentioned that you have
we
like those.
can measure. You see, when I said this linear encoder is the instrument that actually tells you, the distance when you travel 100 meters. Yeah.
Yes.
And it tells you went in a straight line or curved line.
Yes. And so the way to a very simple experiment. Let's say I'm going to calculate how much difference, how different the angle between those two plumb should be, assuming assuming that the Earth's 2 point to a center and are not offset by, say, a local mountain or a lake. And then I'll come back with an answer, and we'll see what's the answer. Is it below or above your detection limit? That seems like a good experiment, right?
Yeah. I mean, for 100 meters, the arc curvature should be 7.8 millimeters. So this means that between these two radiuses, you have an angle, which that angle we must be able to measure it. That angle cannot be parallel lines. You can't have an angle between parallel lines.
Yes, you're right. Perfectly.
Yeah. This is the problem. Yeah.
Did you? Can you provide a link to your calculation that shows that the difference? I would love to look at it. If you
This
at hand or later.
This one, I tell you honestly, I'm looking into building my own CNC machine. I was looking for linear encoders. I'm a flat earther. And I came across this company that's producing these linear encoders, and I started reading about them. And I saw that they supply Airbus with these linear encoders for their giant 3D printing machine, which are printing carbon fiber structures for the aerospace. And I went into looking how they calibrate that, I read how that 3D printer actually works. You can find it at Airbus. It's not like secret hidden technology or whatever.
Small question: are you confident and sure that this machine does not account for any possible for this difference? Does it say that the answer that it provides is the raw measurement and not some corrected fact number?
Yeah, it was about 1 month ago, or 1.5. And to be honest, I didn't save this website, which now I'm pretty sad about it. No, I should have saved it.
Yes. Yeah. Because if they, let's say that they are in on it and that they want to still perpetuate this, the myth of the globe Earth, then it would be very easy to ask them, does the machine account for this and how?
Well, they were saying, they were not saying about taking into account the Earth's curvature or anything like that. They were talking about installing and calibrating the machine. And they used plumb tools, to precisely position and also to verify the rail tracks, that they are correctly installed, perfectly straight. So when that machine is moving across inside this building, there is no deflection in the down vector or anything. This machine in no position in that building is not perpendicular with the down vector. And on a globe, if this was true, when you build such a big machine, when you move this machine, like 4 or 5 meters tall machine, printing head, and the down vector is tilting, this machine is heavy and will be bending, and it will change the angle which the printing head position will not be correct, precise.
Yes. Yeah, that's also a factor in this.
Yeah, and what I read there is that they built it on a perfect flat surface, a building with a flat floor inside, 200 meters long and about, 20 or 40 meters, 20, 30. It's huge building. They have airplanes inside there. And Airbus, does build very big airplanes.
All right. Well, that seems like something I can try and work out the specifics of, the numbers.
Yeah.
And then I'll be back because it's frankly getting a bit late around here. So I thank you all for having me here, and I'll be back. Simply put, goodbye.
Bye.
Yeah, but I respect my family. I could do that, but I do think he does need to do some research. The only thing that I wanted to offer him was a simple Google search of platform habitat. Like, it's literally just an oil rig that's always in the same spot off of the coast of California. It's not that hard. So all you have to do is find the video that we're also referring you to and kind of put 2 and 2 together on your own. But there's nothing nefarious going on. Sorry, that's just not the case.
Right. Platform habitat, is that the name of the oil rig?
Yeah.
Okay.
I really think he's trying to find out.
I think so too.
Well,
everything's where it's supposed to be, okay? The shoreline's where it's supposed to be. The guy's camera where it's supposed to be. The oil rig is where it's supposed to be. The only thing that's not where it's supposed to be is the geometric horizon that you guys claim is obstructing objects from the bottom up, and this is your proof of the globe. That's where it's not supposed to be, brother.
What I'm doing, I'm asking you guys to help me out in scrutinizing this image to the level that I feel qualified to scrutinize it. And I said that I doubt my mind is going to change. But I still want to scrutinize this image.
If you want us to go to the level you're looking for, you're in the wrong server. You need to go to Gems or something like that. Join up with Kosho, Zanuck, Gem, whatever. Get together with all of Red's Rhetoric, whatever. You guys come up with a solution to this, because right now you have a problem.
I have to
And
say,
if you watch
your scientific approach to this is not very scientific. If you say, when presented with new evidence, my mind is unchanged. That's That's not scientific at all.
Well,
yeah, you also made a huge error by saying help me. You said help me understand to the level I'm qualified for. So you're already shooting yourself in the foot.
So what you do, hold on, crypto. Hold on. Yeah, it is crypto, right? What you do, crypto, when you're presented with new evidence, or what you should be doing, is you should scrutinize the evidence, and you should ask yourself, what does this evidence actually say? And if it doesn't say anything, maybe if it actually proves whatever your pre-existing belief was, instead of the conclusion that the person says it does.
Well, you're not actually speaking to the point I made, are you? You're strawmanning me.
No, I am, because I've been presented with evidence, this black swan image, and I'm trying to scrutinize it. I'm trying to say, okay, what does this actually say?
But I'm not caring about that. I'm talking about the bit where you said, "Oh yeah, my mind's not going to change." That is a deeply unscientific approach.
Oh, right. Oh yeah. Well, so because the other thing is, you have to weigh it up against existing evidence as well. So,
Sorry, wrong answer, buddy.
well, it's like
That's not how it works, buddy. You don't get it. You don't seem to follow. When you destroy a logical contingency of a proposition, the proposition is destroyed in its entirety. The body of non-explicit evidence that you seem to appeal to is irrelevant at that point. Once a proposition is defeated of a necessity with a logical contingency, it's done. D-O-N-E, done.
Well, not that.
Yeah.
And can I ask you one thing before you carry on?
There's no rebuttal to what I just said, dude. That's logical contingency of a necessity. There's no rebuttal.
And before you carry on, if you're asserting that there's any evidence for the globe, aka proof, then present it, please.
There's a very certain Wikipedia article that I posted in here a few times, and I don't feel like, and I'm not sure many other people in here feel like going over that again. So, the thing is,
would that be because it couldn't be defined as proof? Is that why? Nobody actually took that bait?
So, okay. In science, if you have a large body of evidence, and for the purpose of this, just at least give me that there is evidence of the globe, even if you don't think there is, just for the purpose of this hypothetical.
So verifiable proof. Let's just define our terms before we carry on.
Yeah.
Because we could be talking different languages here.
Yeah, sure. So if there was a large body of evidence for something, and then someone comes along and they've got their measurement, they've got their evidence, and it completely contradicts whatever the going thing is, that doesn't just completely overturn all of the existing evidence. That what they've done has to be repeated, has to be replicated. Other people have to find similar evidence. And
that clearly was not evidence to begin with. Sorry to cut you off, but that wasn't evidence to begin with.
This is a classic case of a false axiom leads to a false conclusion. Like when you say, "Oh, all of this evidence, check out my evidence, bro." Well, sure. If it was evidence in the first place, then you'd have a point. But of course, when you say, "Give me that they have evidence," well, no, because that would be conceding the argument, and we don't have to do that because the evidence doesn't exist.
All right. Well.
Keep in mind, a stack of inferences, no matter how many you stack on top of each other, may seem to point to a certain correlation or conclusion, and they may seem to be a large body of quote-unquote evidence. However, a single instance of direct evidence that defeats the proposition on a logical contingency automatically destroys that pile of inferences, no matter how big or heavy it may be. It's just the way it works, brother.
So,
in other words, bro, I'll put it as simple as I can. No curvy, no bally.
Okay. Okay, so you made a distinction between inference and direct evidence. So just to kind of help me understand, take for example seeing the sunset more than once. Is this like non-direct evidence? Is it like just...
watching the sun set in the sky and saying the sun appeared to move from the top of my vision down and then appeared to disappear? That's direct evidence of that claim. To then say it's because the Earth is rotating backwards, that's a very different claim. That's an inference.
Okay.
Do you see the difference there? One is what you actually witnessed. The other is an inference from that thing you witnessed.
Yeah,
For
I mean,
example,
you can see that
in the Black Swan photo, the horizon is clearly beyond the oil rigs. That's direct evidence that the horizon is beyond the oil rigs.
This guy Boinkus Maximus over in the lobby chat is somebody who's good with the maths of this all. Could you take over for me here? I'm not a mathematician.
Yeah, just to talk about the inferences. I mean, you can come up with all sorts of crazy inferences. So you could say, I don't know, the sun sets. Yeah, okay. So you observe the sunset. Cool. Why? Oh, it's because there's a giant light bulb in the sky and a giant man that you can't see switched it off. I mean, you can infer that if you want. Like, you haven't observed that. All you've observed is the sun setting.
Yeah.
Yeah.
Yeah, exactly. Yeah, just making explanations for the things that you observe doesn't do anything. It's not helpful. Doesn't tell you anything. There is no reason to believe that the explanations you've come up with are accurate in any way. So this is why scientists don't do that. What they do is
they do.
Well, what they
do all the time.
What they actually do is they make an observation and they ask, okay, what could the explanation for this be? Okay, and they have an answer, and that they think they have a hunch of what the explanation could be, and they go, okay, what would this entail? What if this explanation were true? What other things would be true? What else should I be able to observe? And then they go out and they try and see if those observations.
I don't actually think they do that.
The
But
thing
anyway,
about that is what's interesting about what you said is, okay, they look at something and they try to determine why it's happening. So you're supposed to be proving your position for the globe. And so to assume it's a globe already and then look at the picture and say, well, if I'm on the globe, there must be something that I'm not understanding about this photo. That's kind of backwards, no?
Well, I'm not in this. Okay, I'm not. I don't want to be like engaging in a discussion or an argument or a debate defending the globe. I've done it. I've tried it, and I just don't.
Yeah, that's what you all say.
Yeah. But what I am interested in right now is kind of talking about some of the other tangential issues. So yeah, like
we don't have any issues, and we don't want to conversate with people who don't want to be real about the information that we're presenting. They just want to skip over it. And what did you say your expertise was? What field were you studying? I'm sorry.
I'm studying computer science.
Computer science. Oh,
That's right.
Okay.
Yeah. Well, so there are tangential issues here, like, you know, something you said, like something you said earlier, sticks out to me. Like you asked me to kind of put aside my skepticism, which I found interesting. So, I found that interesting, and I wanted to
because you don't need to have any skepticism when the evidence is clearly presented to you. And wait, you can go and actually look up this information for yourself, so you don't have to be a skeptic about what's being presented to you. The fact that you're unwilling to do that says that, number one, you do not want the information that is being given. Number two, you are willfully ignorant by default. Number three, you are intellectually being dishonest. And number four, you're being disingenuous. So why have a conversation with someone who does not want to look at new information, digest it for themselves, and move forward? Why would we want to invest time in someone who doesn't want to invest time in themselves? So we've presented something from our side, which we've always done. We've been doing it for years. And all we ever get from your side is, well, let's scrutinize the evidence that you've presented. Let's be skeptical about the platforms, the angles, the numbers associated with the evidence you presented. Having never presented any evidence or proofs to back up your claims, this body of work, it gets a little old and very annoying, because when it comes to defending what you say you have a body of evidence of proof for, we find that those things do not hold up, and that's why you don't really want to have a real discussion or defend the globe.
So,
yeah, you find this with majority opinions a lot. When people have got the majority, there's no tactical advantage to them to discuss anything, because the only movement will be losing ground. So you see this a lot with Globers, because they already are the majority opinion. If they can't come in and call us retards and get an easy win, they're not really interested.
DJ, do you have any question for Flat Earth? Any question?
Sorry, did you say DJ?
Yeah, yeah.
You're referring to myself, yes?
Do you have any question for us?
I don't know, really. I'm thinking about it. I mean,
because there's a lot of people they could answer you here, so.
I mean, I've heard that the moon is a light source. Is it?
None of us claim, we don't know what the nature of the moon, that's right, Roger?
I would say it's a light.
I don't know. It's a light.
Yeah, it's a light.
I mean, I've always been told that it's more of a reflector because of the sun bouncing light off it.
That's the issue with the inverse square law, though.
It can't be reflecting light because the inverse square law debunks that idea.
Well, there's multiple things that debunk it. It doesn't have any properties of a ball reflecting light, like a specular highlight. Also, sunlight's hot and moonlight is measurably cold. So you have lots of problems with the reflection theory. Makes much more sense if it's just a light.
Okay, so, but I mean, I'm not trying to prove nor disprove. I just want to bounce some ideas about for myself.
Yeah,
so,
I gotcha.
So, for example, if you have a heat lamp, do you know what these are?
Yeah, like a lava lamp.
No. They're an actual heat lamp. They are specific types of bulbs. They're not made to shoot out light that we use to read. They are made to produce infrared light. We can't really see it very well, but we can feel.
Oh, you mean like what you use to like grow marijuana or warm up baby chicks?
No.
No.
Well, I mean, not that kind of. You find them like around pubs and stuff to keep people warm on the outside.
Oh yeah, but they glow, right? They glow.
Yeah. An equivalent one would be the gas-powered patio heater. It's the outer casing that gets bright red hot. Yeah. Do we know where we're at there?
Yeah. I know.
So if you take one of those types of heat sources and put two pieces of paper in front of it, one's white and one is black, and measure the temperature of each of them. Okay, and they're in the same. They're right next to each other under the same light. The black one warms up faster than the white one. Would that be agreed?
You need us to agree with you that that's what happens.
No, I'm asking, would you agree with that? Is that something that you would agree with?
Sounds reasonable. Yeah, if you wear a black sweater, you're going to get warmer faster than if you wear a white sweater out in the sun.
Okay. Now, so if the sun is giving off every type of wavelength, both what we can and can't see, including the infrared, which we know is warm, we've already stated that, yes, we can feel that. If surfaces only reflect light that they're able to reflect, for example, the black paper cannot reflect infrared. It absorbs it, therefore it warms up, whereas the white paper reflects it, so it stays relatively cooler, but will eventually warm up. If the moon is reflecting light and it can only reflect the light that it can physically reflect, and the rest is absorbed, would that not account for why moonlight feels cold?
Moonlight doesn't feel cold.
Both papers in that scenario are absorbing some of the heat. You can't. Okay, so the white is reflecting. They're both absorbing.
Yes, but one is reflecting more because it's able to absorb more, whereas the white is able to reflect more.
Are either of them reflecting a cold light?
No, they're both been exposed to infrared.
Exactly. So you can't bounce hot light off something and get a cold light. You can't bounce a G note off something and get an A note. You can't put a blue light on something that reflects and get a red light.
Okay.
So the moon cannot be giving off a cold light if it is reflecting hot, yellow, phosphorescent sunlight.
Okay.
But it isn't giving off cold light.
So, well,
yes, I've done the test.
Can I say something real quick? The moon, according to NASA, the moon has the same albedo as asphalt.
What?
Albedo is the reflectivity of the substance.
Okay.
That's according to them. That's what they say.
As asphalt? Wow.
Yes, if it was opaque and not reflective, then it wouldn't illuminate the night sky. You wouldn't be able to walk around clearly and see the floor. It would be not reflecting light. It would be opaque. So it's obviously very bright. You can't say, oh, look, bright moon lights up everything, but it's
Beautiful
opaque
light.
and not reflecting. Come on, guys. It's got to be one or the other. Can't be both.
I don't think. Where is your evidence that Moonlight is called?
Well, you could look up with 200,000 subscribers, the Globehead, Mr. Magnetism Ken Wheeler did it with a FLIR, which is the infrared thermal technology. But I used a laser thermometer to test Moonlight, and it was measurably colder.
What's your channel called?
What?
What's your channel called so I can look it on your channel?
My channel is called Nathan Thompson.
Okay.
I mean,
a lot of people have done that test.
Thousands have done that test. Globeheads have done that test.
Okay, right. Well, no, drugs. It's curious because if I take, say, a magnifying glass then, and I put it in direct sunlight and get the focal point right, then where the focal point touches, say, a piece of paper, and then technically I should be able to make the paper burn if the conditions are right. Yeah.
I'm just sorry. I just want to know how do I find your channel? Like the video that I'm trying to find about the Moonlight.
God, good luck, bro. Have you heard of algorithms? I know what the videos are called, and I can't find my own videos, dude. You got to go do the test yourself. Costs $30 for a laser thermometer.
No, okay, all right. What's
simple to do?
I just like to know. I just want to see your test that you did.
Yeah, it's on my channel.
Yeah, what's it called? What's the name of the video?
One more time. Well, what's the name? I tested the supermoon, cold moonlight. Type supermoon, cold moonlight.
I will Google it for you and bring it to the text chat. So continue on. Yep.
Yeah. Anyone can do this. I posted the video of Mr. Magnetism, Globehead himself, saying, "Look, Globeheads, Moonlight's cold. I'm testing it with my $10,000
I seen a video of you.
thermometer." So
I typed in Nathan Thompson. I just got.
Who was that tested it? The Globehead?
Ken Wheeler, Mr. Magnetism. The video's in the chat. So, Globeheads have done this. Confirm it's cold. I did it. I don't want it to be cold. I don't have some freaking stake in this. I'm not charging $50 million a day. I went and spent $30. Went outside during a supermoon, and it was measurably cold. About 6 degrees.
Object with place under a full moon, pulling the shade out. Gives it time to reach equilibrium.
It's well known too that fires burn faster in the moonlight than they do in the shade, and that's because the heat transfers faster from hot to cold than hot to neutral. So as the moon goes over the fire, it's actually pulling more of the heat from the wood than if it was in the shade. This is well known for centuries.
Well, I mean, is it the moonlight itself that's doing that then?
Or is it the lighting?
Yeah, well, what else would it be?
Well, I mean, bear with me. Like I said with the magnifying glass thing, if you hold the magnifying glass in sunlight on a good day, you can use it to set something on fire like paper. Yes?
Yeah.
Done that.
Magnifying glass with the moon 36 inches in diameter, and we're never able to increase the temperature of a thermometer by 0.1 of a degree.
No. I'm not interested in the temperature going up. I'm more interested, if it is cold light, then wouldn't the opposite be true? You would get a super cold spot.
Yeah, I would assume that, but they did the test, and that's not what happens. So,
I used a magnifying glass in wood at summer camp, and I did artwork using the sun. It was pretty dang cool. It almost burned my leg though at one point. So yeah.
Yeah, I don't know why it doesn't have the same property as the sun as far as heating or cooling more intensely when magnified. Not sure. I haven't figured that out. But like I said, we all said at the beginning, we don't know exactly what the moon is. We can just test its light, observe what it does, know that it's a perfect pattern. Globers will say it's geocentrically locked, gravitationally perfect. Look, we have a bunch of math with 6s, so it's proven. Here you go.
May I ask a request?
How can we only see one side of it then?
Because there is only one side of it. What do you mean?
Tell us.
You tell us, bro. You're the one on a spinning, tilted, wobbly state ball.
Might I make a request?
It's perfectly tidally locked so that it always faces you no matter where you go.
Yeah, I was just about to ask him if he even knew what the explanation was.
It does tilt, but like what? Why? So why do you think you can only see one side of the moon? Because there only is one side.
Just
like one face. I meant one face.
Yeah. You have to assume that there's another side, that it's spherical, that it's rotating in tangent with and relative to the Earth. You're making claims additional to what's observed.
Basically, it's like saying, well, how come inside my house I never see the shackles on the roof?
I love his instrument.
Never went there and looked at it. Still.
Yeah, Nathan, I love his
He's channeling Professor Dave.
You need better role models.
That's really what you're doing. You're channeling Professor Dave's nonsense.
You can channel. I'm not channeling anything. I'm just asking.
Who's Professor? Do you know who Professor Davis?
No, I don't know.
You're lying. You've seen his video because that's what his most recent flat Earth video is. If the Earth was flat, you couldn't see one side of the moon.
I don't know who Professor Davis.
Nathan.
Okay, hear me out on this though.
Look, I've been a flat earther for 4 years. I have never heard that argument until Professor Dave made his video. Okay, and that was recent. And I've heard it 70 times since then. And the refutation is real simple. You don't understand geometry.
Isn't it right though? Surely if it was
no, because it assumes that the moon is a sphere.
Yep, okay, it assumes solidity, sphericity, and it assumes the characteristics of the medium it's in. You should listen, and then once I finish or other people finish, then you respond. That way you understand what's being said to you. You know what I mean?
Okay.
So you're assuming solidity, sphericity, and the characteristics of the medium.
And this is a typical globehead argument where they point at the sky and say, look, we're on a ball. And you're like, no, dude, you can't point at the sky and tell me what the characteristics of the floor are. So, I'm curious.
Yeah, you
Mr. Moonman, have you ever done any observations on the Earth, not the sky, but the Earth, to determine Earth curve?
Mine, yep. Hang on.
I can tell you're lying because when you're lying, stutter. You heard that song?
System shut down.
When you say stutter, it doesn't mean I'm stuttering. I'm just wondering how come.
We all heard it. Okay, so I just need a clear and concise answer. It's a yes or no. Have you left your mom's basement and tested for Earth curve? Yes or no?
Yes.
Excellent. Where'd you go?
I went to one hemisphere, looked in the other hemisphere, and I seen stars rotating.
No, you didn't. You're such a.
You went back to the sky again. Yes!
And he's lying. Wait, where exactly did you go? Wait, where exactly in the hemispheres did you go?
I live in England.
Who cares? You point
okay, where'd you go? How did you go to the other hemisphere?
Have you ever gone to your mom's basement, left your mom's basement, and looked at the floor? He goes, yeah, I went to one hemisphere, I looked at the sky, and then I went to another hemisphere.
No, you said.
Hey, where'd you go? Hey, my friend, Nathan asked you if you ever tested the Earth, and then you pointed to the sky
again
and said that the stars move.
Guys, real quick, he said that he went to. He said that he went to one hemisphere and saw the other hemisphere.
Yes,
that's amazing.
No, what I said was that's not what I said.
Man, the stars move differently. Yeah, okay, here's the deal, man. Every single star in the sky. No, you need to listen, buddy. You need to listen, buddy. You need to listen, buddy. Hey, kid. Listen.
I don't care.
Every star. Hey, kid. Hey, child. Listen. Every star in the sky moves east to west. You lose.
Yes, it does. But how come when I go to a different hemisphere?
Perception.
How do you know you're in a different hemisphere?
Laughing? Hey, what's the difference in cardinal directions and relative directions of counterclockwise and clockwise? Are those the same thing?
No, they're not.
No, you're right. One's relative to perception and one's an absolute direction.
So how come
sit down, please.
When I go to a different place on the planet, how come I can see different stars rotating?
Just explain that.
Yeah, you're not listening. This is why I told you to listen.
No,
okay?
And you're trying to assume. Hold on, let me say something. You're trying to assume.
I'm not assuming anything. I'm telling you what I've observed. I'm not assuming anything.
You're about to get muted. You're about to get muted. So stop interrupting
You didn't observe a planet.
No, because he's saying I'm assuming things and I'm not. So
You are. You didn't observe a planet and you didn't observe hemispheres. So just stop.
No,
You didn't observe
listen to what I'm saying.
Commander.
What I
That's
said
what you're trying
was
to-
no. What I said was I said I've been to another hemisphere, another part. I've been.
How do you know?
Yeah, you're lying.
How do you know it was a different hemisphere?
Because Australia is Australia.
How did you prove the sphere part?
Right? How could I not be able to see stars?
How did you prove the sphere part? How did you prove the sphere part? That's what I want to know. You're assuming that you're on a sphere in the first place to say I went in another hemisphere. That's what you're trying to prove.
So the
You're trying to prove it's a sphere.
Does the equator not exist on a?
No, it does.
That's an arbitrary idea.
It's a concept. You can't go somewhere and point at the equator.
Okay, fine. How come I can see different stars in different?
Okay, now I'm explaining it one more time. I'm explaining it one more time, my friend. Okay. All the stars in the sky, they move east to west. Now your perception. Stop interrupting me.
I'm just trying to understand.
Now I need you to listen, my friend. Well, you're not going to understand it if you don't shut up and listen.
You can't learn while you're talking. That's impossible. So just listen.
Okay, so every single star, man, moves east to west. All of them. Now, when you change your location, your perception changed relative to your location. You can't see forever, and the way you view the sky alters relative to where you're located on the Earth. But all the stars move the same direction, east to west. So there's a difference in cardinal directions and clockwise and counterclockwise. Those are relative directions due to perception.
Yeah, this is very simple to observe, not Commander. All you have to do is go to a Walmart and look up, and then walk to the other side of the Walmart and look up. If you don't see the same thing, it doesn't prove you're on a ball. It just proves that you moved laterally under a location.
No, I'm saying I can see completely different stars.
Yeah, you would see completely different lights above your head.
Go to a bigger Walmart then.
If you look up.
Is your question why we can't see forever? Is that your question?
No, it's not the question. I'm just saying.
Yeah, your question is why can't we see all the stars? So if there
that wasn't my question.
Why can't I see all the boats? Why can't I see all the airplanes?
You just said that you see some stars that we don't see other places. So your question is why don't we see all the stars everywhere? Thus, okay, what's your question?
That is my question. You just said it.
Okay, I'm saying that means your question's basically why can't you see forever?
No, that's not.
So you just don't understand. You're not equipped for this conversation. You are inept.
No, you're misinterpreting.
You're inept.
You can call me inept all you want.
You don't understand both sides, not Commander. The reason that we can't see all the stars on a flat Earth is
I never asked that. I never asked why can't we see all the stars.
Okay. Well, the reason
I'm asking
we can travel laterally.
Why when I look in one direction, I can on one place on the Earth, I can see a lot of stars. When I'm in the other place, I can see a completely different set. If I was on,
that's because you moved.
If I was on a flat plane, if I was on a
because you moved.
No,
you moved.
Let me finish. If I was on a flat plane and I looked up at the sky, I'd be able to see stars, right?
Wrong.
That's wrong.
Wrong. It's another point at the sky, pretend Earth's a ball argument. I already asked if you've ever tested Earth's surface. Now we're
And I said yes. And I said yes.
Yeah,
hey, let me ask him
about the stars.
If the Earth is flat, okay, which it is. If the Earth is flat, should we be able to see all the stars in the sky at the same time everywhere we go?
No.
Okay, so what are you even talking about?
I'm not saying can we see all the stars. I'm saying.
Obviously, we would have to move laterally to see different stars.
Right.
You're
if
done.
I was on a flat
You're
plane,
done.
if I was
You're
on,
like a 3-year-old playing a sandbox with this little shovel right now.
If I was on a flat plane, if I'm on a,
you are.
I look up at the stars.
Yeah, so you would have to.
No, I'm not saying. Again, you're getting it twisted. I'm not saying. No, you clearly not, because that's not what I'm saying.
If you think the stars prove the Earth's a ball, you are literally not equipped for this conversation. We just broke it down to you in elementary, rudimentary terms. That's why you have to keep interrupting me. You know why you have to? Hey! You know why you have to interrupt, bro? Because you're afraid to hear your worldview be dismantled in live time. But that doesn't matter. That's not how adults behave. If you want to have an intellectual conversation, you need to listen. We've already explained it to you. And we're not going to keep doing it. At least I'm not. I did come in a little hot. I had a bit of a conversation before I came in here. But anyway, what I'm saying is, dude, look, you can't see forever. You have a limit of perception relative to your location. That is the answer. It's very simple. We can replicate this and show that is the truth. So please stop looping your misunderstanding.
I'm not. I don't. Again, you're getting me mixed up. You're getting what I'm saying mixed up. You're saying.
All right, now, Commander, we're going to give you one more chance to tell us what you're saying.
Listen.
Go
okay, I have, and all times you're going. You keep misinterpreting. What I'm saying is, if I was on a flat plane, and I looked up at the sky and seen the stars, I'd be able to see a bunch of stars. I'd be able to see some stars.
That's why you do it every time you know it in nighttime. You see a bunch of stars.
Let him finish.
But however, if I go to another place and I was on a flat plane, I'd be able to look up and I'd be able to see the same stars.
Wrong! For the 20th time, you can't see all the stars because you reach a limit of perspective.
Yep.
Okay.
Reach an angular resolution limit. Also, we are in a medium, so if you look at star trails, they're being forced towards the horizon. So star trails aren't perfect circles. They actually make little egg shapes. So the atmosphere is actually pulling the stars away from your perspective, away from your ability to view them. So not only are you getting further away, they are then you can't see them because of perspective. Now you have to include a medium, which is another interference. So you already said, if you're on a flat Earth, you look up, see a bunch of stars. You do. And then you change location, look up and see. The fact is we have 88 constellations since the beginning of time. You're aware of constellations, right?
Yeah.
Yeah, the sky is a map and a clock. It's been that way from the beginning of time. That's why they've been doing astroarchaeology. Are you familiar with the pyramids?
Yes.
All right, great.
Familiar.
A lot of ancient megalithic structures line up to the sky to this day. So you can pretend they were all stupid and we live on a ball in space because you went to schoolsies, but we all went to schoolsies too. Then we went outside, tested the shape of the Earth, and it's not a ball. And I asked you if you've gone out and tested the shape of the Earth, and you said, yes, I looked at stars.
You have been listening to excerpts from the 24/7 Flat Earth Discord Live YouTube channel. If you would like to join the discussion, simply type in your address bar discord.gg/flatearth. Thanks so much for listening.
What actually brings you here?
What actually brings me here is the idea of trying to understand different perspectives. I'm not saying that I believe one way or another, but I want to see the evidence that would want me to go this direction.
Okay, so your question would be... Sorry, I was just going to say, your question would be, what's the evidence for the Earth being flat? But I'm sure Crypto's got something.
100%. What is the evidence that shows the Earth is flat instead of being round?
That's the wrong question. The right question is what? Okay, well let me give you a really good question. What's the best base axiom to start from when pursuing knowledge on this subject?
Place of non-biased.
Okay, so that's actually impossible. But let's go with that. So
I mean, that's the best place.
No, but there's no human is capable of being unbiased. That's just not possible.
I know.
Regardless, okay. But let me just take him to.
You're gonna prove with a non-biased axiom anyway.
Let me just take him to the start. And then we can move from there. Okay, so what would you say? How do you interact with the world?
I perform my daily activities and duties while trying to better my position in the social.
Yes.
I'm not sure how to answer that question.
Okay, so would you say that you see things?
Yes, of course.
Okay, and do you hear things?
Yes, of course.
Okay, so you know I'm going with this. Would you say, therefore, you use your senses in order to interact with the environment that you currently exist in?
100%.
Perfect. Okay, so when you use your senses,
may I just ask who you are? Because I actually really like the way you're approaching this.
Okay, I'm Crypto.
Okay.
Yeah. Okay. So when you use your senses, do you detect any motion within your environment?
Yes.
Okay. What motion do you detect?
I have a fan on right now, so I detect the movement of air.
Okay, fine. So not fan. I'm talking about of the environment.
Is
the environment itself moving?
Oh, I mean, technically, yeah, because I'm in an enclosed capsule in my house, so yeah, the air is moving, and I've felt like earthquakes and stuff. Yeah.
Okay,
and
so
like hurricanes and
we're not
the
talking about
ocean.
earthquakes. We're talking about the entire Earth moving from point A to point B. Can you detect?
Oh, do I feel the Earth moving from point A to point B? No.
Yes. Okay. So, would you say that that's a good base axiom to start from, that the Earth isn't moving?
I'm not sure. The reason why is like when I fly on a plane, right? I feel the vibrations of the plane, but I don't feel myself moving from point A to point B.
Okay, but that's not. I'm not talking about planes.
No, I'm just saying, like, I'm extrapolating your idea. It's like, I don't feel the Earth moving. No, not at all.
Okay, fine.
But, like,
I'm not saying that that's evidence of anything. I'm not saying it's evidence of anything. What I'm saying is that we're talking about axioms, not evidence, right?
Can you define axioms for me?
I mean, I could give you my own personal definition, but it's probably better to give you the dictionary definition. So, I mean, an axiom is
something that is self-evident.
Yeah, so assumed to be self-evident. Now, if we just make sure statement representing
water's level.
Yeah, fair enough. Close enough. So as an axiom, I would suggest that the Earth isn't moving because I don't detect any movement. Right, my senses are pretty good at detecting movement. I know that because I've travelled in cars, travelled in planes, travelled in trains, and I always know I'm moving. Right, so
can I just ask a question about the planes? Because this is a point that I want to develop and just understand, right? Like the plane, I don't feel the air moving, right? When I look out the window and I'm over the ocean, I don't see anything moving, right? I don't feel as though I'm going 500 miles an hour. So,
are you telling me when you're in a plane you don't see things moving underneath you?
Over the ocean, like when I'm over the ocean in the night sky, flying from Philly to Portugal. Right? And it's a cloudless night. There's no reference, or if it's just black outside, there's no reference to.
But that's because there's no reference.
Right. That's so I'm saying, like, right, so in that,
moving.
Right, but I don't feel myself moving. Like that's what I'm trying to say.
I've travelled in plane for 15 years. I always feel myself moving in a plane. Okay. It blows my mind when people say they can't feel the movement in a plane.
Yeah, that's just ridiculous. If you stand up on a plane even at night time and you are to walk from the back of the plane to the front, opposed to walking from the front to the back, you will feel a difference in the inertia.
And also, you're actually in a container. So, that's probably one of the main reasons you don't feel it as much.
Okay, but we're just establishing axioms at the moment, right? So let's stay with the axiom and then we can go forward. Because I never say that this is like full evidence of anything. It's just where you start from. So for me, it's pretty obvious that you start from the fact that the Earth isn't moving, and if you find evidence to the contrary, then you can consider it. You can say, is this true? Is this false? You can look at it later, right? So for me, it's self-evident that the Earth doesn't move, and for me, it's self-evident that there is no curvature anywhere. Now,
why is it self-evident?
Well, because I've never seen the Earth curve.
Okay.
So we start from that basis.
Unless you've seen the Earth curve.
So if we're starting from the basis of the Earth doesn't move and it doesn't curve, who has to bring the evidence to the contrary?
I don't know who would have to bring the evidence.
The person making a claim counter to the axiom. Right? So, where is your evidence that the Earth is in fact moving?
Horrible.
The evidence would be the seasons.
No.
Why would that be evidence of the Earth moving?
Well, because what it's showing is that as the Earth travels around the sun.
Hold on. Before you start telling us a story, right? Before you start working your presuppositions of the Earth being a ball at a distance from the sun, and it orbited around the sun in this place called space. And because of the tilt of this ball, this is why we've got seasons. Because of all of those presuppositions, we're just down here on the Earth with base axioms. The Earth isn't moving yet. We're trying to find that movement. You're saying seasons. Now, what would you say causes the seasons, things to be hot and cold? would that be the light source and heat source in the sky that seems to spend longer in areas where it's hotter and not as long in areas where it's colder for seasons? So being as it appears that the sun is moving, I mean, unless we can prove the Earth is, as at the moment just standing here on the flat stationary Earth, isn't it easier to understand that it's probably the sun that's causing it to be hotter and colder?
Yeah, it is the sun that's causing it to be, well, in the model that I believe currently, or as I understand it.
That's a lot better. I appreciate that.
It's the distance that is the distance between Earth and the sun. So the sun is always producing the same amount of energy, but it's a distance. Yeah. So it seems like you and I are saying the same thing, but we have different models.
Yeah, so the sun is still closer for those areas on the flat stationary Earth for the summer, and it is further away from those areas of winter. And that depends on the sun moving between its northern path, the Tropic of Cancer, and southernmost path in the Tropic of Capricorn. And when it rebounds between these two areas throughout the year, you get your seasonal cycle, not just your day and night, but your seasons too. But standing here on it's not proof that the Earth is moving, because we can just point to the sun and saying the sun's causing that to happen.
So, like, what you're saying is, if the equator is the midline, right?
Yeah, for the sun.
What?
For the sun, yeah.
You're saying that in your model, the sun will move a few degrees above or a few degrees below the equator in terms of the angle to change the seasons.
Inwards across the plane of the Earth towards the north, towards the Tropic of Cancer for the summer season in the north, and then winter in the south. 3 months later then for 3 months it travels south and hits the equator, and then 3 months more, so a total of 6 months later, it reaches the Tropic of Capricorn in the south, giving summer to the south and winter to the north because of the sun's proximity. It is closer.
And that's what you observe in the sky as well. So going back to trusting our senses and base axioms, we see the sun move. We don't see or feel the Earth move. So why assume that the Earth's moving and the sun's staying still? It's literally the opposite of what you actually see.
I have trouble believing that exact thing, because like the what immediately popped in my head as you said that is that, like, if there's two cars moving together at the same speed, it may not look like they're moving because they're not separating from one another. If one car starts to drive faster, even though both cars are going a certain speed, one car increases its velocity, then it looks like only one car is moving, even though both cars are moving.
Yeah, but that's one frame of reference. What if you look up, though, away from those two cars that are next to each other, you're going to see that they are in fact in motion. Your senses, your internal equilibrium is going to tell you, your balance equilibrium is going to tell you you are in motion. You don't just rely on one frame of reference and one sense for one thing.
Yeah, and to be fair, I didn't just say that you only saw the sun move, you also do not see or feel the Earth move. So to assume that all of those things are the opposite is frankly absurd.
So, based on your analogy, you're basically standing on a parked car, watching another car drive by you.
Yeah,
and assuming that your car is moving and the other one's still.
Exactly.
So, when you start pointing... Sorry, go on. No, you're fine, buddy.
Real quick, the point being is that say the two of us have lived in a cave our whole life, and we just go outside for the very first time, and we both observe the sun and the stars and the moon going from east to west every day. And I say, oh, well, that's because we're stationary and everything's moving around us. Look, see? You could say, well, no, it's because, we're moving, everything else is stationary. One of the two of those things could be right. We understand what you're saying. Now, we say it's self-evident that we're just literally standing here doing nothing. We don't observe any motion. or we don't detect any motion, and we see that it's observed flat. Then you say that's because we're a giant sphere and we're spinning 1,000 miles an hour and going 100,000 miles an hour in this direction and 100 million miles an hour in this other direction, and all of these you're making all of these other claims based on the same exact observation, and you don't have any data to back up your claim other than, well, that's just what we were all taught in school. We say it's self-evident that it's flat and not rotating because it's not. We don't observe it to be. If you say that there are these movements and motions, it's up to you to prove that. Yeah? Does that make sense?
And I'd like to add as well that you said that you're going to look at this from a non-biased view. And the reason it's impossible is because as soon as you're coming up with things that contradict what you see and experience in real life, you're immediately going to the indoctrination that you already know. That, oh, well, I see two trains moving. That don't mean we're moving. Or, oh, the seasons of the summer. They're still creeping in. These answers are still creeping in. You need to look at it solely from what you see, what you experience, and what you can tell. Only things that you're going to change your mind at is the education that you've been given. For example, I look at the sun, I look at the moon. They look about the same distance away from each other. From me, sorry. But the only reason I believe the sun is 93 million miles away is because I've been taught that. So if somebody said to me, without me being taught that, how far is the moon? How far is the sun? I'd say it's probably about as far as the moon, because that's what my senses tell me. My senses don't tell me it's 93 million miles away.
Right. It's the same. Like if you say that you make all these claims, and then the obvious axiom of well, if we're spinning 1,000 miles an hour, why don't we fly off in all directions? Well, because there's this thing, gravity. Oh, well, can you show it to us? Well, I can't demonstrate it, but it's happening. Okay, cool. So, but we're definitely curving. Well, I can't really show it to you because it's too big, but believe me, it is. Okay, but we are spinning. Well, I can't really show it to you because it's all relative, but trust me, it is. Okay, you're 0 for 3, and these are things that. Do you see the pattern that emerges here, or do you see how, especially when you said you can't be biased, like you said? Do you see the problem?
I never said that. I am capable.
No, you said let's look at it in a non-biased fashion.
I'm looking at it.
No, he said that was his aim. To be fair, yeah. I don't think he was saying that he was unbiased. I think he was just aiming to be unbiased. So, yeah. To be fair, I don't think he meant what you said.
Yeah, he didn't. Yeah, you're right.
No, I just meant one thing we have to look at it. Yeah, I hear you, but yeah.
Let's I'll bring it back.
Yes. Oh, fuck's sake! I think give me a. Oh yeah, that's it. I had a thought the other day, and I've been dwelling on it more and more. And obviously, when we say gravity, right? So gravity is things falling down, right?
Yeah.
I was asking the other guy.
Oh, okay.
It's the yellow guy. Is he there?
Yeah. Okay. Sure. Yeah.
Yeah. Okay. So gravity things falling down. So explain the helium balloons.
It's a gas much lighter than the surrounding atmosphere, and it's concealed in a container.
So is gravity involved there as well?
Yes.
Okay, so gravity's involved when things go up and when things go down. When the moon goes across the sky, what's happening there?
The moon, in my model, is in a homeostasis relationship with the Earth. And
caused by what?
It is traveling around the Earth and has centrifugal force, but is also being pulled into the Earth by Earth's gravitational pull, which has locked it in a stationary orbit.
And you witness all this.
No, okay, but let me finish my point. So this is the thing that I came to the other day, and I don't know why it never occurred to me. But gravity is responsible for things going up, going down, going left, and going right. How can one cause have 4 different effects?
Oh, gravity. Gravity doesn't really have to do with anything going.
Just snap the wand
up. Because what I was trying to say is that if something is going up, gravity is still a force, but the force projection is not pointing up; it's still pointing down. So the helium balloon.
But do you understand though that you're not observing any pull? You're not observing. So you say, okay, so gravity is a downwards force, as we're told. I know that's not even the current rhetoric. Whatever. That's what most people understand. understand. Yeah, when things go up, that's also gravity. When things go to the left, that's gravity. When things go to the right, that's gravity. Can I finish? Let me finish. Can you not see how this is like a guy who hasn't done his homework, and the teacher's like, "Where's your homework?" And he's like, "The dog ate it." And it's like, okay, that was the excuse yesterday. That was the excuse the day before. It's just an ad hoc explanation. It doesn't actually mean anything.
More complicated. They don't tell you that it's actually, more complicated.
I mean, I think that's why they do it at such a young age too, when your brains are still like sculpting and you're learning. So you could tell a kid anything and they'll believe it.
Well, they actually don't believe the globe when they're told it. According to like studies they've done, the kids actually, because for a kid this isn't a problem, the kids actually will believe that the Earth is flat when they go to kindergarten. They get told the Earth's a globe, but they still believe that the Earth is flat, and that it only is a globe when you go into outer space. Right? It's only a globe if you go away, but when you're on the ground, it's flat. See, they don't have like ideas about geometry, right? So like we do, that's like things can't be two things at the same time. But to a child, that's totally possible. So they just think it's two things at the same time.
Yeah, I mean, it's definitely. I think they know they're doing it at the right age. At least they probably. I don't know. Do you think they've thought about what age should we start like really forcing this, like science classes?
Man, they've started that crap. Go have a baby and go try and buy a mural or a mobile. You know how many you got dinosaurs or planets or whatever. Anyway, what I really wanted to say to you is I wouldn't worry about believing the Earth is flat or a globe. I would worry about how you approach the problem. Because if you approach it in the right way, with the right critical thinking, appropriate for the question that's being answered, then you're going to lead yourself to the right answer regardless.
Right, yeah. I mean, end of the day, we want truth. We don't necessarily saying, okay, we want this versus this.
Yeah, well, I think like this. Okay, what is the significance of the question I'm asking, and what level of proof or evidence would satisfy that for the level of importance? So, to me, what the shape of the Earth is an existential question. It'll define how you think of the world, because it tells you, like, there's a globe, I'm this, and, this is the meaning of my life. If it's flat, it's this, and this is the meaning of my life. So it's, if it's concave, you know what I mean? It's where you live. It's your cosmology. It's your existence. How you think you fit into the scheme of things.
So what do you...
Well, let me continue. That's a pretty important question, right? You think? Because it kind of guides your...
Definitely. I mean, that's
pictures of space do not meet my burden of proof for the importance of that question. You see what I'm saying?
Yeah.
Imagine if they there's a time machine and they go back to Aristotle and they just flash them a picture and like, look, this is where you live. You think Aristotle or Plato or anybody would have been like, oh man, fuck this philosophy stuff. I'm going with the picture. No, they're not going to do that, right? They're going to be like, yeah, that's interesting. I'm going to try and incorporate that into my, my philosophical knowledge. They're going to just say, ooh, a picture, let's drop everything. And that's how I look at it. I'm not just looking at a picture and drop everything. I want actual proof. And if I can't get the proof, so be it. Then I just don't know everything. Then I don't know where I live. And I can be satisfied with that. But I'd rather not know than believe something that's not true. Or might be true, or might possibly be true.
Yeah, I mean, it's funny you mentioned the picture thing. I was thinking that, I mean, it's so easy to manipulate and edit photos nowadays that it's like, I really don't get why anyone just kind of assume. I don't know. It's very enlightening to be. I mean, I feel like I got introduced to it late, but at least now I know that. Now at least I'm aware of all of this.
Yeah, they've been faking photos since the beginning of photography. I think the first fake image, well, famous one, is from 1851 of Abraham Lincoln. Yeah, so they've been doing this a long time.
You have been listening to excerpts from the 24/7 Flat Earth Discord Live YouTube channel. If you would like to join the discussion, simply type in your address bar discord.gg/flatearth. Thanks so much for listening.
flat Earth has long been denigrated, derided, and disparaged as being the most crackpot of all conspiracy theories, marginalized, mocked, and ridiculed for centuries as being an ignorant, ancient, unscientific worldview. But the facts of the matter are far from what you have been told. When thoroughly examined and diligently researched with an open mind, any skeptical, critical thinker will find it is actually the tilting, wobbling, spinning spaceball Earth promoted by NASA and taught in schools that is truly ridiculous and unscientific. The following are 20 ways anyone can prove for themselves that Earth is a level, stationary plane. 1. Common sense. It cannot be overstated or overemphasized. The most important thing to realize, and most obvious way to know you are not spinning on a ball, is your own common sense and lived experience. You have always, and will always, experience yourself as living right side up on a motionless Earth, with the sun, moon, and stars revolving over and around you. This is common sense, and what everyone in the world personally experiences every day of their lives. We are taught to believe otherwise, however, many things completely contrary to our own common sense and experience from a very early age. We are told that people living down under the spinning ball Earth in Australia are actually living upside down relative to those residing in the northern hemisphere, while an invisible force, strong enough to hold people, buildings, and oceans stuck to the underside of a rapidly rotating ball, but weak enough to allow birds, bugs, and planes to take off and fly with ease, keeps Earth's atmosphere spinning in perfect balance, and holds everyone firmly to the surface without crushing us. We can clearly see that the horizon is horizontal, but we are told it curves. We can feel that the Earth under our feet is motionless, but we are told it moves. We can observe the luminaries revolving around us, but we are told it is us that revolves. It is obvious that stars are stars, but we are told that stars are suns. We can see the sun is bigger than the stars, but we are told stars are bigger than the sun. We can see the sun and moon are the same size, but we are told the sun is 400 times larger. It is obvious that up is up and down is down, but we are told there is no such thing. As stated by flat Earth author David Wardlaw Scott, with the modern astronomer there is theoretically neither up nor down, though his experience belies his assertion every time he looks up to the heavens or down to the ground. Such aberration of intellect is really to be pitied. The 3rd century philosopher Lactantius was similarly perturbed about the idea, stating, "A sphere where people on the other side live with their feet above their heads, where rain, snow, and hail fall upwards, where trees and crops grow upside down, and the sky is lower than the ground? The ancient wonder of the hanging gardens of Babylon dwindle into nothing in comparison to the fields, seas, towns, and mountains that pagan philosophers believed to be hanging from the earth without support. Truly, the idea that people are standing, ships are sailing, and planes are flying upside down on certain parts of Earth, while others are tilted at 90 degrees and all other impossible angles, is utter absurdity and an affront to common sense. In fact, common sense is the first casualty of globe belief. No child or unindoctrinated man would ever conclude or even conceive, if given to their own devices, based on their own personal observations, that Earth was a spinning ball revolving around the sun. When children are indoctrinated from a very early age to abandon their common sense and lived experience of a geocentric plain Earth in favor of this nonsensical, heliocentric globe model taught in schools, a schism occurs in their psyche. No longer can they trust their own senses and experience, and instead must trust information completely contrary to it, taught by supposed experts and authority figures who insist their version of reality is correct. When children see that every adult around them believes wholeheartedly in the spinning globe, and hear that only our ignorant, unscientific ancestors believed otherwise, They readily abandon the empirical evidence of their senses and adopt the prevailing nonsensical model. As stated by flat Earth author E. Eschini, the one thing the fable of the revolving Earth has done, it has shown the terrible power of a lie. A lie has the power to make a man a mental slave, so that he dares not back the evidence of his own senses, to deny the plain and obvious movement of the sun he sees before him. When he feels himself standing on an earth utterly devoid of motion, at the suggestion of someone else, he is prepared to accept that he is spinning furiously round. When he sees a bird flying and gaining over the ground, he is prepared to believe that the ground is really traveling a great number of times faster than the bird. And finally, in order to uphold the imagination of a madman, he is prepared to accuse his maker of forming him a sensiferous lie. 2. Fake photographs. One of the main reasons the average person believes the world is a globe is because of the globular Earth images and video footage provided by NASA and other space agencies. Hundreds of such pictures and thousands of videos featuring a globe Earth are freely available on the internet, yet most people never critically examine them with a skeptical eye. From the earliest photographs to the latest live streams, NASA and the world's other space agencies continue to be exposed for their Hollywood-style trickery. When conscientiously compared, contrasted, and investigated for inconsistencies, it turns out every single image and video showing a globular Earth has been manipulated in some way. All globe videos, for example, are achieved using either a fisheye lens to curve the horizon or created completely through CGI technology. One clear instance of the latter is NASA's 1990 time-lapse video of Earth supposedly filmed by their Galileo space telescope from 1.3 million miles away. This video features the Earth globe spinning in space uncut for 25 hours and shows the exact same clouds present without ever dissipating, changing shape or location the entire time. In reality, if you watch clouds in the sky for several minutes, three things will inevitably happen. The clouds will all move, some will morph, gradually changing shape, and others will dissipate and disappear completely. In NASA's official footage of the spinning ball Earth, however, the entire world's cloud cover doesn't dissipate, morph, or move for 25 hours, which is, of course, impossible, and proof of fakery. A good example of fisheye lens fakery is the famous 2012 GoPro Red Bull jump, where skydiver Felix Baumgartner was lifted to a record-breaking 128,000 feet in a stratospheric balloon, then jumped back to Earth. 7 GoPro cameras on the outside of the craft, and strapped to Felix himself, recorded the entire ascent and descent. Astute observers will notice that from ground level all the way up to the 24-mile apex, the horizon is significantly curved and remains equally so for the entire ascent. This is because the curve is artificial and being caused by the GoPro camera's standard-issue fisheye lens. Once Felix reaches his peak altitude and the door of his craft opens, an inside camera mounted behind him without a fisheye lens reveals the truth, showing a perfectly flat horizon still at eye level, 128,000 feet high. As for the hundreds of supposed photographs available of the globe, NASA readily admits that these are composite images and not actual photographs. They claim the composites are made by taking strips of data sent from satellites, spliced together in Photoshop, and colorized for the final creation. NASA's senior program analyst and lead data visualizer, Robert Simon, admitted in an interview that they are photoshopped because they have to be. When compared side by side and viewed with a discerning eye, the inconsistencies become obvious. The coloration of the land and oceans and relative size of the continents drastically changes between images, and they often feature far too little land mass for 50% of a globe. Several of NASA's blue marble Earth images have repeat instances of exact cloud patterns clearly copied and pasted into place. Computer enhancements done on Earth images taken during the Apollo missions also show similar photo trickery. When hues are removed from the black backgrounds and brightness enhanced, distinct rectangular artifacts appear around the globe where they were pasted in, again proving them to be doctored composites. Furthermore, when NASA's Earth pictures are compared with those from the Russians, Chinese, and other space agencies, the differences become evident, and the fact that they are all simply Photoshop images becomes obvious. If NASA and the world space agencies could provide real, legitimate photographs and videos of a globe, they most certainly would. So the fact that they continue producing and pumping out nothing but fisheye fakery and CGI cartoons is strong evidence that Earth is not what they claim. 3. Water. The natural physics of water are that once contained and undisturbed, the surface will always remain horizontal. This fundamental physical property of water is why it has been used as a leveling tool by builders and engineers for millennia. Whether in a bucket, bathtub, pond, lake, or an ocean, the surface of water at rest always remains flat and doesn't have the ability to show convexity or any shape whatsoever upon its surface. This fact is easily demonstrable and empirically verifiable, but completely at odds with what we are told about the globe. For Earth to be globular and over 70% covered in water, the oceans must be somehow curving around and sticking to all sides of a rapidly spinning ball suspended in space. It is simply impossible to make water behave this way. As anyone can experiment for themselves, bodies of water will not stick to the underside of a ball and cannot show convexity or any other shape upon their surface. Globe defenders will often point to water droplets, meniscus, surface tension, or adhesion, claiming these are examples of water bending or sticking to a surface, which is nothing but a fallacy of false equivalency, as these only happen at a very small scale, the size of a coffee cup. The claim is entire oceans wrapping around and sticking to the underside of a spinning ball, not a water droplet or the meniscus in a glass filled to the brim. NASA has also recently taken to faking CGI water balls using augmented virtual reality technology in an attempt to convince the public that water can behave this way. This kind of demonstration, done in a reference frame inaccessible to 99.99% of the population, however, is unrepeatable by the world's scientists and skeptics, and is therefore not scientific or permissible as proof of anything. First, they claim only massive objects the size of Earth have this attractive property. Then, as evidence, they show a phenomenon allegedly outside of our earthly reference frame. In other words, they are claiming bodies of water can bend around, stick to a ball, and show curvature upon their surface, but only at a scale too big for the public to recreate. Then they are claiming water can ball up and float suspended in air, but only in a reference frame too far for the public to recreate. As for water level, globe defenders have actually attempted to completely redefine the term level just to fit with their dogma. The true definition of level is a flat horizontal plane with no deviation in elevation along its surface. Water always reliably seeks and maintains its own level, and that is why it has been used in spirit levels and construction projects from time immemorial to create perfectly horizontal structures, no matter their size. Globe zealots, however, unsatisfied with this obvious truth and clear definition, have attempted to redefine level to instead mean curved. Their globe-friendly version of level means equal heights around a ball when measured from a central point. The fact of the matter is, however, that nobody has ever reached this hypothetical center point of the hypothetical Earth globe, so their redefined term cannot be tested or falsified. Until that day, rest assured there is good reason we call it sea level and not sea curve. 4. The horizon. The horizon is always perfectly horizontal, 360 degrees around the observer, regardless of altitude. If Earth was actually a globe, no matter how large, as an observer ascended, the horizon would remain fixed in position and fall below the observer the higher climbed. In reality, all amateur balloon, rocket, plane, and drone footage filmed without a fisheye lens at maximum altitudes of over 20 miles high, show a completely flat horizon still rising to eye level. Only in NASA and other space agency footage does the horizon ever curve or appear below the observer's eye level. In the heliocentric model, the horizon is claimed to be the physical curvature of their globe, and the reason boats receding from a shore-bound observer disappear from view. This was actually one of the original alleged globe-Earth proofs presented by Aristotle and still parroted by believers today. But by using modern zoom technology, we now know that the horizon is not the physical curvature of a globe, and those boats can be zoomed back into full view. This is because the horizon is not an objective physical phenomenon at all, but rather a subjective optical phenomenon based on an individual observer's perspective. If the horizon was actually the objective physical curvature of a globe, then objects receding beyond it could not be zoomed back into view, and it would remain fixed as an observer ascended. In reality, however, the horizon rises along with the observer no matter how high, and modern zoom technology can bring objects receding beyond it back into full view. This proves the horizon line is not some objective point of curvature on a convex Earth, but rather the subjective vanishing line of perspective from a given observer's point of view. Quoting Earth Not a Globe by Dr. Samuel Robotham, on the shore near Waterloo, a few miles to the north of Liverpool, a good telescope was fixed at an elevation of 6 feet above the water. It was directed to a large steamer, just leaving the River Mersey and sailing out to Dublin. Gradually the masthead of the receding vessel came nearer to the horizon, until, at length, after more than 4 hours had elapsed, it disappeared. The ordinary rate of sailing of the Dublin steamers was fully 8 miles an hour, so that the vessel would be at least 32 miles distant when the masthead came to the horizon. The 6 feet of elevation of the telescope would require 3 miles to be deducted for convexity, which would leave 29 miles, the square of which, multiplied by 8 inches, gives 560 feet, deducting 80 feet for the height of the main mast, and we find that, according to the doctrine of rotundity, the masthead of the outward-bound steamer should have been 480 feet below the horizon. Many other experiments of this kind have been made upon sea-going steamers, and always with results entirely incompatible with the theory that the Earth is a globe. 5. Gyroscopes. Gyroscopes are precision instruments consisting of a wheel mounted inside 2 or 3 gimbals, which provide pivoting support and allow the wheel to rotate about a single axis. As the entire contraption moves and shifts angles, the gimbals move and shift accordingly, but the inner wheel never changes its angle with respect to its initial reference frame. This unique property is called rigidity in space, meaning the inner wheel maintains its orientation and axis of rotation in relation to space and not to the surface of the Earth. This means that the base of a gyroscope set in motion, with its axis in a vertical position, then placed on a table for 6 hours, should rotate 90 degrees with the spinning globe Earth. As the globe turns under the gyroscope for 6 hours, the axis should slowly turn from vertical to horizontal. This experiment has been tested many times with several full-length videos available online, and never does the gyroscope's vertical axis shift whatsoever. If the heliocentric model were true, not only would the gyroscope detect the alleged 1,000-mile-per-hour spin of the globe, but also the 67,000-mile-per-hour revolution around the Sun, the entire solar system's 500,000-mile-per-hour spiral around the Milky Way galaxy, and the entire galaxy's multi-million-mile-per-hour journey through the universe. Since these hypothetical motions never register on precision gyroscopes, it is clear that they, just like the spinning ball Earth they're based on, do not exist. Gyroscopes are also the technology behind inertial guidance systems and airplane artificial horizon indicators. When military jets are performing loops, barrel rolls, and other dogfighting maneuvers, the artificial horizon allows pilots to easily see their exact orientation relative to Earth without having to rely on looking out the window. If Earth was truly a sphere, by simply flying level, airplane artificial horizon indicators should show a steady decline unless pilots constantly correct their altitudes downwards so as not to fly straight off into so-called outer space. For example, a pilot traveling 500 miles per hour over a globe Earth 24,900 miles in circumference would have to descend an average of 2,777 feet, or over half a mile per minute. Otherwise, in 1 hour's time, the plane would be 31.5 miles higher than desired. In fact, if Earth was really a ball, there should be no reason to use rockets for flying into outer space, because simply flying an airplane straight at any altitude for long enough would already inevitably send you there. 6. Compasses. The mariner's compass is another precision instrument which can only work on a level plane Earth, and is an impossible and nonsensical tool for use on a globe. It simultaneously points north and south over a flat surface, and must be held flat to work, yet claims to be pinpointing two constantly moving geomagnetic poles at opposite ends of a spinning sphere originating from a hypothetical molten metal core. If compass needles were actually drawn to the North Pole of a globe, the opposing south needle would actually be pointing up and off into outer space. Likewise, observers holding a compass in Antarctica would be at the bottom of the ball, so to show north, the needle would have to point down at their feet. If the so-called South Pole in Antarctica were truly the southern pole of a magnet, observers would be able to walk in a circle with their backs to the South Pole and have their compass needles show north being in front of them in every direction. This feat has never and will never be achieved because the so-called South Pole is simply an arbitrary point along the Antarctic ice marked with a red and white barbershop pole and topped with a little metal ball earth. The actual type of magnetism present on Earth is similar to a ring magnet found in loudspeakers, which have a central North Pole, with the opposite South Pole being all points along the outer circumference. This perfectly describes the magnetism of our flat Earth, whereas the alleged source of magnetism in the globe model is emitted from a hypothetical molten magnetic core in the center of the ball, which they claim conveniently causes both poles to constantly move and thus forever evade independent verification at their two ceremonial poles. 7. Plain sailing. Ship captains in navigating great distances at sea never need to factor the supposed curvature of the Earth into their calculations. Both plain sailing and great circle sailing, the most popular navigation methods, use plane, not spherical trigonometry, making all mathematical calculations on the assumption that the Earth is perfectly flat. If the Earth were in fact a sphere, such an errant assumption would lead to constantly glaring inaccuracies. Plain sailing has worked perfectly fine in both theory and practice for thousands of years, and plane trigonometry has time and again proven more accurate than spherical trigonometry in determining distances across the oceans. It is so commonly used at sea, Navigation in Theory and Practice states that, in practice, scarcely any other rules are used but those derived from plain sailing. The great and serious objection to plain sailing is that longitude cannot be found by it accurately, although in practice it is more frequently found by it than any other method. So both latitude and longitude are found most often and most accurately by assuming Earth to be flat, more accurately even than assuming the Earth to be spherical. Quoting 100 Proofs Earth is Not a Globe by William Carpenter, "If the Earth were a globe, a small model globe would be the very best, because the truest, thing for the navigator to take to sea with him. But such a thing as that is not known. With such a toy as a guide, the mariner would wreck his ship of a certainty. This is a proof that Earth is not a globe." 8. Construction. Surveyors, engineers, architects, and builders are never required to factor the supposed curvature of the Earth into their projects. Plumb bobs are used to establish plumb vertical datums, with spirit levels then used to establish horizontal datums and lay flat foundations across great expanses. If Earth was actually a globe of given proportions, builders would find themselves constantly deviating from both their established vertical and horizontal datum lines. But in reality, canals, railways, bridges, tunnels, and other large projects are always cut and laid horizontally, often over hundreds of miles, without any allowance for curvature, and no deviation from established datums. As stated by surveyor T. Westwood in Earth Review magazine, quote, "In leveling, I work from ordnance marks, or canal levels, to get the height above sea level. The puzzle to me used to be that over several miles, each level was and is treated throughout its whole length as the same level from end to end, not the least allowance being made for curvature." The Suez Canal, which connects the Mediterranean Sea with the Gulf of Suez on the Red Sea, is one clear proof of both the Earth's and water's non-convexity. The canal is 100 miles long and without any locks, so the water within is an uninterrupted continuation of the Mediterranean Sea to the Red Sea. When it was constructed, the Earth's supposed curvature was not taken into account. It was dug along a horizontal datum line 26 feet below sea level, passing through several lakes from one sea to the other, with the datum line and the water's surface running perfectly parallel over the 100 miles. Another good example is the Dunyang Kunshan Bridge, the longest bridge in the world, just over 102 miles long, which runs parallel to the Yangtze River and connects the Shanghai and Nanjing provinces. This bridge is approximately the same length as the Suez Canal, and was also built without factoring the alleged curvature of the Earth. If Earth was actually a globe 24,900 miles in circumference, spherical trigonometry dictates that the center of both the Suez Canal and the Dunyang Kunshan Bridge would bulge over 1,666 feet higher than either end. Engineer W. Winkler was published in the Earth Review regarding the Earth's supposed curvature, stating, "As an engineer of many years' standing, I saw that this absurd allowance is only permitted in school books. No engineer would dream of allowing anything of the kind. I have projected many miles of railways and many more of canals, and the allowance has not even been thought of, much less allowed for. This allowance for curvature means this, that it is 8 inches for the first mile of a canal, and increasing at the ratio by the square of the distance in miles. Thus a small navigable canal for boats, say 30 miles long, will have, by the above rule, an allowance for curvature of 600 feet. Think of that, and then please credit engineers as not being quite such fools. Nothing of the sort is allowed. We no more think of allowing 600 feet for a line of 30 miles of railway or canal than of wasting our time trying to square the circle. Railroads are another example of large-scale construction projects spanning hundreds or even thousands of miles, working from an established datum line and without deviating for the entire length. The Manchester Ship Canal Company, in an official statement published in Earth Review magazine, confirmed, quote, "It is customary in railway and canal constructions for all levels to be referred to a datum which is nominally horizontal, and is so shown on all sections. It is not the practice in laying out public works to make allowances for the curvature of the Earth." As an example, the London and North Western Railway forms a straight line 180 miles long between London and Liverpool. The railroad's highest point, midway at Birmingham Station, is only 240 feet above sea level. But if Earth was actually a globe of given proportions, the 180-mile stretch of rail would form an arc with its center point at Birmingham raising over a mile, a full 5,400 feet above London and Liverpool. A surveyor and engineer of 30 years, published in the Birmingham Weekly Mercury, stated, "I am thoroughly acquainted with the theory and practice of civil engineering. However bigoted some of our professors may be in the theory of surveying according to the prescribed rules, yet it is well known amongst us that such theoretical measurements are incapable of any practical illustration. All our locomotives, are designed to run on what may be regarded as true levels, or flats. There are, of course, partial inclines or gradients here and there, but they are always accurately defined and must be carefully traversed. But anything approaching to 8 inches in the mile, increasing as the square of the distance, could not be worked by any engine that was ever yet constructed. Taking one station with another all over England and Scotland, it may be stated that all the platforms are on the same relative level. The distance between eastern and western coasts of England may be set down as 300 miles. If the prescribed curvature was indeed as represented, the central stations at Rugby or Warwick ought to be close upon 3 miles higher than a chord drawn from the two extremities. If such was the case, there is not a driver or stoker within the kingdom that would be found to take charge of the train. We can only laugh at those of your readers who seriously give us credit for such venturesome exploits as running trains round spherical curves. Horizontal curves on levels are dangerous enough. Vertical curves would be 1,000 times worse, and with our rolling stock constructed as at present, physically impossible. 9. Long-distance photography. We are consistently able to observe objects at incredibly long distances, far beyond what would be possible if Earth was actually a globe of given proportions. By inputting the observer height and distance viewed into an Earth curvature calculator, it is easy to check how much a target should be obstructed on a globe Earth. For example, it is often possible to see the Chicago skyline from sea level 60 miles away across Lake Michigan. In 2015, after photographer Joshua Nowicki photographed this phenomenon, several news channels quickly claimed his picture to be a superior mirage, an atmospheric anomaly caused by temperature inversion. While these certainly do occur, the skyline in question was facing right side up and clearly seen, unlike a hazy, illusory mirage, and on a ball Earth 24,900 miles in circumference should be a full 2,400 feet below the horizon. In Genoa, Italy, from only 70 feet above sea level, on clear days it is possible to see the distant islands of Elba, Gorgona, Caprea, and Corsica, which are 81, 99, 102, and 125 miles away. If Earth was truly a globe of given proportions, all 4 islands could never be visible for such an observer, and would be hidden behind 3,300, 5,200, 5,600, and 8,700 feet of curved water. From Anchorage, Alaska, at an elevation of 102 feet, on clear days, both Mount Foraker and Mount McKinley can be seen in their entirety, standing straight from base to summit with the naked eye from 120 and 130 miles away, respectively. If Earth was really a ball of given circumference, both mountains should be leaning back away from the observer, with the lower half of each mountain completely obstructed from view. Based on verifiable curvature calculations, 7,719 feet of Mount Foraker's 17,400-foot summit and 9,220 feet of Mount McKinley's 20,320-foot summit should be hidden behind a giant bulge of curved globular Earth. The current record-breaking longest-distance zoom photograph recently captured Pic Gaspard from Pic de Finestrelles, a whopping 275 miles away, with an observer height of approximately 9,000 feet, from which, based on correct curvature calculations, the entire 12,740-foot mountain should be invisible behind nearly 6 miles of curved Earth. Even more recently, flat earthers like J. Tolan Media have been filming using infrared zoom cameras at high altitudes to capture lakes, mountains, and other landmarks up to an incredible 1,000 miles away. If Earth was really a globe the size we are told, many of the landmarks photographed would be hidden behind upwards of 70 miles of curved Earth. 10. Lighthouses. The distance from which various lighthouse lights around the world are visible at sea also far exceeds what could be found on a globe of given proportions. For example, the Dunkirk light in southern France, at an altitude of 194 feet, is visible from a boat 10 feet above sea level, 28 miles away. Spherical trigonometry dictates that if Earth was a globe with the given curvature rate, this light should be hidden 190 feet below the horizon. The Port Nicholson light in New Zealand is 420 feet above sea level and visible from 35 miles away, where it should be 220 feet below the horizon. The Agero light in Norway is 154 feet above high water and visible from 28 statute miles, where it should be 230 feet below the horizon. The light at Madras on the Esplanade is 132 feet high and visible from 28 miles away, where it should be 250 feet below the line of sight. The Cordonin light on the west coast of France is 207 feet high and visible from 31 miles away, where it should be 280 feet below the line of sight. The light at Cape Bonavista, Newfoundland, is 150 feet above sea level and visible at 35 miles, where it should be 491 feet below the horizon. The lighthouse steeple of St. Botolph's Parish Church in Boston is 290 feet tall and visible from over 40 miles away, where it should be hidden a full 800 feet below the horizon. The Isle of Wight lighthouse in England is 180 feet high and can be seen up to 42 miles away, a distance at which modern astronomers say the light should fall 996 feet below the line of sight. The Cape Legulas lighthouse in South Africa is 33 feet high, 238 feet above sea level, and can be seen for over 50 miles. If the world was a globe, this light would fall 1,400 feet below an observer's line of sight. And finally, the lighthouse at Port Said, Egypt, at an elevation of only 60 feet, has been seen an astonishing 58 miles away, where according to modern astronomy, it should be 2,182 feet below the line of sight. 11. Impossible atmosphere. If Earth was truly a globe, constantly spinning eastwards at over 1,000 miles per hour, it stands to reason that helicopters and hot air balloons should be able to simply hover over the surface of the Earth and wait for their destinations to come to them. For example, during the Red Bull Stratosphere dive, Felix Baumgartner, spending 3 hours ascending over New Mexico, should have landed 2,500 miles west into the Pacific Ocean, but instead actually landed a few dozen miles east of the takeoff point. Likewise, vertically fired cannonballs and other projectiles should fall significantly due west on an eastward spinning ball. In actual fact, however, whenever this has been tested, vertically fired cannonballs shoot upwards an average of 14 seconds ascending, 14 seconds descending, and fall back to the ground no more than 2 feet away from the cannon, sometimes directly back into the muzzle. To account for this problem, globe defenders claim that gravity somehow magically and inexplicably drags the entire lower atmosphere of the Earth in perfect synchronization up to some undetermined height, where this progressively faster and faster spinning atmosphere gives way to the non-spinning, non-gravitized, non-atmosphere of supposed infinite vacuum space. NASA refuses to answer at what altitude this impossible feat allegedly happens, but the effect such a transition would have on a craft traversing it would be disastrous. It is also scientifically refuted by the simple fact that vacuums cannot exist connected to non-vacuums while maintaining the properties of a vacuum. As anyone who has punctured an aerosol can knows, two adjacent pressure systems, not separated by some kind of barrier or membrane, will equilibrate. If gravity magically dragged the atmosphere along with the spinning ball Earth, that would mean the atmosphere at the poles would be spinning at 0 miles per hour, while over the mid-latitudes it would be spinning around 500 miles per hour, and gradually faster until reaching the equator, where Earth and the atmosphere would be spinning together at over 1,000 miles per hour. Not only would this gravitized atmosphere increase speed from poles to the equator, but would also necessarily progressively increase speed the higher the altitude. In reality, however, the atmosphere at every point on Earth is equally unaffected by this alleged force, as it has never been measured and is proven non-existent by the ability of airplanes to fly unabated in any direction without experiencing any such atmospheric changes. Landing airplanes on such fast-moving runways, facing all manner of directions, north, south, east, west, and otherwise, would also be practically impossible. Not to mention rain, fireworks, birds, bugs, clouds, smoke, balloons, and projectiles would all behave very differently if the Earth and its atmosphere were constantly spinning. Tests were conducted in the 19th century with cannons facing each of the cardinal directions, which proved Earth and its atmosphere are not spinning. If they were, then north and south-facing cannons would establish a control, while east-firing cannonballs should fall significantly farther than all others, while west-firing cannonballs should fall significantly closer. In actual fact, however, regardless of which direction cannons are fired, the distance covered is always the same. Common sense tells us if Earth and its atmosphere were constantly spinning eastwards over 1,000 miles per hour, this should somewhere, somehow, be seen, heard, felt, or measured by someone, yet no one in history has ever experienced this alleged eastward motion. Meanwhile, however, we can hear, feel, and experimentally measure even the slightest westward breeze. Furthermore, clouds, wind, and weather patterns casually and unpredictably meander every which way, with clouds often traveling in opposing directions at varying altitudes simultaneously. This is altogether incompatible with the theory of a rapidly rotating Earth and atmosphere. 12. Flight times. If Earth and its atmosphere were constantly spinning eastwards over 1,000 miles per hour at the equator, then the average commercial airliner, traveling 500 miles per hour, should never be able to reach its eastward destinations before they come speeding up from behind. Likewise, westward destinations should be arrived at thrice the speed, but this is not the case. In reality, the differences between eastbound and westbound flight durations usually amount to a matter of minutes, and nothing near what would occur on a spinning globe. As Gabrielle Henriette stated in her book Heaven and Earth, if flying had been invented at the time of Copernicus, there is no doubt that he would have soon realized that his contention regarding the rotation of the Earth was wrong, on account of the relation existing between the speed of an aircraft and that of the Earth's rotation. If the Earth rotates, as it is said, at 1,000 miles an hour, and a plane flies in the same direction at only 500 miles, it is obvious that its place of destination will be farther removed every minute. On the other hand, if flying took place in the direction opposite to that of the rotation, a distance of 1,500 miles would be covered in 1 hour, instead of 500, since the speed of the rotation is to be added to that of the plane. It could also be pointed out that such a flying speed of 1,000 miles an hour, which is supposed to be that of the Earth's rotation, has recently been achieved, so that an aircraft flying at this rate in the same direction as that of the rotation could not cover any ground at all. It would remain suspended in mid-air over the spot from which it took off.
there. Oh, I gotta go. I gotta go see. Fine. Where the atmosphere is too weak to support the winged. Hold on. Where do you paste? Just stop a bit. Literally replied. Okay. He said he went beyond the Kármán line where the atmosphere is too weak to support winged flight. That's developed at the United Nations. That's an arbitrary place where they're just going to. Outer space is where the aerodynamic control surface is no longer depending on how shitty of an airplane you make, right? So my car is in space because it can't steer based upon, the aerodynamics of the car. So if I'm like falling out of an airplane, I'm in space no matter what control where I'm going. It won't produce lift. Which is why we have a political destination where they just say 300 setback here is the real when you respond that's fake to everything I say. This is difficult for me, I know, right? With search the word fake, I couldn't. How many times fake? Isn't it like up to 56? I've been looking like a week. 56,000. That would be crazy. Halt chanting. Now we're at 30. Thank God. Let's figure out Earth to the sphere. 7,000 mathematicians.
I just realized my mic was off. Hey!
There he is. Hey, talking about the.
Yep, I'm the guy.
Did you hear what I said about the definitions?
I just joined.
Okay, okay. So the Kármán line is a political designation from the U.S. Above here is what we're going to call space. It's nothing to do with anything other than a bunch of. That's the Kármán line. The scientific definition is when the aerodynamic control surface, but that applies to anything. So applies to you, me, I slip. It's just the definition of space. And this is what I looked up, and this is what it says. It's not my opinion, it's their opinion.
One way of looking at it.
Yeah. Like if you clap your arms to fly to the moon, right? It's not going to happen. If the air was a lot thicker, right? You probably could. Like if it was like a signal, you could produce lift. If the
Good night, boys.
Good night.
Good night, sir.
The description.
I'm sorry, my mic is. Ow, why is it? Okay, hold on, wait. I'm sorry.
Yeah, it is.
Yeah.
I can only talk, but I cannot hear.
Alright.
Okay.